Okay, we're at the Museum of Developer Art, and I'm standing here with Alex, who actually curated the pieces we're about to take a look at. Alex, can you tell me a little bit about why you chose these pieces for a developer festival?
So the two artists that are here, Ezra Miller and Vincent Jose, are both developers themselves and artists. And so their work is really about using code to create beautiful natural simulations. Vincent creates fluid dynamics that are interactive, which is a very hard thing to do. And Ezra creates data visualizations that are essentially transforming into flocking starlings. Yeah.
And why these pieces at this festival?
So I wanted to find artists that could understand the sort of developer mentality and communicate to developers and show that by using developer tools, you can still create really beautiful work. So that's really the main reason.
Awesome. Well, we were looking at them earlier, and that really comes through. Thank you so much.
Thank you.
I'm standing here with Vincent in front of his art. Now, I have a few questions. It's amazing, and I really need to know more. But first, can you tell me just a little bit about this piece? Your process making it, what you used, and what it represents to you?
So, this piece is called Fluid Structure. It's an exploration of how liquid-like shape form kind of deforms and react under various forces and stimuli. So I've been fascinated for a long time by fluid dynamics, because it's like you see it everywhere in nature, like stream, rivers, smoke, volcanoes, and it's all this incredible variety of motion, very intricate. And historically it's been very computationally expensive, but now recent progress makes it possible to do the simulation real time, and that makes it very exciting for me to build interactive piece using this technology. Also to explore all kind of different how it's going to react, playing with different forces, and what happens if we slow the time down or make it really fast. And I think it seems familiar and both mysterious, because we're kind of used to how things react to physics laws. So I think one of the challenge for this piece was the scale and making it interactive for a large number of people. So it's using 5 different Kinects, which is a depth sensor that can tell me in space where the people are, and it's computing forces based on where people stand to push the liquid around, so that most people who are not always familiar with sensors and interactive installation would get it. There's little hints, you're gonna see your silhouette, and some modes where the water falls on you is easier to get your interaction and how you influence the result. And I think, and watching the people tonight, so it was a premiere for me as well to I tested with a few friends, but it's what are people gonna do and how they're gonna react, and a lot of people are really getting into it, and that's pretty amazing to see that.
Okay, so one more thing is that the size of this is massive. I don't know what your studio space looks like, but I presume you did some prototyping that wasn't this big before. How did you kind of conceptualize a piece this large?
So I was lucky I could prototype a smaller slice.
Okay.
And then I used VR and Oculus to kind of
Really?
get a feel for the scale of the piece, which I had done in the past for other art installations, which were also pretty big scale. And I'm based in New York, and so large space is kind of a rare thing to get.
Yeah.
So VR for me is it's really useful to get a sense of scale. And the other thing is that since everything is running real time, I have like a number of parameters I can adjust quickly once I see the piece for the first time on site at scale, which I did tonight. So I slowed down something and like tweak some timings to make it like better. So that's the two way I worked on this scale.
Awesome. Well, thank you so much for sharing your art with us.
Yeah, you're welcome. Thanks. It's great to be here and like have this opportunity, and thanks to Alex for curating this medium of developer art.
Thank you. Okay, now we're looking at the second piece, and this one is by Ezra. Ezra, could you tell us a little bit about this?
Yeah, so what we have here is my piece Data Memoration, which I built using WebGL. So it's just running in the browser. And it's a flocking simulation as well as a data visualization.
So one of the things that I noticed about the piece is that you definitely have something to say about the really clear data that shows up every once in a while on this graph, but then it breaks out all these data points into this flocking behavior. Like, what brought you to that artistic choice?
Right, so yeah, it oscillates between this sort of like formless cloud of birds swarming and then this really well-defined graph. I think to me it's sort of trying to get at questions about whether humanity can organize itself as we face a lot of problems as a society. And I think the difference between this like formless swirling cloud and that get at that idea. I don't know.
All right, man. Hey, let's talk a little bit more about the tech since we're at the developer conference. You said this is in the browser?
Yeah, so I make websites using WebGL. This was built with 3JS, which is a pretty, like the go-to WebGL library, and I use it out in all of my work pretty much. And it's built using shaders, which are programs that run on a computer's GPU that let you do computations a lot faster than on the CPU. And it's basically creating everything procedurally, which means there's no real image textures being used or any other real assets. I think the main asset is the data, and then everything sort of comes from that. So.
And I also noticed in addition to the flocking, there's this almost waterfall effect. What is that?
Right. I actually added that in like right recently before we set up. I think it just adds a little more dynamism to the background. Kind of cuts through the clouds, and it's a feedback loop process, which is something I use in all of my work pretty much. Yeah, I just thought it looked...
Leave it at that mystery.
Yeah.
I like that. All right, Ezra, thank you so much for sharing your work with us today.
Thanks, man. I really appreciate it.
Wow. All right, so I'm here at the VR Drive-In, and I'm standing with Sarah, who actually helped build the experiences that attendees are going through right now. Can you tell me a little bit about what they're experiencing?
Yeah, so we're Google Spotlight Stories, and we are creating content that directors create their own stories in this medium. So we have Pearl by Patrick Osborne, which was nominated for an Academy Award this year for Best Animated Short Film, and we have the Gorillaz' newest music video, which is a first music video for our group.
Now, you worked with the production teams and the artists in building these experiences, right?
Yes, yes.
What's that like? Do they have all sorts of questions? Like, what's different from a normal production experience?
Yeah, it's definitely a new medium for most people, but both took to it very well. So you have to think about creating a film in 360 space a little bit differently than you would a normal 2D narrative film. So you have to make it interesting in all directions, if you will.
Very cool. Sarah, thanks so much for joining us.
Thank you.
Don't be scared of what's to come. It's all for you. How did you forget? It's all for you.
This has got to be the largest foosball table I have ever seen. Look at this thing. Coming to you live from the World Championships of Pair Ping Pong here at Google I/O. I'm just kidding, we're having fun. All right, there's probably something I could say, but honestly, this is just mini golf. So I'm gonna go have some fun. What am I doing here?
All right, so it's a 360 video booth that records high frame slow motion. So anything that you do looks cool, it's gonna be, and you get to share it right away. Does that sound good? Yeah. All right, so the main rule is you don't leave the platform until I catch the arm, so you don't get hurt.
Okay.
Other than that, you can do anything that you want. You can jump, move. Moving quick is cool. Standing perfectly still is cool. Either way.
Don't
Okay.
move slow.
Yeah, because it'll be kind of melodramatic.
So like a jump or something.
Be very, yeah, that'll be good. Yeah, you good to go?
All right, I'm just testing it out. I don't really know what's going on, but I'm gonna go with this. This is it. Woo! I am tuckered out. Thanks for joining me at the block party here on the first evening of Google I/O. We saw a lot of really cool stuff, and I hope you had as much fun as I did.
Can I start? OK. Thank you. Thank you for attending our session, Android meets TensorFlow. I'm Kazu Sato. I'm a developer advocate for Google Cloud Platform team. And
Hello, good morning. Thanks for coming in very, very early morning. So I'm not a morning person, so I'm a bit sleepy now. Anyway, yeah, my name is Hakurao Matsuda. I'm a developer advocate of the Android gaming and native technology.
OK. So today, in this session, we'd like to discuss these topics. So for the first part of the sessions, I will be discussing what is AI, machine learning, neural network, and deep learning, and how Google has been using that kind of technologies for implementing our services, and what is the TensorFlow, that is an open source library for building your own neural network. And then I will pass the stage to Hack. He'll be discussing how you can build the Android applications powered by TensorFlow and how you can optimize it. And lastly, I'd like to do a sneak preview of the new technologies such as TensorFlow Lite and Android Neural Network API. So what is machine learning and neural networks? How many people actually tried neural network by yourself? How many people? Oh, so many people, like 20 to 20%. And how many people actually used neural network on mobile devices? Oh, thank you so much. I found like over 10 people. OK, today we'd like to learn how you can use the TensorFlow and machine learning model running inside mobile applications. And there has been so many buzzwords such as AI or machine learning or neural network or deep learnings. We have been hearing about those buzzwords for the last few years. Now, what's the difference? The AI or artificial intelligence, you can say that is a science to making smart things like building an autonomous driving car or having computer drawing a beautiful picture or composing music. And one way to realize that vision of AI is the machine learning. Machine learning is a technology where you can let the computer train itself rather than having a human programmers instructing every steps to how to process the data by itself. And one of the many different algorithms in machine learning is neural networks. And since around 2012, we have been seeing a big breakthrough in the world of the neural networks, especially for the image recognition, voice recognition, or the natural language processing, and many other the applications. And at Google, we have been focusing on developing the neural network technologies for several years. So what is neural networks? You can think it's just like a function in mathematics or function in programming language. So you can put any kind of data as an input and do the matrix operations or calculations inside neural networks. Then eventually you would get an output vector which has the many labels or speculated values. For example, if you have a bunch of images, and you can train the neural networks to classify which one is the image of cat or image of dog. And this is just one example of the use cases of neural networks. You can apply the technology to solve any kind of the business problems you have. For example, if you have a bunch of the gaming servers, then you can try converting all the user activities or player activities converted into a bunch of numbers, such as vectors, and try training the neural networks to classify the types of the players on your gaming server. For example, if you want to find any cheating player who will be using the automated script to try to cheat on your server, or you can try to using the neural networks to find the premium players who could be buying more and more items from your gaming server. So that is just one example, possible example of the possible thousands of the applications. And at Google, we have been using deep learning technologies for implementing the smart functions on over 100 production projects, including Google Search, or Android, or Play, and many other applications. For example, if you are using Google Search every day, that means you are accessing the deep learning technologies provided by Google every day, because 2015, we have introduced RankBrain, which is a deep learning-based ranking algorithms that generates the signals for the defining and ranking of the search results. And if you take a look at the mobile applications from Google, for example, Google Photos is one of the most successful mobile applications that has been using deep learnings for analyzing and understanding what's the content of each image is taken by your smartphones. So you don't have to put any tags or keyword by yourself. Instead, you can just type dog or your friend's name or the wedding party to find the images based on this content. Smart Reply is a feature that shows the options to reply to each email thread. So it uses the natural language processing powered by the neural network model to try to understand the context of the email exchanges. And now the over 12% of the responses are generated by the Smart Reply features. So you can say that now email has been written by the computers and not by humans anymore. Google Translate app recently introduced a new neural translation model that has improved the quality, especially the fluency of the translated text significantly. So there are so many possible use cases for the combination between machine learning and mobile applications, starting from the image recognition, OCR, or speech-to-text, text-to-speech, or translation, NLP. And especially, you can apply the machine learning for the mobile-specific applications, such as the motion detection or GPS location tracking. And why you want to running your machine learning model or neural network model inside your mobile applications? Because by using the machine learnings, you can reduce the significant amount of the traffic, and you can get a much faster response from the cloud services. Because you can extract the meaning from the raw data. What do you mean by that? For example, if you are using the machine learning for image recognition, easiest way to implement that is to send you all the raw image data taken by the camera to the server. But instead, you can have the machine learning model running inside your mobile application so that your mobile application can recognize what kind of the object in each images, so that you can just send the labels such as flower or human face to the server. So that can reduce the traffic to 1/10 or 1/100. It's a significant amount of the savings of traffic. Another example could be a motion detection. So if you're gathering all the motion sensor data, now sending the just raw images directly to the server, you can use the machine learning algorithms to extract the so-called feature vectors. Feature vector is just a bunch of the numbers, like 100 or 1,000 numbers that represents the characteristic or signature of the motions from the motion sensors. So you can just send the 100 or 1,000 numbers in the feature vector to the server. And what is the starting point to build your own mobile application that is powered by machine learning? The starting point could be the TensorFlow, which is the open source library for machine intelligence from Google. And TensorFlow is the latest framework for the building the machine learning or AI-based services developed in Google, and we have open sourced it in November 2015. And now TensorFlow is the most popular framework for the building neural network or deep learning in the world. And one benefit you could get with TensorFlow is ease of development. So it's really easy to get started. You can just write a few lines of Python code or tens of lines of Python code to define your neural network by yourself. And actually, TensorFlow is, this technology is really valuable for people like me because I don't have any the sophisticated mathematical background. So when I was started reading the textbook of neural networks, I found many mathematical equations on the textbook, like a differentiation or backpropagation or gradient descent. And I really didn't want it to implement everything by myself. Instead, now you can just download TensorFlow, and where you can write the single line of Python code, like gradient descent optimizer. So that single line of code can encapsulate all the sophisticated algorithms such as gradient descent or back propagation or any other latest algorithms implemented by the Google engineers. So you yourself don't have to have the skill set to implement the neural network technologies from scratch. Also, the benefits of the TensorFlow is the portability and scalability. For example, if you're just getting started with the technology, you can download the TensorFlow on your Mac or Windows, where you can play with the Hello World kind of the very simple samples. But if you're getting serious about the technologies, for example, if you want to train the model from scratch to recognize an image of a cat, then you may want to use a GPU server, because GPU is like a 10 or 50 times faster than CPU or Mac or Windows to train your model. But many large companies like Google or any other enterprises are using tens or sometimes hundreds of GPUs running on the cloud, because the computing power is the largest challenges for the deep learning technologies. But still, you don't have to make any major changes on your TensorFlow neural networks, because TensorFlow is designed to be scalable. So once you have defined your neural networks, you can learn it, train it, and use it on a single CPU or multiple GPUs or hundreds of GPUs, or TPU or tensor processing unit, which is the ASIC or customized LSI designed by Google. And once you have finished the training of your model, you can copy the model, which has about, for example, for image recognition, the single model can consist of the 100 megabytes of the data, the parameters. You can copy those parameters to the mobile devices, such as Android, iOS, or Raspberry Pi. And if you go to the tensorflow.org website, you can find the sample code for those, the embedded systems and mobile phones. And then the benefit you could get from TensorFlow is the community and ecosystems. So if you want to find any practical production quality solutions, then the TensorFlow can provide the best answer for that, because there are so many large enterprises and developers who are using the TensorFlow for serious development, such as Airbus or ARM or eBay, Intel, Dropbox, Twitter. They are all using TensorFlow. Now I'd like to pass the stage to Hack, who will be talking about how you can implement the Android applications powered by TensorFlow.
Okay.
Oh, thank you.
Thank you, Kazu. So let's move on to Android part. As Kazu mentioned, we have found a lot of great use cases of running TensorFlow inference on mobile devices. Let's take a look how we can integrate TensorFlow inference on mobile devices and how we can optimize it. TensorFlow supports multiple mobile platforms, including Android, iOS, and Raspberry Pi. In this talk, we'd like to focus on mobile devices like Android and iOS. Building a TensorFlow shared object from scratch was a bit tricky, required multiple steps, starting from git clone from GitHub, install Bazel, install Android Studio, Android SDK, NDK, and finally editing a setting file, etc. But we have a good news today. Announced this I/O, we just added a JCenter integration, which makes the steps a lot easier. Thank you. So just add one line to the build Gradle, and the Gradle takes care of rest of the steps. Android library archive holding TensorFlow shared object is downloaded from JCenter, linked against your application automatically. Also, you can fetch pre-built model files, such as the inception, stylize, etc. from the cloud as well. And it's easier for iOS as well. We just added a CocoaPod integration as well. It's quite simple now. Let's take a look how you can use the TensorFlow API. We released Android inference library to integrate TensorFlow for Java application. The library is a thin wrapper from Java to the native implementation, and the performance impact is minimal. At first, create TensorFlow inference interface, opening the model file from the asset in the APK. Then, set up the input feed using Feed API. On mobile, the input feed tends to be retrieved from various sensors like a camera, accelerometer, etc. Then run inference, and finally you can fetch the result using fetch method over there. You would notice that those calls are all blocking calls. So you would want to run them in a worker thread rather than the main thread, because API would take a long time, like several seconds. This one is the Java API. And of course, you can use regular C++ API as well if you love C++, as I am. Okay, let's move on to the demo. So this one is a TensorFlow sample running on Android. The sample has 3 modes. First one is running Inception v3 that classifies a camera image. And also we have classified face and a stylized photo sample. This one is a stylized photo that is applying the artistic filter on the camera preview. Okay. Thank you. And one special thing on the demo is that I tweaked the demo a little bit using the GPU, using Vulkan compute shader. That one is a regular sample, just supports the CPU and the neon optimization, but I tweaked that using the GPU. And this one was just for experiment and just for fun. That was pretty fun, and I learned a lot to optimize TensorFlow for GPU. Basically, on Android devices, performance limiting factor is mostly coming from the memory bandwidth rather than computing itself, so that reducing memory bandwidth helped a lot. For instance, in some convolution 2D kernel, it was fetching the 32 by 32 by 32 by 4 samples just to generate one output value, which is a huge amount of data from the viewpoint of the compute shader. So memory bandwidth is the key, crucial for the Android and mobile device optimization. Anyway, everybody can tweak TensorFlow code because it's open source. It's a beauty of open source, right? So now we can integrate TensorFlow inference on mobile quite easily, as I explained. However, there still be challenges, performance. Even the mobile device performance has been increased significantly. It has less computing power than cloud or desktop counterpart. Also, it has limited RAM, which is a precious resource on mobile. Let's say if your application takes 1 GB of RAM, then your application is highly likely to be killed by the system itself when the application goes to background. That's not a happy situation, right? So let's take a look how we can optimize TensorFlow graphics, reducing a memory footprint, increase the runtime performance and improves the load time as well. So this one is the model of the Inception V3 model. The model takes around 91 megabytes in storage with 25 million parameters, and the binary size would take 12 megabytes. That is huge. And we have multiple techniques to optimize the graph, such as the freezing graph, and using graph transform tool, quantization, memory mapping, etc. Let's go through. Freezing graph is one of the load time optimization, which convert variable node into constant node. What's a variable node? In TensorFlow, variable nodes are stored in different files, but a constant node is included in the graph depth itself. So moving a variable into the constant node can concatenate multiple files into one file, like Apple Pen. That would be a slight performance win in mobile and easier to handle. To do that, we prepared a freezegraph.python script. And the graph transform tool is your friend. The tool supports various optimization tasks, such as stripping unused node files inference, but used only in the learning phase. When learning the inference node, those are not necessary. A thing is that currently it would require some manual steps to determine which node is the start node and which node is the output node. So the tool requires both start and output points specified manually. Let's talk about quantization. Neural network operation requires bunch of matrix calculations, which means tons of multiply and add operation. Current mobile devices are capable of doing some of them with specialized hardware. For instance, SIMD instruction in CPU, general purpose computing in GPU, DSP, etc. Roughly, on mobile CPU, it can perform around 10 to 20 gigabyte flops in total. And using GPU, it would achieve 300 to 500 gigaflops or more. That sounds a great number, but still less than a desktop or server environment, so that we want to perform some optimization. Quantization is one of the techniques to reduce both memory footprint and compute load. Usually, TensorFlow takes a single precision floating value for input and math, and also output as well. As you know, single precision floating point takes 32 bits each. But we found that we can reduce the precision to 16-bit, 8-bit, or even less, while keeping a good result. That's because a learning process involves some noise by nature, and adding some extra noises wouldn't matter much. So a quantized weight is the optimization for storage size, which reduces the precision of the constant node in the graph file. But please note that quantized weight, with the quantized weight optimization, the value will be expanded on memory when the graph is loaded. So we have another optimization. We can call it quantized calculations. With the quantized calculations, we can reduce the computing precision by using the quantized value directly. This one is good for both memory bandwidth which is a limiting factor in mobile devices. Also, hardware can handle less precision values faster than single precision floating value. But we still have an open issue. To do the quantized calculation, we need a maximum value and a minimum value that specify the range of the quantized values. We still don't have a great solution for that. It's still manual, but active research is going on so that hopefully this issue will be resolved pretty soon. This one is an example how quantized calculation optimization works in TensorFlow. TensorFlow has some operations that support quantization. For instance, convolution to the matrix multiply, ReLU, etc. We think that's good enough to cover most of the inference scenarios. However, we still don't have all of operations quantized yet, so that we need to quantize the value and dequantize value output right before and after each node. And the graph transform tool analyzes the path of each graph node, and sometimes we can reduce unnecessary quantized and dequantized value. Memory mapping is yet another optimization for loading time. With this optimization, the model file is converted and can be mapped directly using the memmap API, which could be slightly performance optimization on some Linux kernel-based operating systems like Android. Another one is reducing executable size. That's an important topic mobile as well, because on mobile devices, executable package size is limited to specific size. For instance, Android 100 megabyte for Android, including binary and graphics and any other resources. By default, mobile device supports multiple selected operations that is mostly good enough to cover inference operations, but ops used learning process is missing. So if you want to do the learning on mobile device, you need to register extra operations. Also, if your graph wouldn't require some of pre-registered operations, you would also remove some of them. To do that, you can do the selective registration. So for instance, for inception v3, by doing the selective registration, the binary size, original binary size was 12 megabytes, and after the optimization, it can be reduced to 1.5 megabytes. Note that this optimization requires rebuilding the shared object in your local. So you would need to construct the builder environment as well. So with these optimizations, now inception v3 graph now becomes 23 megabytes and 1.5 megabyte in binary size, which is 75% smaller now.
Okay.
Let's get back to Kazu.
Thank you, Hak. So as Hak mentioned, there are so many. Thank you. As Hak mentioned, there are so many tips and tricks to optimize your TensorFlow model to squeeze into an Android applications, mobile applications. And that is what you can do right now. These techniques are available right now. But now I'd like to discuss a little bit about the new technologies coming in the near future, such as TensorFlow Lite and Android Neural Network API. What is NN API? It's a new API for neural network processing inside Android, and that will be added to the Android framework. And the purpose of the adding a new API is to encapsulate and have an abstraction layer for the hardware accelerators such as GPU, DSP, and ISP. And modern smartphones have such a powerful computing resource other than CPU, such as GPU or DSP. Especially the DSP is designed to do a massive amount of the matrix and vector calculations. So it's much faster to use DSP or GPUs to do the neural networks inference on it, rather than using a CPU. But right now, if you want to do that, you have to go directly into the library provided by the hardware vendors and build some binaries by yourself. It's so tedious task, and also it's not portable. So instead, we'll be providing a standard API so that developers don't have to be aware of any the hardware accelerators from the each individual vendors. And on top of the neural network API, we'll be providing TensorFlow Lite. That will be a new TensorFlow runtime optimized for mobile and embedded applications. So TensorFlow Lite is designed for smart and compact mobile or embedded applications. And also, it is designed to be combined with the Android NN API. So all you have to do is to build your model with TensorFlow Lite, and that's it. So eventually, you'll be getting all the benefits you could get from the Android NN API, such as the hardware acceleration. So that will be coming as an open source in the near future, so stay tuned. And if you are interested in these new coming technologies, please take a photograph of this QR code so that you can join our survey for the ML on Android, where you can give your feedback or requests for the new products. Okay? Okay, thank you. So lastly, I'd like to show some very interesting and fun applications, real-world applications built with the TensorFlow on mobile and embedded systems. The first application is running on the Raspberry Pi, built by a Japanese cucumber farmer. So they are actually, I, by myself, took these photographs. I went their cucumber farm and took this photograph. And they have you can see there's sorry. There's no pointer. So you have the one person in the middle. He is the Makoto-san. He has started helping the cucumber farming 2 years ago, and he found out that sorting cucumbers into correct classes is the most tedious task. His mother spent 8 hours a day for classifying each cucumbers based on its shape or length or color into 9 different classes. And he really didn't want to help her. So instead, he downloaded TensorFlow and did his own cucumber sorter. So what he did is took a 9,000 photograph of the different cucumbers and put the labels crushed by his mother and trained the TensorFlow model by himself. And he built this sorter robotics by himself by spending $1,500. And the TensorFlow model is running on the Raspberry Pi to detect the cucumbers put on the plate. And it can classify the cucumbers into 9 different classes based on its shape and colors. And this is a system diagram of the systems. So it has 3 parts. The Arduino Micro is used for controlling the servos and motors. And Raspberry Pi has a camera to take a picture of the cucumbers on the plate. And it runs the very small TensorFlow model on it. And this is actually a really great example how you can split the task, the workload for machine learning into an edge device and cloud part. Because he found out running the full set of the TensorFlow model inside the Raspberry Pi is too heavy weighted, so decided to split into two tasks. So the TensorFlow model running on Raspberry Pi only detects whether there's a cucumber on the plate or not. And only when it detects there's a cucumber on the plate, it sends the picture to the server where he has a more powerful TensorFlow model that can classify the cucumber into 9 different classes. So let's take a look at the another interesting applications running on Android and iOS. That is a gymnastic exercise scorer. What is that? Actually, every Japanese knows the exercise called radio exercise. Because we have a national radio broadcasting network, they play the same exercise music at the same time every morning. And tens of millions of Japanese people are doing the same exercise every morning. Did you know that? Yeah. And this application is designed to record the scores or how well you have been doing your exercise with the music. And to capture the motions with the motion sensor, they have used the TensorFlow. And they were able to train the TensorFlow model to capture and extract the patterns or features from the data from the motion sensors so that it is able to evaluate the motions made by human hand. And they also built their own TensorFlow compiler so that they were able to apply the techniques such as the quantization or approximations. And they were able to reduce the TensorFlow model from tens of megabytes into a few megabytes. So that was the key technology to build the production quality Android and iOS applications with the TensorFlow power. So let's take a look at the live demonstration of the exercise scorer. So can I switch to the So this is the applications where you can choose the various kinds of the exercises. And I'll be playing the most standard one. So this is the music.
腕を前から上に上げて伸び伸びと背伸びの運動からはい1 1 5 6 7手足の運動1 5 腕を回します頭は
Am I doing right? So just like that. So let's stop. Oh. It's enough. It's enough. So now the TensorFlow model is trying to evaluate how well you have done with the exercise. And you can see the bar chart here. That is the evaluation by the TensorFlow model inside these applications. It's a real thing. Okay? So go back to the slide. So that was the thing we wanted to show. And so in this session, we have learned many things, including the yet another weird thing from Japan, and new tech and some optimization techniques for the building TensorFlow applications with the production quality Android and iOS applications. And if you are interested, please go to the tensorflow.org, where you can have the lots of the getting started materials. And there are also some of the good code labs on the code lab website. Okay? Thank you so much.
Thank you.
games all my life. It's my passion. I also learned how to program computers. And then in 2001, we started the first video games company for mobile phones in Spain called Microjogs. In 2013, my studio was acquired by a big company. Some of the guys and myself, we decided that we should do something fresh, something new, and we founded On The Run. Titan Roll is a real-time strategy game. It's considered as a MOBA. MOBA is a massive online battle arena, but especially designed for mobile devices. The game is today as it is thanks to the early access program. We changed many things from the learnings from the community. Since we launched the game on early access, we got more than 2 million installs on Android devices.
We started in the early access program back at the very beginning of it. The difference between the early access program and a traditional soft launch is that users are actively giving the team feedback. So you don't only check the metrics you have, but they also provide possible solutions. So you end up by doing the game players want to play. The thing about not having the ratings but having the constructive feedback was very good. The early access was a great opportunity for an indie developer, someone starting, and very key for us in Omnidron. When we started with the early access program, we approached it in different stages. So the idea was at the beginning to focus on the engagement of the games. Once we sorted that out, we focused on the retention of the game. And finally, we focus on monetization to do a valid product for the market. We managed with early access to improve our retention in a 41%, the engagement by 50%, and the monetization by 20%, from the very beginning of the program till worldwide launch the game.
I feel very happy working on the video games industry because it has been my passion since I was a child, and it's really inspiring that through Omnidron we have a real chance to shape the new era of the video games.
In response to popular demand, the Android Framework team has written an opinionated guide to architecting Android apps, and they've developed a companion set of architecture components. Hi, my name's Lila, a developer advocate for Android, and I'm here to introduce you to these shiny new architecture components. Components persist data, manage lifecycle, make your app modular, help you avoid memory leaks, and prevent you from having to write boring boilerplate code. Your basic Android app needs a database connected to a robust UI. The new components, Room, ViewModel, LiveData, and Lifecycle, make that easy. They're also designed to fit together like building blocks, so let's see how. I'll step through with a new SQLite object mapping library. To set up the tables using Room, we can define a plain old Java object, or POJO. We then mark this POJO with the @entity annotation, and create an ID marked with the @primaryKey annotation. Now for each POJO, you need to define a DAO, or database access object. The annotated methods represent the SQLite commands you need to interact with your POJO's data. Now take a look at this insert method and this query method. Room has automatically converted your POJO objects into the corresponding database tables and back again. Room also verifies your SQLite at compile time. So if you spell something a little bit wrong, or if you reference a column that's not actually in the database, it will throw a helpful error. Now that you have a Room database, you can use another new architecture component called LiveData to monitor changes in the database. LiveData is an observable data holder. That means it holds data and notifies you when the data changes so that you can update the UI. LiveData is an abstract class that you can extend, or for simple cases, you can use the mutable LiveData class. If you update the value of the mutable LiveData with a call to set value, it can then trigger an update in your UI. What's even more powerful, though, is that Room is built to support LiveData. To use them together, you just modify your DAO to return objects that are wrapped with the LiveData class. Room will create a LiveData object observing the database. Then you can write code like this to update your UI. The end result is that if your Room database updates, it changes the data in your LiveData object, which automatically triggers UI updates. This brings me to another awesome feature of LiveData. LiveData is a lifecycle-aware component. Now you might be thinking, what exactly is a lifecycle-aware component? Well, I'm glad you asked. Through the magic of lifecycle observation, LiveData knows when your activity is on-screen, off-screen, or destroyed so that it doesn't send database updates to a non-active UI. There are two interfaces for this, Lifecycle Owner and Lifecycle Observer. Lifecycle owners are objects with lifecycles, like activities and fragments. Lifecycle observers, on the other hand, observe lifecycle owners and are notified of lifecycle changes. Here's a quick peek at the simplified code for LiveData, which is also a lifecycle observer. The methods annotated with @onLifecycleEvent take care of initialization and teardown when the associated lifecycle owner starts and stops. This allows live data objects to take care of their own setup and teardown. So the UI components observe the live data, and the live data components observe the lifecycle owners. As a side note to all you Android library designers out there, you can use this exact same lifecycle observation code to call setup and teardown functions automatically for your own libraries. Now you still have one more problem to solve. As your app is used, it will go through various configuration changes that destroy and rebuild the activity. We don't want to tie the initialization of live data to the activity lifecycle because that causes a lot of needlessly re-executed code. An example of this is your database query, which is executed every time you rotate the phone. So what do? Well, you put your live data and any other data associated with the UI in a view model instead. View models are objects that provide data for UI components and survive configuration changes. To create a view model object, you extend the view model class. You then put all of the necessary data for your activity UI into the view model. Since you've cached data for the UI inside of the view model, your app won't require the database if your activity is recreated due to a configuration change. Then, when you're creating your activity or fragment, you can get a reference to the view model and use it. And that's it! The first time you get a view model, it's generated for your activity. When you request a view model again, your activity receives the original view model with the UI data cached, so there's no more useless database calls. To summarize all of this new architecture shininess, we've talked about Room, which is an object mapping library for SQLite, Live Data, which notifies you when its data changes so that you can update the UI, and importantly, it works well with Room so that you can easily update the UI when the database values change. We've also talked about lifecycle observers and owners, which allow non-UI objects to observe lifecycle events. And finally, we've talked about view models, which provide you data objects that survive configuration changes. Altogether, they make up a set of architecture components for writing modular, testable, and robust Android apps. You can sensibly use them together, or you can pick and choose what you need. But this is just the tip of the iceberg. In fact, a more fully fledged Android app might look like this. For an in-depth look at how everything works together and the reasoning behind these components, check out the links in the description below. To jump straight into code and get started working with these objects, you can check out the code labs and samples for lifecycle and persistence. Happy building, and as always, don't forget to subscribe.
I'm Wojtek Kalicinski, this is Android Tooltime, and let's talk a bit about the Espresso Test Recorder and how it can help with adding UI tests to your app. But first, a short explanation for those unfamiliar with Espresso. Espresso is a testing framework designed to provide a fluent API for writing concise and reliable UI tests. However, it is often the case that developers are reluctant to add UI tests to their apps, or simply don't have time to learn the framework. This is where the Espresso Test Recorder comes in. It lets you create and add UI tests to an existing app in an interactive way. You may have previously seen the beta version of this feature, but in Android Studio 2.3, we are promoting it to stable with a few enhancements. To get started with the test recorder, click on Record Espresso Test under the Run menu. The device selection dialog pops up, and after you make your choice, the test recorder runs your app in debug mode. Simply progress through your app's UI as a regular user would, by clicking buttons, swiping, and typing into input fields, and all those actions will appear in the test recorder window. You can also click here to add an assertion to your test at any time during recording, which will trigger the test recorder to dump the current view hierarchy. To select the view you want to assert on, click on the screenshot that appears in the recorder window and choose between the assertion type from view exists, doesn't exist, or check that it contains the specified text. When you've finished recording your test, the test recorder generates the equivalent test code to run your actions and assertions and puts it in a new file in your project's instrumentation test folder. It also checks if your build file contains the required Espresso dependencies and adds those if needed. When you look at the source file that Espresso Test Recorder created, you will see that it's perfectly normal, human-readable code, so if you need to further customize your tests or alter them when your app changes, you can simply open the file again and make the alterations you need. As you can see, the Espresso Test Recorder is very simple to use, but it does come with some limitations. As of Android Studio 2.3, only a few most common assertions are available through the Recorder UI, so if you need anything more complicated than that, you will need to edit the generated code by hand. Also, at this stage, the test recorder cannot handle all situations where additional synchronization is needed to deal with delays and async operations in your apps. I highly recommend getting familiar with the Espresso idling resource API and using that in your tests to signal when a long-running operation happens. For advanced users who want to tweak some aspects of test code generation, there's a settings page for the test recorder in Android Studio Preferences. Here you can change the maximum view hierarchy depth that will be used for view identification, and if app data should be cleared every time you record a new test. The Espresso test recorder is a great way to start adding tests to your app, whether you want to learn Espresso by examining the generated code, or simply to quickly build a test suite which you can customize later. We look forward to your feedback on our social channels, and happy testing.
Hi, Timothy Jordan, your friendly developer advocate here at Google I/O 2017. I'm in the machine learning area, and we're going to check out a lot of really cool stuff. A reminder before I get to it, if you'd like to see any of this footage or any of the other sandbox tours that I've been doing, go to g.co/io/guide. First off, I'd like to check out the Cloud TPU in person. Wow. So much heat sink.
This looks like a skyscrapers. It's like a miniature city down there.
This is seriously one of the best Tron moments I've had in years.
This is among the most amazing things I've ever seen in my life.
Okay, Magnus. Everybody, this is Magnus. You may know him from, well, being Magnus and all sorts of things. Hi, Magnus.
Hi, how are you?
I'm doing super well. So you've been hanging out with all this really cool machine learning stuff all day long.
Yeah, that's right. We've been here all day doing different machine learning stuff.
I'd like to check out some of it and just play with it.
Okay.
Let's try AI duets first. So what is this?
So you can actually play on these things, and then the network generates something back. Yeah.
Okay, so it's kind of like the machine playing music with you.
Yeah, it's kind of constructing music based on what you play. It's trying to create something similar, but still different.
Okay, I want to try it out.
Yeah.
That's a lot of fun. It feels a little like that scene in Close Encounters with the Third Kind.
Yeah, absolutely.
All right, so there's one other thing that I would like to check out while we're here, and that's the candy sorter.
Yes, it's an amazing thing. It consists of so many different machine learning technologies in one single demo.
Shall we check it out?
Yeah, for sure.
As promised, we're going to check out the candy sorter. What is a candy sorter, you may ask? Well, Dave's here to tell us what that is.
Okay, great. So what we're going to show here is how you can infuse machine learning into your apps without actually being a data scientist. And the way we're going to do it is through Candy and through labels. Now, what we've done is we've trained a model up in the cloud that for basically we've taken an existing model, and we've trained it for candy. So we've put labels and next to candies. And we've got a little camera here that's taking pictures of the candy, and we put labels that have been associated with the candy. We sent it up to the Google Cloud Machine Learning Engine, and we've trained the model. We used the Inception v3 model, and using transfer learning. And so what we're going to show now is, now that the model's been trained, is actually the serving of the model. So I'm going to take candy here and just throw it out in front of the camera, and this is just any random candy that we have trained this model for. So I like gum. I want to make sure there's plenty of gum out there. And you'll want to make sure there's a little bit of space in between here. Again, when we train this image, it has been a well-trained model that has been modified with these images and these labels. You can even write your own labels, which is awesome. So now it's trained. Now the fun part of this is actually the serving, the prediction. So you're going to speak into this mic. You're going to hit this little mic button here. You're going to speak into this mic and ask for some kind of candy. And it's going to make a call to our API. It's going to understand the text. It's going to do a speech API, so speech to text API. And then it's going to understand the intent of what you're asking for using our natural language processing API. And then it's going to make a prediction based upon the model that's sitting out in the cloud. And the best part is, hopefully, cross your fingers, it's going to make the prediction, pick it, and then give it to you.
Awesome. Okay.
All right, so click on that and speak into the mic.
May I have some gum?
So it understood what you said, may I have some gum? Now it's going through natural language processing. It's identifying the noun there, and gum. So now it will then match based upon the model that's been modified. Come on, come on, come on. And it is picking chewy gum. Oh, and there, the camera identified extra long-lasting watermelon gum. Now the camera's and over, and there's your gum.
That's great.
Machine learning in an app.
So I get to keep this, right?
Yeah, actually I've got like 7 boxes back there, so please everybody take one.
Dave, thanks so much.
All right, thank you.
That's pretty great. All right, so that is the machine learning area. I hope that you've enjoyed these experiences as much as I had. It's really cool to see machine learning up close and personal, see how it can be used in real life through these demos. And I hope it inspires you to do some cool stuff with TensorFlow and with cloud. See you later.
Good morning, everyone. Good morning. My name is Tal Oppenheimer. I'm a product manager on the Chrome team, and I'm here with Maria and Robert to talk about some of the things we've learned from building products that can work for billions of people. So just before we jump in, as a quick overview, there's 3 main things that we're going to be covering here. The first is just talking about where we found that our users actually are and where we expect them to be in the coming years. Second, we'll be talking about some of the things we've learned from trying to make sure that all of our products work for everyone. And third, we'll be sharing some specific tips that we have for how you can build products that work for everyone as well. So to jump right in, when we're talking about billions of people, we really need to think about where people are accessing the internet. And the reality is that internet growth is happening everywhere. So we really need to take a global look when we're thinking about this. So this is a chart from 2014 of the overall number of internet users per country, where darker means more internet users. And what you'll see is that in 2014, China has a tremendous number of internet users with about 675 million. And you'll see that the United States also has quite a large number of internet users at slightly under half that number. But if we fast forward a little bit, we start to see a different story here. So by 2015, you see a few other areas light up, most notably India here, with about 354 million internet users. And by 2016, we still see a similar picture, but we're seeing a few other areas light up as well, with areas like Brazil having 139 million internet users, and Nigeria at about 87 million internet users. But what's really interesting isn't just looking at the absolute number of internet users, but looking at the growth that we've been seeing year over year in each of these countries. So looking at the same data a little bit differently, this is a chart of the number of new internet users that came online every year. And in 2014, you already see a bit of a different picture here. You'll see that while we saw a lot of total internet users in the United States, the new internet users was quite minimal, and because the United States is honestly pretty saturated, the number of internet users. In comparison, both China had a lot of new internet users and India. But if we fast forward a little bit more, we see this start to shift as well. In 2015, there's clearly a dominant India here with new internet users. And this gets even more pronounced in 2016, last year. And if we dig into this and looking at India specifically, last year we saw over 100 million new internet users come online in India alone. But what's really remarkable here is that this is the second year in a row that we've seen over 100 million internet users coming online just in India. And this isn't just the case over the past couple years. We still see that 65% of India's population is not yet online. So projecting forward, various estimates suggest that by 2020, there will be about 1 billion unique mobile subscribers in India alone. And this is just India. Remember, we saw other areas on this map also having quite a few new internet users. And we've seen this shift in a lot of our Google products as well. To give one example, on Chrome on Android, we've seen that we now have hundreds of millions of internet users from all of these next billion user countries. And this is already the case. And it's not just limited to the browser. We're also seeing this with how they engage with certain products. For example, with Google Search, we see that Brazil, India, and Indonesia are all in our top 10 based on search query volume for Google searches. So the reality is that it's not just about where our users are going to be, but it's where our users are today. As a result, we've been working really hard to improve our own products. And to share some of the things we've learned, I'm going to invite Maria on stage.
$1 billion by 2020, right? It just blows my mind. All of these people are coming online. Rahul, yesterday, day before, in his mobile keynote, mentioned that 7 people are coming online every minute in Brazil. So these people are going to be your future users. And a lot of them are already our users. And we've been doing a bunch of research and also iterating on products to make sure that we best suit their needs. And I want to share with you a little of the stuff that we've learned so that you can apply it when you are building new stuff on the web or elsewhere for your own products. Now, Brazil, India, and Indonesia might seem like they are very different. You know, different continents, different types of population, languages, culture, GDP. But actually, what we found is that they share a few very common things. And I want to share 3 of those things with you first to put you in the right frame of mind when you're thinking about building a product on the web, what kind of things you should be considering. The first thing that is shared across all of these countries is that there is a really wide range of devices. Now, all of us have a phone in our pocket, and probably you bought your phone, what, maybe a year ago, 2 years ago? But in India and Indonesia and Brazil, people use a lot of secondhand phones. There is a super wide range of screens, storage, and memory. So what might work on your phone if you're building it and testing it on this kind of device might not work for these users. In fact, what we know is that about 33% of users in India run out of storage on their phone every day. Can you imagine this? You look at your phone in the evening and you're like, oh, I can't take any more pictures. I have to delete something now. And that's what they do, actually. 83% of people delete stuff every week to make space for new pictures or videos or other things. So what does this mean for you? If you're building an app or you're building something else and it's large, for a small phone with limited storage, you're going to have a hard time competing with everything else, and you're always going to be in a precarious position if someone is wondering, OK, I want to have some more space for videos. What should I delete? Should it be this 2 megabyte app, or should it be this 45 megabyte app, right? The other thing that we found, which is shared, is the very poor quality of connection. So a lot of us here on Wi-Fi, we probably don't even notice. We're completely online all the time, 4G networks, really fast connection. But half of the users in India currently are still on 2G connections. And 2/3 of the users in Nigeria are on 2G connections. So a lot of them actually are not even connected most of the time. And if you're building a product which relies on the updates over the air, or you're relying that people have to be connected in order for your product to function, that is not going to work out for you. So we learned this the hard way. So you need to make sure that your products are either fully functioning offline, so offline is a state of its own, it's not an exception, or you need to make sure that at least they degrade gracefully, so people can still use them in some kind of decent way. Finally, data is really, really expensive. So a lot of people in those countries actually use prepaid data. So they will buy it in small packets of 10 megabytes or 100 megabytes, and they're extremely conscious with how they're using this data. So they keep track which app is using up how much, and they will turn different things on and off, and sometimes even go into airplane mode in order to preserve the data. So for us, what we perceive as a free app, and it's only 40 megabytes to download, is actually a big decision for them, because they have to spend a bunch of their very, very precious data in order to download it. So if you're requiring people to install stuff, and it's large in size, think again. So we took these 3 trends, and then with research, we've actually extracted 5 principles that have made our product successful. And I want to share with you an example of what we've made in terms of changes for each of those 5 principles. And I'm hoping that this will help you when you're building your products on the web. So the first really big principle that we learned is that before people even start interacting with your product, you need to remove the barriers for them to do so. So remember the things that I mentioned before in terms of high cost of data, poor connectivity, and low quality, low range devices. Those are things that stand between you and these users even before they start using your product. So you need to think about, OK, can I make a solution that will not require an install? Can I have something which is very small, which works offline? And here's an example of how Twitter did this. I don't know how many of you went to the session that they did on Monday, but they very recently released a progressive web app, which is a light app, and it solves for all of these challenges to remove these barriers. So it doesn't require any installs. It's less than 1 megabyte in size, and it allows to read stuff offline even if the user is disconnected, if that stuff has already been preloaded. And it also comes with a data saver feature, so that people can pick exactly which images and videos they need to download. So they don't need to see all of their stream. They can just download the things that they like. And they've just launched it for a few months now, but it's really enjoying a lot of success. So here's just some of the metrics that they shared with us. It gets over 1 million launches per day. And since they've launched it, they're seeing 20% decrease in bounce rate. So by removing these barriers, They have delighted their users, and they're doing pretty great. And they actually built it specifically for these emerging market users where the connectivity is flaky, and the data cost is high, and the devices are kind of poor. The second thing that we've learned is that in order to succeed in these markets, you need to optimize for speed. Your load performance needs to be amazing. And a lot of people are like, well, I don't need to do all this special work. And believe me, you're not special casing for a specific market when you're making your stuff fast. I have yet to hear anybody anywhere on the planet that is complaining that something is loading too fast. So if you make your stuff work for users in Indonesia on a 2G connection, your users in the US will be also super delighted. Now, we've been working to optimize our core products as well for speed. And one thing that we noticed is that for users in India on 2G connections, it actually could take sometimes up to 8.5 seconds for the search results page to load for them. So imagine that. You're searching and you're counting 1, 2, 3, 4, 5, and still no results, right? So we did some work to optimize our page. And we also didn't stop there. We actually looked at what can we do after the click. Because we noticed that in some cases, again, on 2G connections, it could take up to 25 seconds for a page to load in India. So what we launched is something called transcoding pages. And it leads to great results. So this is an example of one of the biggest newspapers in Indonesia, Kompas. And as a result of this transcoding and page optimization, we are now consuming 90% less data, and these pages load 5 times faster. And what do you think how do you think users reacted when they saw this? Well, actually, there's been 50% increase in traffic to these transcoded pages, because users just perceive that everything is loading much, much faster, and then they just browse more. So it's a win-win for both sides. The next big thing that we learned is that offline is a state in itself. We need to make sure that our stuff functions even when people are going in and out of connectivity. So not everybody has Wi-Fi. In fact, a lot of people especially go to stores or train stations in order to get access to Wi-Fi. They download a lot of stuff there, and then they spend most of their time offline the rest of the day. So one thing that we are experimenting with in order to make sure that people have a little bit smoother experiences when they're going online and offline throughout the day is in Chrome, if you're searching, so this is the example on your left. If you're searching and you're trying to fetch a page in Chrome, and we notice that you're offline, first we'll show you adorable dinosaur, and second, we show you this download button. So when we detect that if you click on this button, we detect that you're going back online later, we'll download this page for you then, and then you can see it. So we are aiming to experiment in order to smooth the experience for people. Similarly in search, if someone does a query and we notice that they're offline, we'll offer them to do this search later and then send them a notification that they got their results. The next trend, and a really important one, is that in a lot of these countries, people use more than one language to accomplish their daily tasks. They might do their homework in English, they might talk to their grandma in one dialect, and they might use a completely different language in school. And so depending on that and what product you're building, you need to be ready to handle these challenges. For example, in search, what we've noticed is that sometimes people will search in English, but the words that they're typing are in Hindi. So we launched something where if you're searching in Hindi and in English, we'll show you the results side by side. And you can actually click on the top and then just switch. And people really like this. We saw that there is a 50% increase in Hindi searches on mobile after we launched this. Now, the last trend, and a very important one, is that a lot of these users are coming online in a completely different context. And so you shouldn't expect that the product that you have right now with the UI and the flow and the graphics will fit their needs, even though it has a very specific function. So a lot of them are coming online for the first time on a phone. They don't have any experience with desktop. A lot of them have never used email. And they have different cultural expectations or color preferences. So we did a lot of research for our products in order to make sure that what we're launching for them is actually suitable for their needs. And you need to keep this in mind as well. So here is an example. This is the Chrome default page. And if you look at the one on the left, it's the standard one, right? Google is pretty much known for its super minimal interface. We have the search box, and that's it. But what we found when we did research with users in India is that this empty page reminded them of like a big, vast, empty lobby where you have to walk all the way and then ask a receptionist something. So it felt very cold and not welcoming. And what they wanted to see were they wanted to be surrounded by their favorite things. And so on the right side, you'll see a version of the Chrome homepage that we're experimenting with, where the user can see their favorite sites that they're visiting the most often, and then also they can see articles that are related to the searches that they've been doing. So this feels a lot more welcoming. And we continue to experiment with that. So to sum up, 5 important things that you need to remember if you're building stuff for these markets, which we learned the hard way. And you today, by waking up early and coming to this session, have managed to learn the easy way. First, before you even start thinking about how people are interacting with your product, make sure to remove the barriers for them to adopt this product. Second, make sure to optimize performance as much as possible because these connections are super slow and data is very scarce. Third, yes, make sure that your product works offline almost as well as it works when it's online. Fourth, don't assume people speak only one language all the time, and make sure that whatever user flows you have in your product are addressing their multilingual needs. And finally, but not last, make sure to guide the users and that your experience in your product matches what they're expecting in terms of culture and habits. So you've seen the examples of how we've done this in our own products on the web. And hopefully, by now, you're inspired and you want to know how you can do this. Well, you're very lucky because we have Robert here, who's going to give you specific examples for each of these 5 things on how to build to succeed in next billion user markets.
Thank you. Thank you, Maria. So first and foremost, thank you for showing up. Like morning of day 3, I love you. I'm so happy you're here. So I'm Robert, and looking at how the world is evolving and looking at what we learn, I'm going to be here and talk about our best advice for catering to these challenges, like our best practices and how you also carry all of this into the things you're building. So the first and really most important thing, though, and Maria was talking about this as well, this is not only about advice for a certain market or a certain country or a certain person. Like all the advice we'll be giving you here will be applicable everywhere. It's going to help all your users wherever they are in the world. So let's start with removing barriers. For instance, as Tal was saying, in 2020, we expect about 1 billion unique mobile subscribers in India alone. That's a lot of people. So how do we cater to that, and how do we make sure to remove barriers for them? As you saw with Twitter Lite, when you're building something, you really make sure that you have no friction or as low friction as possible. So no install being necessary, saving as much data as possible, and working offline. These are all crucial features. But you also need to have the best possible reach with what you're building, and also that the content is actually being kept up to date for your users as well. And meeting these needs of no install or using as little data as possible are really big and hard challenges for native apps. So what's the solution? As I'll be showing you from our experience, progressive web apps really just respond to all of these challenges and also these opportunities And I'm going to walk you through this with a few examples and also a number of different use cases as well. Historically, with native apps, once they've actually been installed, they had really great UX experiences. Home screen icons, offline support, push notifications, background syncing, access to sensors, and much more. And the idea with progressive web apps is bring the best of native together with the best of web. Like, what are our learnings and how can we get it all in one good package? And I'm sure you already heard a lot about progressive web apps so far, before Google I/O and also here at Google I/O as well. So I'm not going to delve too much into the technical details here. I just want to quickly mention a few of the core basic features, like add to home screen, push notifications, offline support. And all of these features, it's not just something that's completely new, right? This is being built on top of what the web already has, the existing reach that the web has, and then already staying up to date capabilities that the web has as well. One quick thing to mention, though, if you haven't already implemented that, is the web app manifest. So you can add this to your HTML code, and this is really the foundation for the features like add to home screen and push notifications. And the way to do it is really, really simple. You just reference the manifest file from in the HTML code, and then within the manifest file, it describes the app name, the icons, the start URL, and much more. And an important thing to note here, if you look at the start URL, is also to make sure to have a parameter in there so you know if your users are coming from the home screen icon or if they're coming from visiting your progressive web app through a browser tab. You can also control other things like having a splash screen, theming and background color, display type, orientation, and much, much more. And we've had a number of talks here at I/O about progressive web apps, so I really recommend looking at those videos. But also in our developer website as well, we have very detailed information how you go about implementing all of these things. But also when we talk about progressive web apps, we can talk about a lot of technology, right? But at the end of the day, it's about user experiences. And this is really the key thing. Like, user experience needs to be reliable, fast, and engaging. For whatever you build, this is the key thing. And for us, these are the key words for progressive web apps. So these should, whatever you do, this should really be your new mantra. Look at what you're building. Does it actually match this? And we also see this kind of mental approach as the key to removing barriers for your users. And when we talk about being reliable, it means that it will always load instantly for your users. You will never show the users that are actually offline. And you use service workers to cater to that. And there are client-side proxy to put you, as a developer, in control of things like cache and networking requests. But it's also about being fast. You need to load fast, but you also need to stay fast as well. You don't want to have any janky scrolling or slow experience. Like, it always needs to be very, very smooth for the user. And it also needs to be engaging. And we see features like add to home screen, immersive full screen experiences, push notifications, and much more. That's really, really good things to get there. But another part of removing barriers that is sometimes overlooked is actually storage constraints. Like, app size matters more today than ever before. And we see a lot of users never installing any new apps or never installing any apps at all, or they remove the apps that are using up the most of the space on their devices. And as Maria mentioned, 33% of smartphone users in India run out of memory space every day. That's a lot of people. And for instance, if you only have 1 gigabyte of app storage, you can only install between 5 and 10 native apps. So with this in mind, we were really excited with seeing Twitter's progressive web app, where they really cater to this specific issue. So Twitter Lite is under 1 megabyte. And compared to their native apps, that only makes up 1 to 3% of their sizes as well. And this is great, like, it's a really small file size. But they launched very recently, and already so far, they see a 50% increase in page views and 60% increase in pages per session. And in India, a company called Ola Cabs, they had fairly big native apps, 60 megabytes on Android, 100 megabytes on iOS. And these aren't like super big sizes for native apps either, like, but fairly big, right? So they decided to build a progressive web app to address this, and the result was really stunning. So their progressive web app now is only half a megabyte. So you compare that to the size of their native apps, and it can still give the users the same exact experience. And they also work with Polymer to achieve this, both to get the small file size and the good experience, but also working with Polymer to make sure that they would have support for the UC browser, which is one of the very popular browsers in their main market. And Polymer is natively supported in Safari, Chrome, and Opera. And with polyfills, it works on Firefox, Edge, UC Browser now, and IE11 as well. And whichever framework you use, I mean, you should use what works best for you. This is just one example. But make sure it also has a small file size. Like in the case of Polymer 2 that was just released, it's only 10 kilobytes on Chrome, 30 kilobytes on Safari, and slightly larger on Firefox and Edge and a couple of the other ones. And in Brazil, we saw a company called Terra. And they recently built a progressive web app as well. And for them, it's already a success. They're seeing users visiting twice as many pages as before, but also spending twice the amount of time in their progressive web app as well, compared to their previous mobile experience. And the second challenge, but also opportunity here, is really optimizing speed. You want to make sure to reach your users, but also make sure that they don't go elsewhere as well. So coming back to Ola Cabs, their progressive web app has an enviable first load of only 50 kilobytes. And repeat load sizes can be as small as 10 kilobytes. And that actually means 500 times lighter than the iOS app and 300 times lighter than the Android app. So I mean, it's completely different worlds here, right? But also, this low data consumption makes sure that the first load is about 3 seconds, and then repeat load times could be down to about 1.8 seconds. Which is good on its own, like it's a fairly good loading time. But in this case, these loading times are on 2G or ultra-low 3G networks, which of course is the defining factor to actually reaching your users. And for them, catering to many millions of people in India, this is the key thing to actually being able to reach them to begin with. Another really interesting number that we see is that 53% of the users abandon sites that take longer than 3 seconds to load. And 53% of the users, that's over half in 3 seconds. That's not a long time. So you can work a lot with progressive web apps and achieve a lot of really good performance. But generally with progressive web apps, we've seen that for the second and subsequent loads, using progressive web apps and service workers, it's a really good experience. But what about the first load? What about if no matter how hard you work on it, what if it's not fast enough for your users? One option we've been looking at here is called AMP, and Accelerated Mobile Pages. And one thing that I want to stress here is that it's an open source initiative, really trying to make the web better through fast and high performing pages across different devices and distribution platforms. And the idea with AMP is that you're guided to only do things that are fast. It's almost impossible to make slow AMP pages. So I'm going to talk briefly here about what AMP is, but also how it ties into progressive web apps. And AMP consists of a few different things. The first thing is AMP HTML. And it's basically regular HTML with some restrictions for reliable performance. I like these cute little bubbles. It's like a morning shot or something. But basically, it's HTML, but it's extended with some custom properties that you will need. And some HTML tags are being replaced by AMP-specific tags, or so-called AMP HTML components. The second part is the AMP JavaScript library. And the idea is really to ensure the fast rendering of the AMP HTML pages, to manage resource loading, and also give you support for a few other different custom tags I mentioned. But it also makes everything that comes from external resources load asynchronous. So nothing in the page can block anything else from rendering. And finally, you have the Google AMP cache. And the idea with the AMP cache is that you can serve cached AMP pages. So it's a proxy-based content delivery network for delivering all valid AMP documents. And it caches them, improves them, and improves the page performance automatically. So these three together make up the foundation for AMP. And if you want to get started and create your first AMP page, it's really quite easy. It looks like any basic HTML page you've ever seen before, just a few regular tags. But as you can see at the top, you have the lightning icon indicating that this is an AMP page. You have some boilerplate CSS needed to make sure you have the consistent rendering and look across browsers and platforms. And then finally, you include the AMP JavaScript library. And then you're good to go. That's your first AMP page. It works. And then if you want to do things like including an image, you have the AMP image component. And if you look at it, it kind of looks like the image element in HTML they're used to. It has the source attribute, the alternate text, dimensions, and all of that. But the interesting part here is that the AMP runtime can choose to delay or prioritize resource loading based on different things like viewport position, system resources, connection bandwidth, and other factors. So basically, the runtime will take care of it for you to manage the image resources, make sure that it loads the best and most suitable things at that specific time. And one company called Zomato started working with AMP pages, and they had a 4-second page load before, and they're down to 1 second now. And again, on really slow networks as well. And I mentioned I was going to talk about AMP and progressive web apps and how they're connected to each other. And we see two different approaches here. One is using AMP as an One is using AMP as an entry point into your progressive web app. And the other one is using AMP as a data source for your progressive web app. So taking a look at the first one and using AMP as an entry point, AMP's selling point is really almost instant delivery of pages, whereas progressive web apps enable much more interactivity and engagement-enabling features. So a good approach here could be have an instant first load with AMP and then upgrade the user to a progressive web app. Basically, start fast, stay fast. And the way to do it within an AMP page is to use a component called AMP install service worker. It basically allows you in the AMP page to warm up a progressive web app in the background. So then for the next click from the user, you can instantly load a fully featured progressive web app. And looking at this component, you have the source attribute here, which is specifying the URL of the service worker you want to register. And then you have an optional attribute called data iframe source, which could be the URL of an HTML document to register a service worker. And then finally, you need the layout attribute, which must have the value no display. And looking at this combination between progressive web apps and AMP, WeGo started working with that. And for their AMP pages, they had a previous page load time of about 12 seconds, and it's down to 2.75 seconds now. And for the progressive web app shell, they had a loading time that was almost 9 seconds before, and they're down to 1.63 seconds now. And again, these tests are being done on a Nexus 5 on a slow 3G connection. So just looking at the improvement, and again, coming back to the user experience, it makes such a massive difference for them. But it's not only fast, right? This directly leads to actual results. So with their new implementation, they now see 74% of all visits actually turning into conversions. And all in all, the conversions have gone up now on the site 95%. And looking at the other option of having AMP as a data source for your progressive web app, maybe you started with building something with AMP, for instance, but you haven't built a PWA yet. And the idea here is that you can still reuse your AMP content within the progressive web app. And a common scenario could be that you're building a progressive web app as a single page application that connects to a JSON API through AJAX. And I know, it kind of looks like I'm trying to set a world record in acronyms here. I'm sorry about that. It's a lot of fancy words. But the thing here is, like, with the JSON API here, then, it will return a number of data sets to drive the navigation and then the actual content of your site. So the way you can do it is that you start by including Shadow AMP in your progressive web app. You load the AMP library in the top-level page, but it won't actually control the top-level content. It will only amplify the portions of the page that you need it to. And then secondly, as you would normally do, you handle navigation in your progressive web app. But then the final twist here, that you then use the Shadow AMP API to render AMP pages inline. So it could look something like this. You have a progressive web app shell around everything, but then when you start tapping, you get the AMP content and the AMP pages instantly within the progressive web app. So it's been a really good combination in that way. Another thing I want to mention is the Network Information API. And we had this for a while, but people have been really asking for detailed information about bandwidth to convey the HTTP client's network connection speed. And network speed here is provided as an estimate of the current transport RTT and the network bandwidth. And it also takes constant variation and user variation into account. As you might know, 4G doesn't actually always mean the 4G speed you would expect. But still, though, if you're building things, you're doing a really good job, but it's not really fast enough for your users at the end of the day. How do you know when to deliver even lighter experiences? And one really good option here is to check for the save data request header. And this is available in Chrome, in Opera, and in Yandex browsers. And the idea here is really to deliver fast and light applications to users who have opted in to the data savings mode in their browser. And for instance, in Chrome, if you turn the data saver on, it will send this header with on as the value. So it basically looks like something like this. It's easy to check the header and then know what the users want and need here. But also, if you're building something or using something like a service worker, you can inspect the request headers and you can apply the relevant logic to optimize the experience. So you can, for instance, return an alternate response like different markup, smaller image files, smaller video size, and much, much more. And within the Chrome Dev tools, if you start inspecting headers there, you would just find saved data really quickly, and then you can adapt the code. The third part here is about addressing intermittent connectivity. And Maria showed us before in the What We Learned section that around 50% of the users in India are on 2G. So slow or intermittent network conditions are really big challenges for reaching users, but also giving them a good experience. And here we really see service workers as a key technology to address that. So what are they and how do they work? Basically, it's a programmable proxy sitting between a network and the browser. But it's more than that. So when a page registers a service worker, it adds a set of event handlers to respond to things like network requests, push messages, updates to the service worker, and much more. And because it's being event-based, it doesn't need to be resident in memory unless it's handling one of those specific events. And also, kind of a side note here, there are two interesting options for poor network conditions, but also devices with slow disk access. And the first one is using timeout for slow networks. So for instance, if you have a slow or intermittent network condition, you can create a timer in the service worker where you give the network a chance to deliver a resource within, say, 1 second. But if it doesn't, then you can fall back to the local resource. A small note here, like don't set a timer that's too long, though, because the service worker might get killed or replaced by a new service worker. The other really fun thing is race conditions, because with some devices, it might actually be faster to go to the network and get the content than going to disk, which is not what you would expect. But this is a really good, interesting way of testing that. And of course, both with the timer and with going to disk or not, it's always important that you get data from the network to have it locally, just in case. And Maria also mentioned Nigeria, and seeing 2/3 of the users being on 2G here. And one company there called Konga added Service Worker to streamline the site to help consumers really reach the parts of the site they wanted to browse. So they can go through categories, they can review previous searches, and they can actually even check out by then calling into order, all by being offline. And as you can see, the results was much, much faster than native, like 92% less data for the first load and 82% less data to reach the first transaction. But it wasn't just faster than native, it was much faster than the previous mobile website as well. So 60% less data for the first load and 84% less data to reach the first transaction. And the fourth part, and Maria was talking about, over 20% of users in countries where we see the next billion users are coming online are searching in 2 or more languages. So we have something called the Search Console, which is a tool from Google to show how your site is doing in Google Search. But you also have something in there called Search Analytics, which looks like this, which shows you queries, positions and results, clicks, click-through rate, and much more. And you can filter information in many ways in here, like applying the country and the device filter, for instance, to see from which countries we're getting the most mobile users. And also, in this example, the majority of the users of the site are coming from China, Indonesia, and Malaysia. So it's really worth investigating whether the content is available in language they understand, and also if they can complete the key user journeys. And you can also track performance, specific pages, specific queries, and much more. And finally, about guiding new users. It's really about making sure to help users when they come to your website the first time. And we've seen really good numbers from add to home screen here, in this case with OLX. Like the users browsing around, they're looking, they see what it's like, and then you get to a certain point where you get the add to home screen prompt pop up. And they then choose to add it to the home screen, and then they get the icon of the home screen. It's really easy for them to get back as well. And one really, really interesting number to share with you here now, that I actually don't think has been anywhere else here at I/O so far, is that we see users 5 to 6 times more likely to use add to home screen than installing the equivalent native app. That's a pretty big difference. And in India, we saw Flipkart with 63% of the users on 2G. And again, being fast was essential, right? And user service worker and all that to achieve this. But one really interesting part here is that they really worked on when to show the add to home screen prompt, and now they see really great results. So 60% of the users are now coming from the home screen icon, which is fantastic. But it's not only a lot of visitors, it's also high-quality visitors. So people coming from the home screen icon, they convert 70% higher than the other ones. So summing it all up, as you see in applying the 5 principles that we learned about, removing barriers through using progressive web apps and the web. Optimize speed by using AMP and progressive web apps together, but also the network information API and the save data header. And for addressing intermittent connectivity, service workers is really your best friend here. And make sure to have multilingual support and understand your users and which languages they're actually using. And then adding features like add to home screen, which has been really successful to make sure that you actually guide users throughout the journey. And with all of this, we hope this is good advice and good numbers and good learnings for you to go out and build for your next billion users. And if this sounds great, which it does, right? You would go to this website and you would get a lot of advice and guiding to actually how to get started. And also Tal, Maria, and I is just going to be out here around in the corner in the big round fluffy thing in the mobile web sandbox. So please come over, ask us questions, and tell us what you're building. On behalf of all of us, thank you, and go out and build great things.
I was in HR, I was working as a recruiter, and I was completely unaware as to what I am supposed to do. I used to feel that I just don't want to be a recruiter, I want to be on that other side, talking technology and talking about gadgets and how technology is changing our day-to-day lives. One of our relatives, he challenged me that you are a girl and engineering requires a lot of designs and drawings. I wanted to prove him wrong, and that was the time when I heard about Udacity. I started taking some online courses in Java and Android, very basic things. It is little difficult, but it's just that I don't want to feel that, that sense of regret. I just don't want that. So Udacity has actually been a savior in my life. The quality of the projects is very good. It's like, after completing those, you feel like you have conquered something. Actually, I finished my nano degree yesterday, and so today it's just going to be the celebration.
I couldn't be happier to be here to see the launch of the Android skilling program. There's going to be so many new great Android developers here in India.
Good morning, everyone. Thank you so much for coming. Some of you know I'm from Delhi. Always fun coming back and meeting all of you.
We can scale up developers and scale up mobile developer training to help make India a global leader in mobile app development.
Having the universities teamed up with us in the skilling program is going to be a huge opportunity and make a huge difference.
Finally, we've launched it. It's been a year since we first introduced this program. 2 million developers.
I think that it's a really achievable goal, and I think that it would do a lot for improving the environment in the country in terms of hands-on programming. So I think it's great.
It's a massive number. The possibilities are immense. India will be the largest developer base globally, and just to get everyone to start thinking about Android and developing for Android, we're at the cusp of a revolution.
Let's do something big. More games, more users, more success.
Yes.
Everything more.
Developing a successful app isn't easy. To reach a broad audience, you'll need to consider your iOS, Android, and mobile web users. And to build for these platforms, you'll need a backend server to store data and support the apps. Of course, you want to get your users logged in, hopefully lots of users, which means your backend will have to scale. Then after you've solved your scaling problems, you'll have to find more ways to spread the word to get new users. But have you found a way to measure all this activity? And oh no, your app is crashing and causing servers to melt down, and you haven't even made a dime yet. Don't you wish this could be easier? This is why we built Firebase. It has all the tools you need to build a successful app. It helps you reach new users, keep them engaged, scale up to meet that demand, in addition to getting paid. From the beginning, with Firebase, you'll have test lab and crash reporting to prevent and diagnose errors in your app. Your backend infrastructure problems are solved with our real-time database, file storage, and hosting solutions. Acquiring new users is easy with invites, AdWords, and dynamic links. And using the authentication component, you can get those users logged in with minimal friction. Once installed, you can keep your users engaged with notifications, cloud messaging, and app indexing. Then, with Remote Config, you'll have the freedom to experiment with new features and optimize the user experience in real time. And of course, you can earn money with the same AdMob component that's been monetizing great apps for years. Last, but certainly not least, our all-new Analytics component, designed uniquely for Firebase, brings insight into how well these components are working for you and your users. With Firebase Analytics, you can measure and optimize your advertising campaigns, discover who are your most valuable users, and understand exactly how they are using your app. Now, all these components work great on their own and provide a solid infrastructure to build out your app, but they work even better when combined in creative ways. So let Firebase handle the details of your app's backend infrastructure, user engagement, and monetization, while you spend more time building the apps your users will love. To get started right now with Firebase on Android, iOS, or the web, follow these links for more information. Then, to manage and monitor your apps connected to Firebase, there's a web console to view crashes, set up experiments, track analytics, and a whole lot more. And to learn more about Firebase and all of its components, you can read the documentation right here. We can't wait to see what you build.
Thank you for joining us here today. India is coming a long way, as I just mentioned. Today, India is the second largest country in the world in terms of number of developers. Soon, it's going to be number one.
What we want to invest in is actually training the faculty from your colleges.
The potential is so great, and what Google is doing to help catalyze that innovation it's really an exciting time for these campuses.
We are really trying to provide the best possible experience to teachers in these faculty hubs, because the first step to training 2 million developers is to train the teachers that are going to teach those 2 million.
Industry as of now demands a lot of updated curriculum. Developing 2 million Android developers. Working in a technical university, we can contribute hugely on developing those million app developers.
So we're excited that all the raw materials are there to create an innovation revolution in India.
I really think the students are going to make some great things, and I can't wait to see what comes out.
There's a lot of potential in India, and we need to take it forward.
With Google, we can provide rich opportunities to all. That is the essence of Google program, which I have seen.
This is a good move, and this program will definitely be useful to the students, because app development is going to rule the world for next few years, believe.
let's now take a quick look at Google Cloud. There's two things that I want to check out, and Jen is here to tell us all about them. Hi, Jen.
Hi, Timothy.
So what's this? Because I really want to play with it.
So this is Kubernetes Whack-A-Pod, and it is a demo in which you battle Kubernetes, where you are trying to take down a service by being the cast monkey. While you're doing that, Kubernetes, which is a container orchestration framework, an open source project, will try and keep your web service up.
That sounds like fun. I'm going to totally try and take it down.
Yeah, give it a spin. You're going to hit the button and you're going to battle for 30 seconds. Ready? Here you go. So you're doing great. Kubernetes bringing those containers right back up. And the YOLO is special. It'll take out the entire web app in one go. Oh, and it's down, but Kubernetes is already bringing those containers right back up. You're doing great. 4, 3, 2, 1, and you are done. So during your 30-second battle, you took out 58 pods and caused 9 seconds of downtime. But it seems Kubernetes was victorious in getting about 70% uptime. But it's still a very good attempt.
Awesome, that was a lot of fun.
I love that demo.
All right, so I'd also like to check out Spanner, because I think Spanner is like one of the coolest things ever created.
Spanner is pretty amazing.
So I want to check out what this visualization is. Maybe you can give us a quick rundown of what Spanner is and then tell us what's happening here?
Sure. So Spanner is a managed SQL database. What makes it special is it is massively horizontally scalable and can handle huge amounts of traffic. And you still have the wonderful features you would expect from a SQL database, like queries and transactions and other neat, shiny things like live migrations. Yeah, and it's fully managed, which is pretty cool. Who likes managing your own database? This is a view of the schema that is an example schema on Spanner, which is the same thing being used to power the demo on the screen next to us.
You know, if I can, I think one of the things that I've always really liked about Spanner is the fact that it stays in sync, even though things are happening in different... Can you tell me a little bit more about that?
Yeah, that's a great point. That's one of the special features of Spanner. Spanner, in this particular demo, we have Spanner running on 3 different data centers on 3 different continents all over the world, and yet, due to some magic involving atomic clocks and very precise timekeeping, we can still serialize all those transactions and maintain that consistency.
That's cool. So what is actually happening on the screen here?
So on this screen right here, we are simulating a pretty amazing ticket sales event, where apparently, whatever this ticket sales event is, we are selling 137,000 tickets every minute. And so far, this demo, which I believe we started this morning, has sold 238 million tickets during its run through. You can see that they're distributed across the world, and even despite all that really high throughput, we're still maintaining about a second of latency on those transactions.
That's amazing. Okay, is there anything else you want to tell us about what's happening here at I/O?
It's a great show, but other than that, I think we found the fun spots.
All right, thanks, Jen.
Yeah, thanks so much, Timothy.
Okay, see ya. I'll be honest, it's not a party if there's not a photo booth. So I found the photo booth, and the guy who built the photo booth, Alex, was going to tell us all about it.
Hey guys, so this is a talking photo booth. For an operating system, it uses Android things, and you talk to it using the Google Assistant, and it uploads photos to the cloud using Firebase.
Awesome, so we try it out?
Yeah, let's do this.
Where does it talk out of there? What about the speaker? Okay. Okay, Google, let me talk to the I/O photo booth.
Sure, here's I/O photo booth. Hi, I'm the I/O photo booth. Okay, taking a picture. 3, 2. Don't look so serious. You're in a talking photo booth. 1. Do you like it?
Yes.
Would you like some style for your photo?
Yes.
Just a minute. Downloading styles.
That's 56K, I can tell.
Here you go. I'm uploading your photo now. Can I share this on my Twitter too?
Yeah.
Yeah.
Got it. Uploading your photo. Printing a link in the photo now. Don't forget to share your photo with hashtag O'17 and have a great time at I/O.
That was awesome.
Thanks. That was a lot of fun.
All right, thanks, Alex. Hey, look at us. All right, so I'm here with Doug from Firebase, and there's a lot going on in the Firebase area, a lot that developers have already been able to play with and know pretty well, but there's also some new stuff, and I've asked Doug to show us some of that new stuff.
Yeah, so announced today, actually yesterday at Keynote, we found out that Firebase now has Firebase Performance Monitoring, which is a set of tools you can use to measure and monitor the performance of your app. So let's take a look at that. All right, so this is the dashboard. What we have here is an overview of the performance of your app. So we have traces by frequency. You can think of a trace like a window of time that's of interest in your app. Also, we can look at the latency of your network connections all over the world. We can also see the success rate of your app over time. So it looks like things are getting a little bit worse for this app as time goes on. So that might be something to pay attention to. Now, if we drill into traces a little bit, we can see that there are a collection of automatic traces, so we capture these for free automatically, and here's some custom traces that have been defined by the app. So you have the flexibility to write code to get some performance, or you can just let it do things automatically. Now if we go to network requests, we can get a breakdown of all the HTTP transactions that are going in here. And you'll notice that there's some wildcards, so we're actually bundling up different kinds of requests that look the same but actually have different parameters. And you can see for this set of APIs, what's the average response time, what's the success rate, and the number of requests that have gone through the system. You can click through to this and see how it's going. So you're probably using a lot of different SDKs. You probably want to know how they perform. You probably want to know how the app is performing from your user's point of view, and this is a great tool to get that done.
Awesome, Doug. That's really cool. And it's really neat to see all the data in this way.
Yeah, no, it's definitely very helpful. It's definitely also very interactive. It's not just a dashboard that you look at, it's a dashboard that you interact with. So.
It's actually one of the really cool parts about being at I/O is that if I were just to set this up on my app right away, I might not have all this data right away. But we're showing a demo here where we've collected a bunch of that data so you can see what it's like once you've invested for a while.
Yeah, definitely. There's nothing worse than opening up a dashboard and having nothing staring you in the face, right? It's nice to be able to see what you're getting into before you actually get into it.
Absolutely.
Starting. Good morning, everybody. My name is John Pallett, and I'm a product manager with the Chrome Media team.
And I'm Swa, and I love working with web APIs.
We are here to talk with you about the future of video and audio on the web. And we are going to talk a little bit about how we got where we are today. We're going to talk a little bit about what you can do today and show you a couple of demos, and then take a look at what's coming in the future. That's an awful lot to cover in 40 minutes, and so we're going to get right into it. So to give a bit of context, let's start back in 2000 when I bought my first HD television. The Super Bowl was just broadcast in HD for the very first time. I was pretty excited. There weren't any DVRs for HD or anything like that, but it seemed like a pretty good thing. And it looked great, and it played great, but over the next few years, there wasn't a ton of stuff that happened. DVRs came onto the scene, Skype came out, And we were able to do postage stamp side video conferencing on the desktop, which was pretty cool. YouTube came out in 2005. Amazon and Netflix started streaming about 2007, but for a large degree of us, for most of us, this really meant that we were watching video on the desktop or sitting on the couch watching television at home. So at the end of the day, over 10 years, there wasn't a huge amount of change in terms of mainstream user behavior. Well, now let's look at what happened with my daughter. About 2010 is when she really started consuming media, and around about that time is when tablets came out. And all of a sudden, you could take your video and you could watch it anywhere. This is also about when video conferencing really did go mainstream with apps like FaceTime. 2011, Twitch, video game streaming, comes online, and all of a sudden people are sending video all over the place. And 2013 is when Snapchat came out, 2014, Musical.ly, and suddenly millions of teenagers are creating little music videos and sending them to all their friends. And then in the last couple of years, 360 video, augmented reality, virtual reality. You can see that in the last few years, the pace of innovation has really accelerated for video. And really, when you look at it, as mentioned in the State of the Union, 70% of the bytes being shipped over the internet today are video. And that's actually projected by Cisco to go to 80% in 2020. This is a really big deal. This is the decade of video. Things are happening fast, and it's a really great time to be thinking about video. So if you're wondering what session to be in, this is, in fact, the right one for this time slot. It's a really, really pivotal point. But here's the problem. We look back over that time. Where was the mobile web? Some of the apps I mentioned actually have URLs as names, but when you go there, it tells you to install an app. The mobile web didn't play a big part in the innovation that's come so far, which is a little weird because it's frictionless. You want people to get in. You want them to get out. You want them to be able to see things quickly. These are all things the web is really, really good at. You'd be forgiven if you thought, well, yeah, that's because the mobile web's not very good at video. And it's true. Over the past few years, as recently as a year ago, there have been a number of problems with the way the mobile web handled video. Let's look at the first one. Buffering. A lot of video publishers were so focused on Flash that HTML5 was a secondary thought. The mobile web wasn't even a thought. And in a lot of cases, what you'd have is you'd have a giant video file sitting on a server, and when you went to access that over the mobile web, it would take a long time to download, and you'd be stuck waiting for it to play. Or they would think about the mobile web, and they'd create a very small video file. And now you would download it, and it would look awful. So great, no buffering, but the video quality is just terrible. The publishers who didn't think about the mobile web from a video perspective often would do the layout for the desktop site and not check some of the mobile sites. Now, to be fair, a lot of the APIs to do this correctly didn't even exist a year ago. So there has been a big change in the web over the last 12 months in terms of its ability to do video, but this is what you were looking at a year, 2 years ago. And of course, if you went offline, your media experience was pretty terrible. I like the dinosaur game. It's not going to keep me going on an airplane for 4 hours. So now let's take a look at where mobile web media is today. To show you this, we have a demonstration application, which was written by Paul Lewis and our developer relations team. Let's go to the application, please. And what I'm going to show you is what you can do today on the mobile web. So this is a progressive web app, and it's called Biograph. When I went to the website for the first time, it asked me if I wanted to install on my home screen, which I did. And so now when I launch it, you can see it comes up, gives me a nice splash screen, and goes right into the frameless app. If I take a look at the task manager, you can see there's no Chrome frame around this. I'm going to keep re-emphasizing the point. This is a web page. This is what you can do with a progressive web app. It looks great. It doesn't look like it's in Chrome, but under the hood, it's actually being delivered by the browser. So I can scroll through. You can see it's fast, it's seamless, it's very responsive. If I hit play on video, it comes up very quickly. We didn't get a buffering event at the beginning. Now, I wish I could say that the Wi-Fi here at the show was so fantastic that you will never experience buffering with video, but that's not what's going on here. In reality, because it's a progressive web app, it's able to pre-cache the first second of video or a few seconds of video, so when I hit play, it was instantaneous. Let's take a look at some UI elements here. If I rotate, I can go full screen. You can see that I've got custom controls allowing me to go back and forward. I can also drag on the timeline. I can get some great thumbnails. Not really what you'd expect from mobile web playback, is it? If I go back into portrait mode, the device automatically pops back. Let's take a look at what happens if I go into lock screen. There's a lot of cases where I might want to hear the audio on the video, but I might not necessarily want to be watching it. You can see here, it's a little dark, but there's a background image filling the entire frame, and I have media controls. Video in this case, and media, true with audio as well, is now a first-class citizen on my mobile device, and it lets me know what's going on in the background. If I unlock and I go to the notifications, you can see I have controls there as well. Now this is all great, but what if I'm getting on that airplane? Well, I have the ability to take media and make it offline in this app. This is using an API that's still in development called Background Fetch. What's neat about Background Fetch is that now it's pulling down the video on the device, but if I switch pages, or even exit the browser and then come back, let's go back, you see the download continued and finished up even while I was on a different page. And this is great because now, if I go into airplane mode, and I go back to the home screen, the app can actually keep track. You'll notice that some of these video items are grayed out. It knows that they're not available offline. Let's go into this one. I'm going to hit play on this video, which is offline, and we'll notice that after a brief second, it starts playing. So you really can do a complete, excellent video and audio experience on the mobile web today. One thing I want to mention about this video, this is actually protected content. Before I hit play on this, it already had a pre-authenticated license and played it. So when we talk about doing a great media experience, this is something that everybody can do for all use cases. It's ready right now. Thank you. So for those of you who are interested in trying this out, the app name is Biograph. You can access it at the URLs on the screen. It's also open source. There are a lot of really good learnings in here. Paul has been doing a series of developer diaries explaining a lot of the tips and tricks that he has used to build the app, including things like how to get those thumbnails to scrub in the player control. There's a lot of really good information there. We'll come back to these links later in case you missed them right now. So what did we see? Let's start breaking this down. I think that was a pretty great experience because there was fast playback. You had the ability to watch anywhere. It had great UI. And it had really high quality video. So this is the anatomy of a great video experience. Let's tackle these one at a time. It's been mentioned before that you'll lose users if your page doesn't load fast enough. Akamai did a study, and they showed that after 2 seconds, you start losing about 6 seconds of your viewers if your video doesn't start playing fast enough. So it's not enough to just have a great page load. You've got to be able to deliver up video fairly quickly. And the other thing that other studies have found is that you need that playback to be sustained. It needs to be continuous. It doesn't matter if the network goes up and down. Anytime a video buffers, you're going to lose people. Well, let's start with the playback. The challenge with playing back video is you have to pull a lot of data over the network, and the network is not constant. The user might go through a tunnel. They might lose bandwidth. So there's a way of dealing with this called adaptive bitrate streaming. What we'll do is we'll encode the video at multiple bit rates. Here I have low, medium, high. In practice, you'd have 6, 10, 12, or more different bit rates that you're encoding to. The next thing I'll do is I'll break the video into segments, in this case 6-second segments, and I'll encode the video segments at each of those different bit rates. The reason I'm doing this is now, when the user hits play, the player can look at a playlist which knows where all of these different segments or fragments are, and as the video plays, it can adapt to the bandwidth, going up in quality and resolution when there's more bits available on the pipe, and going down when the bandwidth goes down. This in the demo was done through the open source Shaka player, and what it does is it reads the playlist and then it pulls the appropriate fragments of video and feeds them into the video tag using MSE, Media Source Extensions. Another thing we need to talk about is startup. Make sure it plays back quickly. This is a proof of concept done by TheoPlayer, And what they're doing, we'll wait for it to come back in a second, what they're doing in the first section here is they're using service workers to pre-cache the first few seconds of video as the user browses the page. So here we go. The user is browsing their page, and eventually what they'll do is they'll select a video and start playing. But they don't wait for that indicator to get ready for video playback. Even while the user is here, they've already pulled down the playlist or the presentation description. And you notice on the left, where it's been pre-cached, the video playback starts right away. On the right, it takes a few seconds. And in fact, if you're pre-caching with service workers, in their example, they were able to get playback from over 3 seconds before the video started down to about 100 milliseconds. So service workers really can make a big difference. Progressive web apps have a lot of powerful capabilities that they bring to video. And in fact, you saw this pre-caching in the Biograph demo. You remember when I hit play, it started pretty quickly. Well, that's because under the hood, Biograph had used a service worker to pull both the presentation description and the first segment of video into the browser cache. And then when Shaka went to access it, that presentation description and that first segment were pulled by the service worker from the cache. After that fragment started playing, Shaka then went and started pulling the next fragments of video over the network. What this means is the user gets fast, fluid, instantaneous playback, which really is like almost every other element in HTML5. You want something responsive and quick that happens right away. I cannot overemphasize how useful and important service workers are to optimizing the speed of your site. One recent case study that we did with Viacom18 on their Voot site optimized their mobile web page. Their page load times went up by 5x, so 5 times faster. And this had a big impact. This is a media site. It had a big impact in terms of return engagement for their users, as well as the engagement of new users. 77% increase, and then conversion from new visitor into an actual video viewer. And then a 15% increase for all of the users in terms of the number of videos that they watched on average. So you can see a little bit of optimization and a little bit of performance goes a long way in terms of increasing the engagements. So that's fast and fluid playback. Let's move on to offline. Offline is really, really an important use case for a number of reasons. One is obviously the airplane, which is something that I, of course, because I fly around, care about. There are also a lot of cases where you'll have viewers or potential viewers who would like to access the video in places that do not have internet access. We've actually seen those users trickle load using the default HTML5 player videos, waiting until they get all the way into the cache, and then they'll take the device and go somewhere else, saving the video for later. That's really not the best way to do offline for anybody who's thinking, oh, that's going to be my new offline strategy. Please don't do that. What you can do instead is use service workers. And when we saw this in Biograph, what Biograph had done with the offline video is it pulled down the playlist, or actually the presentation description in this case. It pulled the presentation description and all of the media segments at a reasonable bit rate into the cache so that I could play it back here at the show. Now, you might ask, which bit rate would I want to choose? Do I want the highest bit rate? Do I want the lowest bit? That's really up to you. You control the logic in the service worker. You control what quality, or you can give the users control. Let them download an HD version if you want, or let them do a low bitrate one if they want to save more on the device. I keep talking about video. This is a really great use case as well for audio. This is something you could do with a podcast. It's also something you can do with a variety of other audiobooks, other types of audio material. Now, I mentioned during the demo that the actual fetching of it, the pulling into the browser cache, was being done by an API called Background Fetch. This API is still in development. This is a good example of something that we very much would like you to look at it now and give us your feedback. It's available if you turn on the experimental web features flag, but take a look at the spec. This is the time. If you have feedback on how this should work, please do let us know. I mentioned a second ago that there's a decision either for you or on the part of the user in terms of how much video do you really want to put on the device. Wouldn't it be great if you could get twice as many videos on the device without sacrificing quality? Well, of course it would be. And this is where video compression really comes into play. Video compression is what gets used to take video and turn it into something that we can actually send over the network. And VP9 is the WebM approach to video compression. It's also known as a codec, which stands for coder decoder. And so if you hear me say the VP9 codec, that's what I'm talking about. It's a compression technology. What's great about VP9 is that compared with a lot of the other common video compression codecs, it can get up to about 50% better compression efficiency, meaning you can cut your file sizes by 30%, 40%, up to 50% while preserving the same quality, or just offer a better, higher quality level. Now, the other thing you can do with VP9 is you can actually deliver higher quality. I mentioned this as a key pillar to a great mobile web experience. VP9 is supported on over 2 billion devices. And so if you want to play high-quality video, VP9 is an excellent codec choice to look at. So good that when YouTube adopted it, they saw videos starting 15 to 80% faster using VP9 compared to some of the other codecs. 50% less buffering and more HD worldwide. There's some really great gains that come from using VP9, a really great high-quality experience. The last piece of the anatomy is the user experience. And one of the things you saw was the lock screen. There are a lot of cases where you might not want to watch a video. You might just want to listen to the audio. If what you deal with is audio, then this is absolutely a primary use case for you. Now, the great thing about this API, which is the Media Session API, is that it allows you to put your metadata and images on the lock screen as well as on wearable devices. It's also great for the user because they can tell what's going on their device and they can control it. So let's take a look at what's going on. In order to use the Media Session API, the first thing I'm going to point out is this is a great example of a progressive feature. The first thing we do is start with an if statement. If the device supports Media Session, if the browser supports Media Session, great, we'll use it. To make things appear, you simply provide a little bit of metadata, title, artist, album, and then artwork. Typically, you might have a longer list of images that you would provide at different form factors. For the sake of brevity here, I have two, 512 by 512, which is the most common Android size for the lock screen, as well as 256 by 256, which is useful for some older devices. Once you've provided that metadata, you'll also want to be able to respond to the controls. And here, you want to be able to seek back, forward, play, pause, next track, previous track. And what you do here is set up action handlers so that when those actions happen, when those events happen, you can take care of them. You may also want to be able to control the playback state so that the user, if you're doing custom controls, get reflection of the media session state inside the lock screen or the notification. In terms of implementing these action handlers, it's not that hard. All you're doing is you're setting controls to the audio or video tag just like you would if you were doing controls on the web page. So it's pretty easy, and it gives a much better user experience. Here's another key part of user interface, full screen mode. This is a good experience. I hit play. If I turn into landscape, it automatically goes full screen. This is also a good example of something that you couldn't do a couple of years ago. Let's take a look at how you do this with the Screen Orientation API. Again, a progressive feature. If the device supports the orientation feature, then what we'll do is we'll listen to when there's an event changing that orientation. If the orientation has become landscape, we'll go full screen. Otherwise, we'll go out of full screen. That's it. That's, 8 lines of code? And all of a sudden, you can make the user experience significantly better for media on the mobile web. So you really can do great media experiences on the mobile web today. Fast playback, the ability to watch anywhere, great user interface, and high-quality playback. And this is really great stuff. It's all available today. And anybody who's sitting here remembering the title of the talk is going to be saying, wait a minute, I thought you were going to be talking about the future of audio and video on the web. This is actually the beginning of the future, and a lot of sites are just now adopting this technology. I hope people in the audience, you're looking at this and saying, we're going to do that as well. So to some degree, this is the short-term future, but let's look a little bit further out, because all of that is available today. Let's talk about what's coming out afterwards. So let's start with color. There are a new set of standards that are coming out around video which are dramatically improving the realism of what can be displayed. And there are a new set of displays, today televisions, coming soon to mobile and desktop near you, which increase the realism dramatically. Part of that is color. So for people who don't work with photos and videos all the time like I do, it may be a surprise that your display cannot actually reproduce all of the colors that you can see with your eye. This curve shows the full spectrum of colors that the eye can see. In fact, it doesn't, because that projector and this screen can't display all of the colors that your eye can see. But let's pretend it does. Your standard sRGB monitor today can only represent part of it. The new video standards around BT 2020 are dramatically extending that color. So colors like my shoes. These shoes probably are not going to represent properly on that screen, but some of the new televisions you're going to get a lot closer. Another aspect of the new video standards is the ability to show a wider range of brightness. And what I mean by that is brighter brights and darker darks. If you look at a standard monitor today, it's doing what's commonly called standard dynamic range, or SDR. And the range of brightness there compared to what you see in the real world isn't really that dramatic. The blacks aren't really that black, and the brights aren't really that bright. As we move into high dynamic range, what's happening is that displays are coming out that cover a much broader range. What this requires under the hood is a change in terms of the electro-optical transfer function, the EOTF, which you may have heard of as the gamma function. There are a whole new set of functions for converting digital values of brightness into what actually gets displayed on the screen. What this means for anybody working in video is you need to know whether or not the device can support those EOTFs, and also make sure that you understand the characteristics of the device you're playing it on. So let's take a look at how we could do that, both for color and for HDR. From a color perspective, this is where the CSS Media Queries Level 4 come into play. The color gamut query is now supported in Chrome and will allow you to query the device to determine the breadth of coverage of color on the device. On the bottom, there's new is-type supported strings coming, which will allow you to query for VP9, which, by the way, does do wide color gamut and high dynamic range with VP9 Profile 2, full 10-bit, allowing you to determine whether or not HDR is supported, as well as the electro-optical transfer function. These new advances, as well as some of the most demanding low-end bit rates, all bring me back to video compression. And there's some exciting news going on here. What I want to talk about briefly is the Alliance for Media, or the AOM, which is a cooperation between a number of companies to create a new open-source royalty-free compression format. This includes YouTube, Google, Amazon, Twitch, Netflix, Microsoft, Mozilla, Hulu, the BBC, are all part of this cooperative effort to create a new compression format that will tackle not only HDR and wide color gamut, but also 8K and 4K, 360 video, as well as, and arguably more importantly, providing video in the most demanding low bit rate situations imaginable. Important for billions of people around the world who do not have the same level of connectivity that we do. This work is going on now. The name of the codec that they're developing is AV1. And just a few weeks ago, Netflix came out with some of their first analysis on the performance of the codec, and what they found is it's not even done yet, and it's already getting 20% better compression VP9. This is not yet available. We're in the future section of the talk, but this is absolutely something to keep an eye on as it rolls out. But when it does roll out, one of the questions you might ask yourself is, great, well, can my device play it back? And this is something that's interesting and unique to the web. Not all devices perform the same way. Ultimately, you want to give the user the highest possible video, but the 1 gigahertz system on the left probably doesn't have the same kind of hardware decode support as the device on the right. This is important when AV1 comes out. It's also important right now, quite frankly, for different video playback capabilities. So let's look at VP9. If I want to detect whether a device can play VP9 today, I'll use the can play type function. I'll pass in WebM-VP9, and it'll say, can you do that? And it will say, probably, and you'll say, okay, here's some VP9, please go play it. Now, what that doesn't really tell you is, are you going to drain the battery? Are you going to play this back at high quality? Are you going to be dropping frames? So there's a new API coming out to address this called the Media Capabilities API. And this allows you to fine-tune the video playback experience for the user. On the top, again, a progressive feature, you say, if we have this Media Capabilities API, I'm going to pass in the resolution and bitrate and the codec of the video I want to play, ask for the decoding information, and then it will tell you, number one, is it supported? Number two, will the playback be smooth and fluid? And number 3, will it be power efficient? Now, you can use this information to make decisions about not only what type of video you want to send, but also what resolution of video you want to send to optimize the viewer experience based upon your specific use case. But we haven't talked about what I think personally is the area of greatest innovation and growth in video and audio that we are seeing right now, particularly over the last few years. My daughter's ability to make mobile music videos on her phone and her ability to put things on her face and communicate with other people is all social. It's all about sharing. It's all about communication here. It's hard to remember. This was not mainstream as recently as 5 or 6 years ago, but it has quickly become very mainstream. The whole premise here with social is you want people to get in, get out, and be able to do things quickly, which is great for the web. So let's talk about the most personal social media, video communications. Web real-time communications, WebRTC, is not new. But what is kind of interesting over the last year or two has been the rapid adoption both by the browser manufacturers as well as the app platform. There are sites now that are using it on the scale of tens and approaching 100 million users on the site. So what is new is that progressive web apps make WebRTC really interesting. On the mobile web, you have the ability to provide people with a website that uses WebRTC on the phone and let them jump in, communicate, jump out. Add to the home screen, they can come back. So there is a next step here as far as peer-to-peer personal communication. And that's fine for one-to-one. But let's talk about another type of social event, which is live streaming. How is this social? Well, if you're sending video to 10 people, they probably want to communicate with you. If you're sending video to 1 million people, they probably want to communicate with each other. It really depends on the event. And what's really neat about this is that where you look at all of the platforms that support live streaming today, the web has a pretty unique advantage in terms of the feature set as well as the way people use it. If you want to share something, you simply send somebody a URL. They don't have to download an app in order to watch it because this event is happening now. Don't make users wait. This is where the web can really come into play. Now, the truth with live streaming is that there's a whole infrastructure challenge underneath the hood. And what I mean by that is if you're deploying to 1 million people and you want latency, low latency rather, you might take a different approach using files that are getting placed out onto the CDN or even files that you're reading while they're growing as they're placed out on the CDN. Or you might use data channel WebRTC and do peer-to-peer CDNs to deliver it. I am not going to go into all the details on that because that would use all our time. But what I will let you know is that the web does support live streaming, both in terms of WebRTC as well as the ability to put out the video segments in the form of files and play them back. And in fact, Shaka has the ability to do this by reading dynamic presentation descriptions and then as the segments become available in the network, knowing the appropriate seek range as well as the end so that it knows what to play back. And all of that's great. But there's the last piece of social media that we want to talk about, and that's creation. If you look at the way that something where you are creating video and sharing it with your friends works, it's really a beautiful cycle. It starts with somebody finding something and watching it and getting inspired, and then they say, now I want to make something. And then they capture, and they create, and they encode, and they upload, and they share it with their friends. And then their friends say, ooh, that's very cool, and they get inspired, and they want to capture. And so this really only works if it's easy to discover, it's low friction to watch, and then also low friction to get into capture scenario. This cycle can go very, very fast as long as the whole path is very easy. The web has a lot to bring here, and to show you an example of what's coming in this space, I'm going to take you to Francois.
Thank you, John. I'd like to share with you a simple web app I've been working on and use it to showcase some awesome media capabilities coming to the web. May we switch to the Android device, please? So this web app is called Moustache, and you will understand why soon. I have previously added Moustache to my home screen and specified in the web manifest that I wanted to run it in standalone mode so that the browser UI does not show up. It is quite hard, almost impossible, to tell that this is a web app. So now you can see me with moustaches and wearing a funny hat. Not that there is no lag here. It is perfectly smooth. May I say creamy? OK, said it. Let's press the record button. And that's all. At the bottom right of my screen, I have a preview video of myself that I can share now. Click the share button, and let's tweet it, for instance. Boop. Or not, please. And that's all. Let me describe what you've just seen and may not have realized by walking you through all the API I've been using for that. Let's start with the basic. This is how you get access to a camera video stream on the web today. Set the video attribute src object to the asynchronous result of navigator.mediadevices.getUserMedia. And you're good to go as soon as the video plays. Note that the only media constraint I pass there is video true. But my Moustache app actually asks for more. The ideal video width, height, frame rate, and facing mode. The browser will do its best to accommodate your request, so it doesn't hurt to ask. My custom draw function is going to be called every time the browser asks for a frame to be animated, thanks to the request animation from function here. Since I'm looking for the smoothest experience there, that means the draw function is going to be called approximately 60 times per second. And each time it's called, I'm going to draw a live video frame on my canvas. At that point, we have our face on the screen. And that's not bad, but let's go further now. Using the experimental shape detection web API, I was able to draw some moustaches and a hat on my moving face while keeping the app running smoothly at 60 frames per second. As a matter of fact, that wasn't the case last week, so thank you, Miguel, for working hard to get this demo ready for today. As you can see, this is a pretty simple and easy-to-use API. As hardware-accelerated detectors may potentially allocate and hold significant resources, I recommend you reuse the same face detector object when doing several detections. The fast mode option here is a hint for the browser to prioritize speed over accuracy, which is exactly what I'm looking for in that case. Let's look at what is happening now in the draw function. Calling faceDetector.detectCanvas returns asynchronously an array of detected faces in the canvas. Note that the processing is all done on device, so there is no internet connection required there. When a face is detected, I use its position, x, y, width, and height to draw some element on top of a video frame. One best practice is to use a simple Boolean like is detecting faces to avoid overrunning the API, as the draw function is called all the time. Pretty cool, right? This API, along with the barcode, QR code, and text detection API, will be available to everyone later this summer for testing purposes in Chrome Stable. Note that you can already play with it today by enabling the experimental web platform feature flag in Chrome. By the way, we love feedback. So if you want more features, such as eye or mask detection, it's a bad example, we have it. But if you want something else, something more, or if you simply stop about bugs, please let us know. Now, how about media recording? Is that hard? It is not, like really. This is the full code I've used in my Moustache app. Grab the stream from the canvas by calling canvas.captureStream and use it to instantiate a new media recorder. The MIME tab option tells the browser which codec to use for the recording. It can be H.264 or VP9, for instance. If you leave it unspecified, though, the browser will choose the best one, which usually boils down to the hardware-accelerated one, if any. You can also pass the bits per second option to customize the video quality of the recording. Recorder.start actually starts recording the media. And each time the recorder delivers some media data, we store them in an array object I call chunks. When the user stops recording, we call recorder.stop, which fires a stop event, allowing us to create a new blob object containing all chunks we've recorded so far and upload that video blob to our backend. I could also have chosen to directly stream these chunks to an RTCP connection, by the way. The media recording API has been in Chrome for a year now, so it is pretty stable. As proof, some popular Chrome extensions use it intensively to record up to 1 hour of content, such as video and tutorials. When I clicked the share button, did you notice that the native Android Share UI showed up and included all my native apps that support sharing text on my device? I was able to do that with the experimental Web Share API, which enables sharing data such as text and soon images from the web to an install app of a user choosing. As you can see, this is as simple as calling navigator.share and pass it a title, some text, and the video URL. And that is pretty much it. These 4 lines of code enable seamless sharing, and I personally can't wait for this API to be available to everyone later this year. Thank you.
Thank you, Francois. That's pretty awesome, right? There's a couple of things in there. One is the Media Recorder API, which I want to highlight because what is great about that is the web creating media for the web. That is something that we see over the next few years is becoming more and more common. But what's really great about this is I love the way that in a plug-in free world, you can connect these items together like nodes and pipe them together using media streams. So camera to canvas to media recorder to upload, microphone to web audio to RTC peer connection. There are a lot of different things you can do with these tools. If you want to access the Mustache demo here, again, to remind everybody, this is a relatively new API. It's still in development, so you do need to turn on the Web Experimental Features flag if you want this to work, and we would ask that you would use Chrome Canary for that. So, that was a lot. I told you at the beginning we were going to cover a lot. So what did we see today? We showed you a couple of demos, and we talked through a lot of APIs, many of which are available today. So in the Biograph demo, which was really about playback, service workers were used heavily. Shaka Player was used for media playback. And then there was a long list of supporting cast of APIs, including the Media Session API, the Full Screen API, the Screen Orientation API, and a variety of others. You don't have to remember all of them, fortunately, because Francois has written a wonderful article on best practices for mobile web video playback, which is available at the link at the bottom. And if you're looking to do your own progressive web app doing media playback, please do take a look at the sample code provided by Biograph. On the Mustache side, Media Stream Recording API, as well as Media Capture and Streams. These are both available today. And at the bottom is the link so that you can access the Mustache demo. Again, Chrome Canary on your mobile device, and make sure to enable the experimental web features. Which brings me to arguably the most important point. We want feedback. Some of what we showed you today, the title of the talk was The Future. 3 of the APIs in particular, background fetch, to allow you to do downloading of media even while the user navigates away from the page or closes the browser. It'll resume when they come back. The Shape Detection API, the ability to look for QR codes, text, faces, and other objects. And the Web Share API, the ability to share items socially. All of these are being developed. This is your opportunity. This is a great thing that's coming in the future, but frankly, it'll be better if somebody in this audience looks at it and says, I would like this. And our developer team and the other developers on the web working on the APIs say, that's a pretty good idea. Please do help us make this a reality by going to these sites and providing feedback. Look at the APIs and tell us what you'd like to see. Or you can see us in person. We will be in the sandbox behind the stage. It's a lot of great APIs. We're happy to talk to you about them. And frankly, we are just really excited. If you look at the pace of innovation over the last few years, the web is coming to play. The mobile web is coming to the media game. And we just cannot wait to see what happens next. Thank you, everybody.
Woohoo!
So you've built an amazing mobile app that your users are going to love, but you want to get it into people's hands and let them see just how awesome it is. Well, AdWords helps you do this, putting ads for your app in front of billions of people that use Search, YouTube, Google Play, and more. You can quickly set up an ad campaign to reach the type of users that might be interested in your app. You only pay if the user clicks on that ad, and you can set the budget and acquisition costs that you're comfortable with. But how do you know you're reaching the right users? Maybe some will install your app and forget about it, while others will make it part of their daily lives. Firebase Analytics helps you do this. You can define events that happen in your app that you consider to be important, such as reaching the first level of your game, purchasing a fancy new pair of sunglasses, or returning every morning to check out new products. You can tell AdWords which of these events are most important to you. Then, AdWords will display ads to people who are more likely to complete these important actions in the future. You can also build audiences, which are specific segments of users, and have AdWords display your app to them. For example, imagine that you have a group of users who are very active, have added a product to their cart, but haven't purchased yet. Well, you can use Firebase to create an audience of just these people, and then use AdWords to give them specific ads and encourage them to come back to your app and take action. Understanding your users and engaging with them at just the right time and in the right way will help you build loyal users for your app. Firebase and AdWords, working together to help you grow your user base. Get started today. Your new users are waiting.
Android Instant Apps make it possible for users to access your app without having to install it first. Imagine users opening your app just by clicking on a link in an email or a text message. We've recently made Android Instant Apps available to all Android developers. To take full advantage of this, we have some best practices to help you make your Instant Apps user experience as great as that in your installed app, or maybe even better. You can find all this and more at the URL in the description below. It's important to keep in mind that by enabling your app to run instantly without installation, you're not creating another additional app. We're thinking of Instant Apps as another way to use the app your users already know and love. It's the same app, just without installation. By adding the ability to access your app directly from a link, a search result, or another app, it's much easier for users to engage with your app and get excited about it. If they decide to keep your app on their device permanently, they can then install it right from within the Instant App. The ability to launch an app without having to install it provides an enormous opportunity. For a long time, app developers have focused on the number of app installations as a proxy for the metrics their business really cares about. Without installation, users simply weren't able to engage with the developer's offerings at all. Removing this barrier to entry enables you to think about the metrics your business really cares about. Your audience is now just one tap away from engaging with your service. Your Instant App is just another mode your app can run in. So don't branch your UI and make any unnecessary changes regarding the layout, interface, design, or experience of your Instant App. The transition from instant to installed mode after installation should be as smooth and seamless as possible. Your users should have a rich and full app experience, even if they haven't installed your app. Rather than thinking of Instant Apps as a limiting factor to what your audience can do, think of it as an opportunity to get them to your functionality quicker and a way to foster your relationship with them. Avoid prompting your users to install the app when they're in the middle of a task. They'll be much more inclined to place your app onto their device permanently after it has had the opportunity to prove its usefulness. Refrain from bouncing them back and forth between your Instant App and your mobile web offerings. You can probably tell by now, Instant Apps are all about removing friction for your users and getting them closer to your functionality. Think about ways you can remove further barriers for your users. For example, wait until users can see the benefit of making an account and signing in until the value of doing so becomes apparent. Asking users to create an account after installation seems like a small additional ask when they've already gone through the app installation flow and are only just getting started. However, when they're coming from a link looking for specific content or functionality, being asked to register can feel very disruptive. Additionally, make sure to use available APIs to make your and your users' life easier. Using Google Smart Lock, for example, makes signing up and signing in a much simpler and straightforward experience. In summary, we really think that Instant Apps will unlock a lot of opportunity to engage your audience more directly. Users will be able to focus on what it is they want to accomplish rather than having to spend time maintaining and updating apps on their phone. We're super excited to see what you come up with. Everything I talked about here and much more you can find on g.co/instantapps. Thanks for watching.
Firebase makes sending messages to your users easy with Firebase Cloud Messaging. It's a free service that allows you to send messages to your users' apps across a variety of platforms. Messages can be addressed to single devices, groups of devices, or even topics. Building a notifications or messaging system with Firebase Cloud Messaging is easy. First, you register your user's app instance with the Firebase Cloud Messaging servers. Then, on your server, you write code that allows you to address these devices by ID, group, or topic, and which tells the Firebase Cloud Messaging server to send the messages for you. It's powerful, it's scalable, delivering hundreds of billions of messages per day, with 95% of messages being delivered within 250 milliseconds to connected devices across many different platforms. It's that easy, it's that powerful. Firebase Cloud Messaging.
People love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer. So you'll want to make sure they each have a great experience, regardless of screen size, OS version, and the features of the app they use the most. It can be taxing to test each one of these situations so that all your users can be happy. We know you'd rather not have to buy and store stacks of devices and test your app in all these circumstances. That's why we built Firebase Test Lab for Android to make it easy and affordable for you to test your app with a variety of devices and be sure it works great for all your users. Our device lab, hosted in the cloud, offers a variety of physical devices ready to test your app. The selection of devices is always growing, so your tests will stay current with the latest hardware and operating systems. The easiest way to use Firebase Test Lab is to run a robo-test. This is an intelligent, automated test that crawls your app to discover and exercise its features. You won't need to write any additional code to make use of a robo-test. For more advanced testing, you can also script the interactions with your app to simulate specific use cases and verify that everything works as expected. Test results include a detailed report for each device used, including screenshots, device logs, and any crashes that may have occurred during the test. This allows you to verify that your app is working correctly on the variety of devices and configurations you selected. It's easy to make Firebase Test Lab a part of your daily development routine, and we have multiple ways to help you test regularly and spot errors early. First, you can use the Firebase console to upload and test your app. There is also a command line interface for testing with continuous integration servers, so you can automatically test every build. During Android development, you can deploy your app directly to Firebase Test Lab using Android Studio 2.0. And finally, in the Play Store Developer Console, there is a special automated launch test that will run for Android apps published to an alpha or beta channel. To get started using Firebase Test Lab and learn how to regularly test your app on different devices and configurations, you can start with the documentation available right here. Happy testing!
When I was 10 years old, my dad got me a book on Pascal. And just a few chapters in, I immediately realized I can create some amazing things all by myself. My name is Shruti Saraf, and I'm a founder and game developer at Blacklight. I always remember my mom playing solitaire on a computer, but when moving to mobile, she struggled to find a good solitaire for her phone. So she insisted that being a game developer, plus her daughter, I should develop solitaire for her. So I took the idea to Sumit.
I'm Sumit Soni and I'm co-founder at Blacklight. I'm 32 years old and I have 25 years of game experience, playing them and now designing them.
We played solitaire for hours. We even bought a deck of cards, real cards, to understand the game better.
60% of our users are mommies and grannies, so we designed Solitaire keeping them in mind. Big bold cards, soothing colors, and minimal design, taking a lot of cues from Google Material Design Guidelines.
It took us 6 months of research and design to make Solitaire look great and be really fun to play. And then we noticed a lot of visitors are visiting our page, but very few of them downloaded the game.
So we thought maybe the logo is the problem. We experimented on Google Play with a modern design and a very old-fashioned one. And wow, the old-fashioned logo had 54% more downloads, and after we adopted it, our total downloads went up by 90%.
Plus, we moved to Android Studio, which allowed us to integrate Google Play game services, and emulators helped us design user interface for different screen sizes and varied pixel density. The feeling that something you have created is adding fun and value to so many people around the world, most of them from places I've never been to, can be quite profound.
Shruti's love for coding and her mom's love for Solitaire led to this. Today, we have 5 more games in the pipeline, and we hired 5 more Android developers to work on them.
It definitely wasn't a smooth journey, but through hard work and great user feedback, we are where we are today, and we can't wait to see what we do next.
Android Wear 2.0 is the most significant update to Android Wear since its launch in 2014. I'm Hoi Lam, and I'm here to take you through 3 highlights of Android Wear 2.0. First, material design has arrived on Android Wear. The new Android Wear interface uses a darker color palette, which makes the watch blend in more in social environments. It also helps save battery by OLED displays. We also suggest that developer adopts vertical layouts and reserve horizontal swipe for activity dismissal. In our research, this makes user interface easier to understand. To help developer implement these new design patterns, we have introduced new user interface components such as the wearable drawer layout and wearable recycler view. Check out the material design for Android Wear site for more details. The second highlight for Android Wear 2.0 is watch face complications. Before Android Wear 2.0, if a watch face wanted to display data from another app, they need a one-to-one agreement in both business and technical terms. To alleviate this complexity, with Android Wear 2.0, we have introduced the Complications API. Complications are a traditional watchmaking term for areas of the watch face that displays information other than the time, such as the date or phases of the moon. We have extended this concept to smartwatches, so any app can publish data for watch faces to consume. And watch faces can display these data in a style that fits into their unique designs. For app developers, this helps increase user engagement and mindshare. For watch face makers, this adds utility to the watch face. Users can now choose whichever watch face they want, as well as getting the data that they need. Check out the watch face and complications sections of the developer documentation for more details. Last but not least, standalone functionality. Previously, Android Wear 1.0 apps require a phone app to communicate with the cloud. With Android Wear 2.0, Wear apps can access the internet directly without the need for a corresponding Android phone app installed. This means the Android Wear app can access the internet even if the user has an iPhone. To help with app distribution, we have also put the Google Play Store on the watch. Users can now download apps directly on their wrist. Apart from these 3 areas of improvement, material design, complications, and standalone apps, there are numerous other enhancements with Android Wear 2.0. Check out the Android Wear developer site for more details. I'm Hoi Lam. Happy coding!
Have you played AppShip 3000?
No, but I'm ready to. And I'm standing here with Abe, who helped build this fantastic experience. Abe, tell me all about it.
Yes, this is AppShip 3000. This is a collaborative Firebase trivia game where 3 people work together to launch their AppShip and hit their moonshot. It's pretty crazy. Played with arcade controllers out here in this very loud situation where it makes you yell to each other and get all hyped up. It's a lot of fun.
Awesome. So we're going to play it, and maybe I'll give you the microphone, and you can sort of narrate what's happening and maybe talk a little bit about the tech.
Absolutely.
Great. So for my fellow team players, we've got Doug over here. Doug, take a bow. And Todd over here, who you may know from such things as everything Todd does. All right, Abe, I'm going to give you the mic.
Yep, everyone's already logged in and they're sitting with their rocket primed for ignition. In order to take off, everyone has a specific color they need to hit. So let's give it a countdown. In 3, 2, 1, take off. There we go, there we go. Now in the game of AppShip 3000, the very first thing that happens is you will get prompted to ask, have you played before? Everyone here has, which is good. And we'll dive right into the game. The very first question, who has it? There you go, there you go. Those blinking things up at the top are asteroids, which will absolutely destroy you. Good, good. Good, good. I'm amazed you knew that. Good job. How many Google engineers does it take? Lovely. Good call, good call. Yeah, you cannot be a true Firebaser if you think pineapples are ugly. All right, while this game's running, I'll talk a little bit about what's happening. But it's a little hard since they're all shouting all the time. Somebody pick something, you're running out of time. Oh. All right. So while they're playing this game, every movement they make is being thrown off into the Firebase real-time database. And the real-time database is taking that, doing some analysis, updating high scores and things like that. So absolutely every move they make is getting thrown off into Google Cloud and Firebase for analysis. All right. Oh, you got to watch out for those asteroids, guys. No, it is not 8. Definitely not 8. Oh, we're low on fuel, If you miss this next question, you are done. Oh, you're so close. Oh! Oh, there you go. That is the end of 754 feet. That is an okay score. That is supremely okay. Good job, everyone. Thanks for playing.
All right, Abe, thanks so much for that.
Absolutely, anytime.
So we're actually going to play another round, so bye.
All right, good morning, Google I/O. I'm Noah Fidel, and I'm going to speak with you today about how to go from research to production with TensorFlow serving. So I'm going to start by sharing a few stories from my past and observing industry. So the first one, show of hands. Who's taken a commercial flight in the last 10 years? All right, everyone's awake and you've taken flights, so this is good. You might be shocked to know that circa 2005, I was working on the flight planning software that plans the majority of the world's flights. This does things like compute how much fuel to take on the plane that you probably care about. But before 2005, that system did not use source control. And for those of you who know what that means, that's pretty scary. It does now. And I raise this just to show how even though we know what best practices are and we publish them and blog about them and talk about them, it sometimes takes a while for them to be adopted across industry. Fast forward to 2010. I was at a startup, and we had a mobile photo sharing app. And we tried to do all the right things. We had source control, continuous integration using Jenkins. And one day, we decided to add machine learning to our app. We trained up a model that could do face detection, auto-crop to faces. This is really great. Our users loved it. Our investors really loved it in 2010. But for machine learning, what is source control and continuous integration? These best practices don't really exist. So I trained that model on my workstation. And if I got sick or if my workstation crashed, no more training for us. We'd have to start over. So here we are in 2017. And at talks like this and other conferences around the world, we have all kinds of great tools and best practices for machine learning. So we have TensorFlow and a whole ecosystem around it, and many other tools. But there are many areas still to be defined. So just as one example of many, what's a continuous integration test look like for machine learning? So you're deploying models every day. You might, when you start doing this, you might make a test that runs some sample data from today through your model, and it does that all the time. What happens when your user's behavior changes? What happens if they look at bigger objects or different kinds of objects, or the distribution changes? So there are many of these things we're figuring out. And I'm going to make a bold statement that I think machine learning is 10 to 20 years behind the state of the art in software engineering. And so we have a ways to go. One of the ways, and there are many, where TensorFlow serving is helping is by making it easy to safely and robustly push out multiple versions of your models over time, as well as the ability to roll back. And so this seems pretty simple, but we've seen people inside and outside Google that don't have that capability. And there are many other things that are part of this as well. All right, so here's the agenda for today's talk. For starters, TensorFlow serving is a flexible, high-performance serving system for machine learned models, and it's designed for your production environments. And before I dive into the details of TensorFlow serving, I'm going to describe what is serving for those of you who might not be familiar. It's pretty simple. Serving is how you apply a machine learned model after you've trained it. Many of the talks on machine learning, both in academia and industry, are focused on the training side. But serving side is kind of left as an exercise to the reader. So that's where we come in. All right, so on the right side of this slide, you're hopefully all familiar with the orange boxes here. If you're at a TensorFlow talk, you should be pretty familiar with these. You have a pile of data. You have somebody doing the role of a data scientist. And you're training a model. And you'll use something like TensorFlow to do that. Now you have your application on the right side. And for the sake of example, let's say that you are ranking videos. So you have an app that users come home from work, and they want to look at some fun videos and just relax. So your application has a list of candidate videos, and your model is sitting over there on disk. How are you actually going to apply it? So the really straightforward and common answer is you're going to have an RPC server. So this server is going to take your model. It's going to load it off of disk. And it's going to make it queryable by your application. So your application can give a list of videos along with their features. And the server will reply back with maybe the probability of each of those videos being clicked on. All right, so moving on to some goals for serving, and in particular for serving machine learned models. So the first one, and this is where serving differs quite a bit from what we're used to when talking about training of ML, is that requests are coming in all the time asynchronously from users. You can't control them. You're not reading them off of disk. But whenever a user sits down on their couch and loads your app, that's when you're going to get a request. So we want to answer these requests online and at very low latency and consistently low latency for all of your users. The next ones are also subtle departures from training. So the first is that you might want to have multiple models served at the same time. So when many groups start with machine learning, they'll have one model that might, as this example goes, serve rankings for videos. But now what happens when week 2 comes along? You have a model, it's working well in production, but now you want to launch a new one. You're not sure if it's going to work. You might run an experiment. So now you want to run 2 models. And maybe you have a couple different experiments you want to run. So that's really common as well. And lastly, who's familiar with mini batching? OK, just a few of us. So I'm going to describe it so we're familiar with this, because it's an important part of both training and serving. So when you take a neural network graph and you process data through it, there's some overhead that happens with all the nodes of the graph and scheduling the work across them. And to get good efficiency, almost all of the training libraries out there will produce what's called a mini batch. So instead of putting one video through your trainer at a time, it'll come up with batches of 32, 64, 128, push them through the graph together, and you get massive throughput improvements by doing that, in particular on GPUs and TPUs and so on. So we aim to achieve that efficiency of mini batching, but at serve time, when all the requests are coming in asynchronously, and you don't have nice, neat 32-size batches off of disk. And the multiple model support and efficiency, they're neat challenges on their own. But what makes them particularly interesting is doing those while also maintaining those standards for low latency all the time. All right, so I just wanted to say again, and throw this up there for you all to read, that TensorFlow serving is a flexible, high-performance serving system for machine learned models. And it's really designed for your production environments. TensorFlow serving has about 3 major pillars. The first one is a set of C++ libraries. These include standard support for the saving and loading of TensorFlow models. They're pretty straightforward, something you'd want to do with a serving system. We also have a generic core platform. And this is truly generic. It's not tied to TensorFlow, although TensorFlow has first-class plugins for everything you might want to do. So let's say you have a legacy ML system in-house, and you might want to mix and match for some period of time with, say, TensorFlow. You can do that. You can write adapters that plug in different ML platforms and run them in TensorFlow serving. Building on top of our libraries, we have binaries. And these incorporate all of the best practices that we've learned out of the box, so they make it easy. We have reference Docker containers and tutorials and code labs for running on Kubernetes with auto-scaling and so on. And the third pillar is a hosted service with Google Cloud ML, as well as our internal instance that many Google products are using. Lastly, I wanted to highlight that across all 3 of these different offerings, your models are portable. So we worked really hard to make sure that one model format will work in any of these environments. So you can take your model, try it on a binary. You want to do something custom, try it in a library, and so on. So you can seamlessly migrate back and forth. All right, so super excited to show for the first time that we're used very, very broadly across Google. So these are just some of our key customers inside Google. And for the first time, I can say that we have over 700 projects inside Google using TensorFlow serving. So woohoo. Thank you. All right, so I'm going to dive in a little bit to the libraries. So I mentioned the generic core platform. I wanted to mention also that the components are all a la carte. And this means that you can mix and match them to suit your needs. So if you're doing something really advanced, and we have some incredibly advanced internal customers, you can mix and match these components and use just the ones that accomplish your needs. You don't have to buy the entire set of libraries. You can take the ones you want. Let's see. There's the batcher for inference performance. This gives us that mini batching performance, but at serve time. And lastly, you can plug in different sources if you have different storage. So maybe you have a cloud storage of your choice. You can write a plugin for that. All right, so we're going to go through a pretty big slide here. I'll try and make this digestible for you. So let's imagine, and this is zooming into the libraries as they would exist inside our server in the binary. So say your server is up and running, and it's serving your video ranking model, version 1. And it's cruising along. Everything's working well. And say you've trained version 2, and you want to deploy it. So I'm going to walk you through how that would work. So on the bottom right of the slide here, you'll see the green source API with the yellow-orange file system plugin. So it's a really straightforward plugin. It simply monitors a file system, observes the new versions of your model, in this case, version 2. And the source is going to emit a loader. In this case, it's going to emit a loader of a TensorFlow saved model. It's important to note that the loader doesn't immediately load that TensorFlow graph. It keeps track of the metadata. It can estimate the RAM requirements and other resources used by the model. And then it can load the model when it's asked to. And this is really an important differentiator between a straightforward model server that you might build yourselves. So this loader that's very lightweight is emitted over to the manager. Now, the manager actually knows the state of the server, how much RAM is available, and other resources, such as GPU or TPU memory. And only when it's safe to do so is it going to ask the loader to go ahead and load version 2 of the model. So let's say that the manager has plenty of memory. It goes ahead and loads version 2 of the model. You might think that the first thing it's going to do immediately is let's unload version 1. We don't need it anymore. But there's another important detail here. I see some smiles, so you probably know what this is. Say you have client request threads on the top left here, and they're actually still processing some queries on model 1. So what you actually have to do is keep track. In this case, we have a handle on top of that TensorFlow save model. And it keeps track with a high-performance ref-counted pointer mechanism of exactly how many clients are still outstanding processing requests. Only when all of those requests have quiesced, then the manager will go ahead and unload version 1. All right, so I'm going to cover some strengths of the libraries. I'll just highlight a few aspects of this slide. So the one I want to highlight here is the fast model loading on server startup. So this is another really subtle detail, but it's really helped a lot of our users. So let's say you're starting up a server. There's a couple of reasons you might want to do this. Let's say you're running an experiment on your workstation. You don't want to wait a long period of time. You want that to load as quickly as you can. Another example where it's even more critical is auto-scaling. So say your users all get home at 6 o'clock. They all sit on their couch, pull out your application, and send you a big traffic spike of video ranking requests. Using a system like Kubernetes, you're going to want to auto-scale as quickly as possible. And you want those servers to start up quickly. So at the same time, most of the time with servers, you only want maybe 1 or 2 of your threads to do model loading. You want all of your threads and CPUs to be performing inference for your users. But say on a 16 CPU machine, why not use all of those cores and all of those threads for model loading? So it's just a small optimization and one of many that we do to make it easier to auto-scale and run your actual models in production. Let's see. We use the read copy update pattern, which is a high-performance pattern for doing concurrent memory access of these models. I mentioned the ref-counted pointers and these simple plugin interfaces. So it's really easy to extend to support your own data store, cloud storage, or even a database of your models. All right, another show of hands. Who has used TensorFlow Serving's libraries? OK, a few advanced users. So especially for you folks, but also for anybody who's thinking that you might want to use our libraries, definitely take a look at Server Core. So what we observed was that our libraries were low-level, very powerful, and very configurable. But for most people, you really wanted most of the sane and sensible defaults. You wanted to load some set of models. You wanted to load new versions over time. And so we made the class Server Core, which does this for you. And it's configuration-driven. So you can probably, if you move to it from our libraries, you can remove about 300 lines of code and just have a nice little config. So give that a try. All right, so moving on to our binaries. And this is what we recommend for most users. So I mentioned a few times there are things like sensible defaults, how many threads to use, and so on. So the binaries come out of the box with those enabled. So you only need to specify the minimum amount of configuration. They're very easy to configure. I'll show you on a coming soon slide how easy it is to launch these. And they're based on gRPC, which is Google's open source high-performance RPC framework. All right, so hopefully you can read these code samples. So the line at the top, this is how you build the model server. It's a one-liner with Bazel. The second line is how you're going to run the server for a single model in just a one-line command. No config files needed, just 3 flags. So you're going to specify the port, the name of your model, and the path to the model on disk. And this is, we call it a base path, because you might have multiple versions over time. So over time, you can just drop more and more versions in that directory, and they'll be loaded. And lastly, we have the command to run the model server with a config file. And this could have as many models as you want, as many as will fit on your server. All right, so this is great. We have a server. How do we actually talk to it? So I'm going to speak a little bit about our inference APIs that are supported by the model server. So the first one is called Predict. It's very, very flexible and powerful. So it's tensor-oriented. you can specify one or many input tensors and output tensors. And so you can do basically anything you can do if you're familiar with a TensorFlow session. If you've been playing with that in, say, Python, you can do just about anything there with the Predict API. Now, moving up a layer of abstraction, we've observed that the vast majority of machine learning used in production is actually doing classification and regression. So we have two APIs, regress and classify. And these use TensorFlow's standard and structured input format called TensorFlow example. It's a protocol message. It's feature-oriented, so you can have different values for different features. And a nice thing about these APIs is you actually don't have to think about tensors at all. So if you're new to machine learning, you just want to try something out, try a code lab, or even if you want to deploy in production, which we see many production users inside Google using these APIs, go ahead and try the high-level APIs first. Next up, and I'll talk about multi-inference a bit later in the talk, multi-inference allows you to combine multiple regressions and classifications into a single RPC. And that has some really cool benefits. All right, here's a total toy model for you. And this is just to show what does the syntax look like. I've talked about these APIs if you haven't seen them before. So we have a model spec. And this specifies the name of the model. And this is because your server could have multiple models running at the same time. We'll have one feature. In this case, the key for it is measurements. We have 3 floating point values. And we have a structured result. So again, you don't have to inspect tensors. You'll actually get a structured result called regressions, which has 1 score. So just an example. All right, so I'm going to move on to some of our key challenges that, for the most part, we've solved, but we still have quite a ways to go. OK, so this is a story of isolation and latency. So from anybody who's ever looked at a latency graph before, you can probably tell that those spikes are really bad. You don't want to have those, right? So those spikes were happening pretty much Monday through Friday, around 12 or 1 o'clock. So does anybody have an idea? Just shout it out. What caused those latency spikes? Lunchtime. Strongly correlated. So we had this fantastic engineer we were working with on one of our largest client teams. They were serving multiple models. These were large, multi-gigabyte models. And they were serving several 100,000 queries per second on a fleet of servers. And what was happening is this great engineer, really a close collaborator, he would go to lunch. But right before he went to lunch, he would push a new version of the model. So you can probably pretty quickly figure out what's going on here. So every time a new model, a particularly large one, about 5 gigabytes, was loading, inference would slow down at the upper end of percentile. So you might wonder, why is this going on? Once we figured out the cause, it was pretty easy to figure out. So for most of machine learning, you have one model in a server at a time, whether you're training or serving until now. And so most systems are optimized around throughput, not latency. And so all available threads are available for any computation that's ready to run. In this case, model loading is parallelizable in TensorFlow. And so TensorFlow would gladly use all the threads available and go load that new model, starving inference of threads. So here's the after slide. And definitely note that the right side of this slide, the axis, just dropped by 10x. So we went from over a second in terms of our latency spikes to about 1/10 of a second. This fully met the needs of the customer. They're serving SLA. They're happy. And the way that we achieved this was we added an option to TensorFlow that lets you explicitly specify the number of threads to use for any call to your graph. And in this case, we wired them up so there's one thread pool for model loading and one for inference. So pretty straightforward. By default, since all of our users want to use all the threads for inference all the time, we actually only need users to configure the number of threads for loading. So usually specify 1 or 2, and then you're good to go. All right, so this is going to be moving on to batching. Several slides I mentioned earlier in the talk, and this is a really key challenge to get great performance and throughput. And so let's look at the right side of the slide. You have these Tetris blocks that are falling down. So imagine these are requests from your users. Maybe those blocks represent individual videos that are being ranked by your server. And their different height represents the time at which they arrive at your server. So what we do is we wait for a very small and tunable period of time. And we wait for a few queries. We aggregate them together and stitch them into one set of tensors that we feed into the TensorFlow graph. So this enables you to get very efficient use out of GPUs and TPUs that have really good batch parallelism. One external paper, the spin paper, saw that moving to batched inference on GPU led to a 25 times speedup. I'm also excited to share that on CPU, we've seen for models up to a 50% improvement in throughput. So it's a tiny little tuning knob that can save you, quite a bit of your inference costs. Another thing is that once you're actually doing batching on top of custom hardware, hardware accelerators, and GPUs, you'll typically only want to have one unit of work being done on that chip or device at a time. And so one thing we noticed is when you're going to have multiple models and multiple versions, but perhaps one piece of hardware, you're going to need to schedule the work carefully across those models. And so we have a shared batch scheduler that lets you do just that. Lastly, the batching capabilities are all available in both library form, as well as they're configurable in the binary. So you can access them very easily in either approach. Now we're going to dive into what happens inside one of these session run calls. All right, so hopefully you can parse this utilization graph. So there are two different kinds of utilization I'm showing here. So the first is the blue dashed line. This is the utilization of your CPU. And you'll notice it's not used through the whole period of this request. The orange line represents the GPU or TPU utilization. So walking through, we'll start with some single-threaded CPU-bound work, like, say, parsing of your input. It's really common. Pretty much all models are going to do this. Then you might do something else that's single-threaded, like do a vocab lookup or an embedding lookup. OK, you're done pre-processing your data. Now you're going to shift over and do computation on the GPU or TPU. So your CPU basically goes to idle. Your TPU or GPU is maxed out for some period of time. It returns. And then, again, you're going to do some post-processing on CPU. And the reason I show this is that naively, if you just ran one inference at a time on this set of CPU and GPU, you're going to be vastly underutilizing both pieces of hardware. So one of the ways that we solve this is by having multiple threads, very, very common in serving systems. And what you can do is you can have a good number of threads and limit how many are running at the same time. And you can make it so that you're constantly using your GPU and TPU, and that most of the time you're using your CPU. But the key takeaway from this slide is that there's this queuing time that happens at the beginning of each request. So once you enable batching, I mentioned earlier, there's this tunable window of time where you're going to wait for a few requests to come together, and then you'll process them. This totally makes sense for the GPU and TPU work. But for the work done on CPU, there's no point in waiting. All this does is add some latency to that work. All right, so we have some challenges here. There's the scheduling and utilization of both the hardware accelerator and CPU. There's the issue of saturating one resource. So maybe you've tuned your model, it's working really great. You're using all of your CPU, but only half of your GPU. That's not ideal, and vice versa. I just mentioned queuing latency. So you really don't want CPU single-threaded work to wait to be batched together. All that does is add some latency. And the last one, for sequence models, where you have input data of variable length, and the computation will have variable cost, it's really challenging to batch these pieces of work together. One of the common approaches is to add padding to the shorter sequences so they all match. But this means that your GPU and TPU will be doing work over padding, which is wasteful. So there's challenging trade-offs there. So we think we know the way forward. I'm going to share with you some work that we're currently doing. It's ongoing, but it's still in the experimental phase. We are moving batching inside the graph. And we think this is going to be huge for throughput and performance, in particular for challenging models. Moving batching inside the graph enables you to surgically batch the specific subgraphs that benefit the most from your custom hardware, your CPUs, and so on. For sequence models, where you have things like a while loop with a single step of code being run inside the while loop, you can actually run the batching only inside that while loop. So it's really neat. You're never doing batched inference or batch computation over padding. And early results look super promising here. Another area is for complex models that might have, for example, a sequence-to-sequence model. Maybe it has an encode phase and a decode phase that have different costs. This would let you batch those subgraphs separately and tune them separately. All right, next up. I'm going to share some new technology that we recently released as part of TensorFlow 1.0. So the main piece of tech here is saved model. So saved model is the serialization format for TensorFlow models. It's available for very broad use. It's not specific to serving. You can use it for training. You can use it for offline evals. And you can use it for other interesting areas I'll get into. Save model has two new features to TensorFlow. So the first is that you can, in one save model, have multiple metagraphs that share the same assets, such as vocabs and embeddings, as well as the same set of trained weights. You might ask, what would I want that for? I've just been training models. Well, it turns out that the metagraph for serving is very, very commonly different than the one for training. And now let's say you want to have a third metagraph that's going to be used on GPU. That's also something you would want to customize. So the multiple metagraph support lets you have a metagraph for training, one for serving on CPU, one for serving on GPU. All right, the second major feature of save model is signature def. So a signature def defines the signature of a computation supported by a TensorFlow graph. You can think of it like a function in any programming language. It has named and typed inputs and outputs. So as humans, we're really good at looking at that graph. You can probably all guess what the nodes in that graph are. I guess if we polled us, all of us would figure out that the middle node on the left side of this graph is where you feed the input. But if you want to take your model and have a whole ecosystem of tools, such as serving systems, that can interpret those graphs that they had never seen before, you would need to annotate that graph in some way. That's exactly what signature def does. So in this case, the middle node on the left is where you feed your inputs. The top right node outputs a set of classes. And the bottom right node outputs the scores. All right, so building on top of signature def is multi-headed inference. This is also known as multitask and multi-tower inference. So another show of hands, who's familiar with multi-headed, multitask inference? Oh, wow, OK. So this is pretty new. There's some emerging research and great work going on here. I think you'll be really excited about this. So let's take that example earlier. You're serving video rankings. Your users are using your app. You get lots of content creators. You're successful now. And so users are drawn to your platform. And maybe some not so good people are drawn to your platform. Maybe they're uploading clickbait. We've seen this in many places. So your first model, the orange model, computes the click-through rate. And these bad guys are training models optimized to get clicks. So you might decide, well, let's define a new metric and train on that. Let's call it conversion rate. And it's going to track users watching the majority of a video. So we'll call that CVR. And now we're going to go train a new model for this. But wait a second. All of the careful feature engineering and other things that we did to get our data ready for the first model apply to the second model. It's very, very likely, and in many cases, it's a certainty that those features are usable in both contexts. So you can actually train one model for multiple objectives, in this case, CTR and CVR. So I've listed some infrastructure benefits on this slide. And there's some really, really big infrastructure benefits. Your inputs are only sent once over the network. So that's already a pretty big one. You only have to parse the data in your model once. You only have to compute your hidden layers one time. So this is going to save you bandwidth, CPU, latency, and even RAM overhead on your servers. This is great. I could stop right there. There's another really important attribute of these, why they're becoming more and more exciting in the research that's going on. So you're likely, in this example, to have many more clicks than you'll have conversions. So when you go to train these models, you have much more labeled training data for your CTR objective than for your conversion objective. So what happens when you actually train one model for multiple objectives? So we've actually seen some early promising results where in one case, we were able to see a 20% improvement in a key quality metric by moving an existing separate model into a multi-objective model with another objective. So there's wins here on infrastructure and on quality. Multi-headed inference is available in the TensorFlow Estimator API, so you can train models with multiple objectives today, and you can serve them as well. So we're really excited about this. All right, I wanted to show, really quickly, what does a multi-headed inference request look like? So it's pretty simple. You can specify one or more inference tasks. They each have the name of a model, as well as which signature to use. So really simple. OK, all of this, power and functionality sounds really great. From early adopters, we also heard, this is challenging to get right. I might want to do things like inspect a model and see, what's actually going on with it, run a sample query, look at the metadata, and so on. So we're introducing the save model command line tool, and it lets you do all these things with a model. So the first query you can do with the save model CLI, you can look at what metagraphs are in the model. So pretty simple. So in this case, we have a save model. It has two metagraphs. One is for serving, and one is for serving on GPU. Now, let's say we wanted to look at the serving metagraph and see its metadata. In this case, the metagraph contains two signatures. One is called classify x to y. The other one is called serving default. So serving default is a documented key, and it's a constant in TensorFlow. And what this does is it says, if the user has not specified which signature to use, just use that one. And in many cases, for people getting started, you have just one signature. So it's really easy to get going. All right, now say you wanted to actually look at the input and output tensors in the serving default signature. So you add on one more flag to the CLI, and you'll see the inputs, and I skipped the outputs for the slide here. But you'll see there's one input tensor called x. It's of type float. Note the method name on the bottom. So the method name here, TensorFlow serving predict. This is kind of like a type in a programming language. It's informing another system, in this case TensorFlow serving, that this signature was intended for use in the predict API. We have similar ones for TensorFlow serving regress and classify. But you can override these. So maybe you have an in-house offline evaluation system. You can make your own method names and check for them in your models. All right, and lastly, let's say you would like to run a graph. You have some input data, maybe you're debugging the model, or you just want to try it out for fun. So I'll highlight here, all of the params are the same, except instead of show, we've asked to run the model. We also have two ways of expressing input that you can mix and match. So maybe you have a NumPy file. You can actually specify the path to the NumPy file, and it'll just be read. You can also specify a Python expression, and it'll be interpreted. All right, so in closing, wanted to say that collaboration is very, very welcome on this project. We sync our internal repository with GitHub about weekly. We have a developer on-call rotation that includes facilitating your pull requests, answering questions, and so on. We have lots of open-ended research problems, so feedback is encouraged on APIs, techniques, anything I've talked about, and any challenges you have as well. You can reach us at discuss@tensorflow.org. For some links on how to get started, just search for TensorFlow serving. Very easy to find. We have a great Kubernetes tutorial. This will let you, launch an inception model server, and it's going to run an auto-scale for you. We have Google Cloud ML, as well as I mentioned our mailing list, and you can also use our hashtag on Stack Overflow, hashtag TensorFlow. All right, let's go to questions. Thanks very much.
Hi there, iOS developer. Interested in getting started with the Firebase platform in your app? Well, you've come to the right place. There are two main parts to getting the Firebase platform up and running: adding your app to the Firebase console and installing the SDK. Let's go over these one at a time. For starters, let's go to the Firebase console at this URL here. Depending on when you're watching this video, the UI might look slightly different, but the general concepts should remain the same. Now, depending on your situation, you might see a blank Create a New Project screen, or you might see a list of existing projects. Oh, before we go further, let me take a moment to explain the difference between projects and apps. A project consists of one or more apps. Now, all the apps in the same project use the same Firebase database backend. And if you want, you can use features like Firebase Cloud Messaging to talk to all of them at once. You don't have to, but you can, which is sometimes convenient. So if you're a developer that has a cross-platform app, you generally want to put the iOS and Android versions of your app in the same project. Now that'll give you some nice cross-platform benefits. Your user can access the same data if they switch back and forth between the iOS and Android versions of your app. Things like dynamic links will work across both platforms. You can send one notification to all versions of your app and so on. On the other hand, completely different apps, you should put those in completely different projects. There's nothing gained by cramming them into the same project except tears and heartache, I guess. So if you're working on a cross-platform app and your Android or web team has already created a Firebase project, you should probably select that project and connect your iOS app in there. Otherwise, if you're the first one to be adding Firebase capabilities to your app, you can be the one to create the new project. In my case, I'm the first app associated with the project, so I'm going to create a new project here. I'll give it a name, and there we go. Once you've selected or created a project, you're going to want to connect your client app. I'm going to select the iOS button here, and I'll give it my app's bundle ID. You are eventually going to need to add your App Store ID here if you want features like Firebase invites or dynamic links to work, but you can leave this blank for now and change it later. Now when you click continue, your browser should automatically download this Google Services info.plist file for you. Note that it needs to be named this exactly, so if you get that little one in parentheses after the name like I just did, you're going to need to do a little bit of renaming in Finder. Okay, next up, drag the file into your Xcode project, like so. And let me go back to the console and hit continue here, and it's telling us that this would be a good time to install the Firebase CocoaPods. Now I'm assuming you know something about Firebase CocoaPods, but if you don't, here's a little video for you to check out. It's fun. So I'm going to jump into my project directory here and do a little pod init. We'll open up the file, and I'm going to uncomment this line because I am using Swift, and this line because my app happens to have a base SDK of 8.0, although at the time of this recording, Firebase is supported as far back as 7.0. Next up, let's add some pods. Now, it's important to remember that, to keep your app nice and svelte, you should only install the CocoaPods for features that you need. In fact, there is no all-encompassing Uber Firebase CocoaPod that installs everything for you. You're going to need to pod install each individual feature, and you can find a full list of the CocoaPods and the features they correspond to over here. Now for starters, I'm just going to add Firebase/core, which includes everything needed to get the basics up and running and also enables Firebase Analytics. So now I'll make sure my project is closed, and I'll run pod install, and then let's open up the generated workspace. All right, we'll build it and make sure everything compiles okay, and it does, so we can move on to the next step. Okay, looks like the last step here is to add some initialization code. I recommend putting this in your app delegate did-finish launching method. First things first, let's import Firebase in my app delegate. Note that this is usually the only thing I'll ever need to import no matter what we've installed. We're doing some pretty nifty work behind the scenes to make sure this works properly. I know this sounds like the exact opposite of my only pod install what you need advice from like 2 minutes ago, but trust me here, this makes development a whole lot easier. All right, so next up we'll add the line firapp.configure to make sure Firebase gets set up properly. And that's actually all you need to do. This configure method will take a look at what libraries you have installed, initialize them, grabbing all the appropriate constants from that Google Services file that you dragged in earlier into your Xcode project. So we'll give it a quick run, and if everything is set up and working correctly, you should see a few lines in your console about how Firebase Analytics is up and running. All right, so congratulations. You are now up and running with Firebase. So there are a lot of places you can go from here. You can add sign-in using Firebase Auth, or get your app talking to the real-time database, or start tracking more of your users' usage with Firebase Analytics. You can check out these links to get started and have a little fun.
What's up everybody? David here, and today I have a quick and easy Firecast for you. We're going to get up and running with Firebase and the web. And this is actually going to be the first of many screencasts in a series, so make sure you subscribe to get notified of tutorials on authentication, storage, hosting, and web push notifications with Firebase Cloud Messaging. Also, if you're a fan of JavaScript frameworks, I'm going to be dropping videos for Angular 1 and 2, Polymer, React, and Ember. So you better subscribe because you don't want to miss those. But today we're going to start with the very basics. I'm going to show you some mad copy and pasting skills by getting the project initialization code from the Firebase console. And then we're going to set up a small web app. So let's go and dive in. So I'm in the Firebase console at console.firebase.google.com. You can see I'm logged in as myself up here, just smiling at you. But to get started, I'm going to create a new project. So I'm going to click Create New Project. I'm going to call it Web Quick Start. And then we'll create it. My project is now created. So I'm going to click Add Firebase to your web app. And this brings up a little modal with all the initialization code I need to get started. It has things like my API key, auth domain, database URL, and storage bucket. So then I can go to the bottom right, and then I can click Copy. And that's all the code I need to get started. But just as a little FYI, you can access all of this information by clicking Auth, and then going up to the top right where there's Web Setup. But now, to the editor. So here in my editor, I'm going to get crazy. I'm going to create this web page from scratch. So I'll start with my basic HTML boilerplate, give it a title, and now I can just paste in all the code from the console. And this is all you need to get started. And just to prove that it works, I'm going to use the database as a little tiny demo. So I'm going to create an H1 and give it an ID. And every single time the value changes in the real-time database, I'm going to sync it to this H1. So the first thing I need to do is get that H1 by its ID. And then now I'm going to create a database reference using firebase.database.ref and then create a child location to the text location. And now I can synchronize any changes using the on function. And then using ES2015 arrow functions, I can just do it all in one line. So to the left right here, I have my project in the Firebase console, and to the right is just my blank page. To use the database, I'm going to remove all security. So I'm going to click Rules, and then I'm going to say Read is true and Write is true, and click Publish. And you should totally know that you only do this while you're developing, because that means anyone can read or write to your database. So now I'm going to give my browser a refresh, and then I'm going to add a text location. And it synchronizes to the browser. And so I can change it, and then it changes as well. So keep in mind that the real-time database is just one of the many features Firebase offers for the web. You can also use authentication, storage, hosting, and even Firebase cloud messaging. So that's all it takes to get started with Firebase in the web. And if you want to go and learn more, then check out the link in the description for our official documentation. And if you're super excited to learn more about Firebase on the web, then please subscribe to our channel because we're going to have tons of more content. So that's all for this time, and I will see you all later.
We started Is on a living room couch, and we really started because of the problem that we had, which was asking the same question to our closest friends. Where are you? What are you doing? We were baffled by the fact that there wasn't a solution that solved this problem, and we felt like we could build one that was better.
The value that Is drives for all users is knowing which of your friends are nearby. So if you look around where we are right now, an arena, how many times have people gone to a basketball game, hockey game, or a concert and found out the next day that they had friends who were at the same event? And think about all those moments that are missed because they didn't know they had friends there. So what we're solving is letting people know who's nearby and making those moments matter.
My name is Diesel Peltz, and I'm the founder and CEO of Is.
I'm Mark French, co-founder of Is.
We felt there was no reason users should manually go fetch data. When I get a text message, there's no reason for me to tap refresh. And we felt, why should it be different from anything else? And Firebase let us solve that. Firebase really allowed us to enhance the user experience by making it real time, simplify the UI by not having a refresh button, and cut down on development time.
Like any startup, the most valuable asset that you have is your team and your time. And what Firebase has allowed us to do is save 50% in terms of time by moving that much quicker with a product. It's a game changer.
We're using 8 features from Firebase right now. They're analytics, remote config, dynamic links, the real-time database, and more. Traditionally, that would have been in 8 different places. And now we go to one place, which is the Firebase console.
We're eager to launch this product in a big way. We're seeing how people are using the product and how they're inviting more and more friends that we're concerned. We're growing very, very quickly. So we sleep a lot easier at night knowing that we got Firebase that's really there to build that infrastructure.
If you're a developer, use it. We love it, and it's enabled us to focus on developing the user experience and not have to worry about the things in the background that should be there.
Yeah, with NPR One, we are reimagining what a listening experience could be outside of the radio.
It's the radio, but better. It has all of the great stuff that we've spent 40 years perfecting.
With NPR One, we see the opportunity of reaching a more diverse audience that have a device in their pocket at all times.
My name is Mike Saifulahi. I'm the lead mobile developer for NPR Digital Media.
My name is Nick Dupre, and I'm the innovation accountant at NPR.
My name is Tejas Mistry, and I'm the senior product manager of NPR One.
Just some of the biggest challenges in any mobile app are that first impression. When the user first installs the app, you've got a very limited amount of time to convince them to keep the app and to get engaged in the experience. Trying to figure out how we can get users into the content as quickly as possible was the real focus of integrating Firebase and dynamic links. Using dynamic links, we were able to shorten the number of interactions it takes for a user installing the app to get from the promoted content to the content from 20 to 3. So that user's able to get right into the content.
We're driving more and more listening per user every week. It's really astounding. Creating playlists of content that are configured by the podcaster or by a member station or by us internally. And with Firebase, we have that at our hands.
Having the analytics product interact with things like dynamic links, remote configuration, cloud messaging, it adds a real multiplier effect.
And the integration with the broader Firebase suite, I don't have to go outside the platform to figure out what's working. So it's not just about shipping the product faster, it's about analyzing the results faster. And with the integration with all the other Firebase products, we're really excited about all the things we can learn from it.
Raise Labs is a company that is focused on building excellence in software, technology, and design. We do that through our work on mobile applications and websites and technologies in general. My name is Gregory Raise. I'm the CEO and founder of Raise Labs. We really want to understand the human problem, and oftentimes the hard problems in software aren't just the technology problems, the API, the how do you connect these things, but really getting at the heart of what people are trying to accomplish and do in their day-to-day.
My name is Ben Johnson. I'm the managing director at Raise Labs in Boston. We decided to put our hat in the ring for the Google Certified Agency Program. The first leg is just having access to a lot of what Google is doing today. So there's access to design reviews, invitations to events, and that's sort of the base level. And I think that's hugely rewarding even in and of itself. Having Google review your app from a design perspective is amazingly helpful. So that's sort of the first tier. The second tier comes with certified status. There's a long application process for that. And once you have it, it's something that you can really say to your clients that gives them comfort that we're a reputable firm, that we're building great software in a way that Google believes in.
The certification is a higher bar for us to really differentiate ourselves from many of the other companies out there. It required us to really dig into what that means to be truly world-class, and we wanted to set that bar for ourselves as well.
My name is John Green. I'm a VP Creative at Raise Labs. The Google Developer Agency Program allowed us to have access to engineers for the map team, the design team, to figure out, how can we actually do some of these things? And we could reach out to them when we needed. And also it allowed us to set up and say, we can make this a success. They might look closer at this app because we're part of this program, which has actually been super helpful.
Some of the challenges in building the Six Flags app, and we touched on some of these, are certainly mapping technology and payment technology, material design, or the APIs. Having access to the Google team to really ascertain how we're approaching certain software and ensuring that we're building technologies the right way makes for a smooth development process.
We set off to build the Six Flags app with a pretty lofty ambition, and it was to bring in-park navigation and commerce to the app. The comfort of knowing that Google is there to help us understand where they are heading as an organization and that we are along for that ride is a really helpful thing to know. And as a business, we know that going forward, we're going to be at the cutting edge of whatever Google is doing through access to programs, through the collaboration with their teams. It's really helpful for us to know that 6 months, 9 months down the road, we'll still be a part of that process, and we'll still be working with them to figure out what's next.
Oh!
Hey, Timothy. How's it going?
It's going great. This is Brad Abrams. Brad is a product manager on Assistant.
That's right. Yep. How's it going, Timothy?
It's going great. Now that you're here and I'm here, I think we should talk about the Assistant. What do you think?
I think that sounds like a great idea because it's the only thing I know to talk about, so perfect.
All right, let's start with square one.
Okay.
What is Assistant and why is it cool for developers?
Well, the Assistant is really a conversational interface to Google. It's the kind of smart brain in your Google Home or on your Android phone, and actually at this event we just launched it on iOS as well. And you can have really a conversation with Google to help you get things done.
That's awesome.
I think so.
What are the different surfaces for developers to integrate with?
Oh, great. So there's a couple of different ways. One, you can extend the Assistant by adding your own custom apps to the Assistant. And then you can also host the Assistant in different devices. So if you're building your own hardware or whatever, you can host your Assistant there.
And that's the difference between Actions on Google and the Assistant SDK, right?
Exactly. So the Assistant SDK is where you host it with your hardware, and Actions on Google is extending the Assistant.
Okay. Well, we're at I.O., and I know some new stuff has been announced. Why don't you tell us about some of your favorites?
Oh, man, it's hard to pick. There's so many. I'm really excited about Actions on Google coming to phones, to Android and iOS. So up until this event, you could only build Actions on Google for home, for eyes-only experience or eyes-free experience. And now we have Actions on Google for the phone as well. So we have suggestion chips, lists, image carousels. And it can really give you a deep multimodal experience.
Oh, you mean like seeing and hearing?
That's right. You can see and hear, yeah. We also launched transactions, so you can buy things via the Assistant. I think that'll help users a lot. I know I want to buy a pizza from my phone. I can just say, okay, Google, I want a pizza, and it can connect me to somebody to go do that. And for developers, it also gives a financial incentive, which I hear some developers like to get paid.
Yes.
So
indeed, they do.
And then, of course, deep. For me is developer experience. And we've done a lot of work. We launched the platform first in December, and we've done a lot of work on developer experience. So we launched a new version of the developer console. We call it the Actions console. Developers can use that to work better in teams together, to get deep analytics about their application, as well as it integrates really well with the Firebase and Google Cloud consoles.
Awesome.
And then can I do one more?
Absolutely.
See, I can just add them. So one more would be discoverability. I think that's been, in the whole kind of chatbot space generally, having people be able to discover them has been a problem. And so we've done a lot of work in that regard. The first is that we have a new directory for our apps, and it's right there on the Assistant surface, just one tap away, and you can see a category view of all the Assistant apps that are there. We also gave you a way to get a web URL into that. So if you wanted to promote your app via your enormous Twitter followers, you could totally go do that, which is awesome. And of course, people who love your Assistant app can share it with their friends via the deep link. And finally, we did some work to help discover when to invoke your Assistant app from information in the directory, other information provided by the developer. We can just respond to queries like play a game, and we can actually find the right Assistant apps to go trigger in that case.
That's totally awesome.
Yeah, it's really fun. It's kind of a big release for us here at I/O.
Yeah, I mean, there's a lot of different stuff.
Yes, it certainly is. But I think it comes together in a really cohesive package, though, because if you're going to do transactions, you're going to buy things. A lot of times, having a visual surface to see the different options, see the cart and whatnot, really helps with that. And then, of course, if you're going to have a financial interest there, being able to have people discover your assistant apps really helps.
Awesome. Okay, so let's take a step back, and I would love to hear your thoughts just on conversational interfaces in general.
Yeah, I mean, if you think about this evolution that's been happening, like when I started using computers, it was like mouse and keyboard. It was very indirect, right? You move.
Wait, you had a mouse?
I did have a mouse. You don't think I had a mouse?
Well, I mean, you start with like the Commodore 128.
Right, yeah. Okay, before you had a keyboard, and then we added a mouse. But these are indirect, like you do something with your hands and something happens on the screen. And then, we got capacitive touch, right? So you could actually touch the screen. And like my kid, when he was 2, knew how to touch the screen, right? Like that was very intuitive. And I think we're at the verge of making the next step. And that is, rather than just being able to like touch the button, what if I could just express what I want? Why do I have to dig through a bunch of menus, find the right button to press? Not really sure what's going to happen when I press that button. But what if I could just express my idea? This is what I want to happen. I want to play this game. I want to order this pizza. I want to do whatever. And that's what I think this conversational interface is enabling.
Awesome. I do want to say that I think one of the things that's been holding us as developers back from that is the right tooling to do so.
As I describe that, I think the developers are going like, wow, sure, but how do I do that when the user, if you think about the huge number of ways people could say they want a pizza and order toppings on the pizza, how can they turn the huge vagaries of human language into something a developer can understand? And that's where tools like API.AI can really come into play. API.AI is our own conversation building tool. And what it does is lets you as developers define intents just by giving us some example phrases of what a user would say. And then we can do pull out the entities from that and do the natural language understanding so that we can do slot filling and actually figure out what users are saying. So you might give an example like, I want a large pepperoni pizza with tomato sauce as your example. We know it's large is an entity, pepperoni is an entity, and tomato sauce is an entity. We can actually pull those out and then recognize other queries like, I want a small pizza with tomatoes and green olives with no sauce. And that, because we can do that, it makes it much more tractable for developers to actually understand human language.
But seriously, how many times have you ordered a pizza with no sauce?
Well, that's pretty rare, but I'm for extra sauce. Just because it dribbles down your face.
Okay, that's good. All right, is there anything else you want to say about Assistant or any of the developer tools before we go?
No, I think we pretty much covered it.
All right, Brad, thanks so much.
All right, thank you.
Is this the clicker? So. Hi, everyone. Welcome, and thank you for coming to our talk today. We are members of the Android UX team, and we're excited today to talk to you about the new notifications features in O from a UX perspective. So I'm Julie. I'm a researcher on the Android team, and today I'll first tell you about the research that inspired the new notifications features in O. So in November of 2015, our team went on what we call a UX expedition to learn more about how people experience notifications. So our team of researchers, designers, engineers, PMs, we all spent a week in New York and New Jersey speaking to and observing users. We approached the topic as attention management to include interruptions from devices, other people around us, ourselves, and everything in your environment. We didn't want to limit our scope to just on-screen smartphone notifications. We used multiple methods in the research. We started by interviewing people. But then we also observed people. Because notifications are so contextual and in the moment, we wanted to observe people receive notifications to see what they would do and how they would react to them. We also had group discussions amongst friends who did design exercises together. And lastly, we synthesized the data together as a team, and we held a workshop later and came up with ideas that turned into the features in O. So what did we learn? The most striking observation we made is that there was this addiction to phones. People were bound to their phones all day because they were afraid they might miss something important. Phone notifications were a major source of stress. People were very hyper-vigilant to any kind of signal they could be getting from their phones, afraid to miss something important. And most notifications were actually not important to them. Only a few were necessary. We heard lots of things like this from our participants. Denise said, if I don't have my phone for 2 seconds, I freak out. What if I miss something? And she was a busy lawyer, and I observed her in her house the whole day, constantly going like this, where's my phone, where's my phone? And she'd leave the room and come back looking for her phone, just really anxious all day, just in case her phone wasn't with her. And then there's Alice, who's a professor. She said, I wish I could have something like an Amber Alert for my parents, ex-husband, and son's school, so that those would override everything else. She gets lots of notifications from different sources, but the only ones she cares about are these. And she wishes these would always override the others. We observed different coping strategies from users to block out all of this noise. The first one is to physically put the phone away. So people would force themselves to put their phone in a purse, put it in another room. Someone even put it in a box in another room. Just anything to prevent yourself from checking it. The other strategy was to not let the device make noise. So let it just vibrate, or don't even let it vibrate at all. Another strategy was to not let sources contact you. That means to block all notifications from an app. And the last one is to do nothing but be constantly annoyed every day and all day. Stephen, he mentioned a particular social networking app sent me way too many notifications, so I deleted the app. So he got fed up and deleted the app, and actually every day he uses the service in a mobile browser, multiple times a day, purely just so he wouldn't receive notifications. In fact, the pattern that we're hearing now is when people get so annoyed with notifications, whenever they download a new app, by default, they'll just block it all, block all notifications without even giving it a try. This is obviously something we all don't want, so we need to really be careful about this cumulative effect of all of our apps' notifications. People often want only some notifications from an app, but not all of them. So even if they want just one type of notification, they still receive a bunch of unwanted ones. And many people don't adjust their settings even if they know they can. So even if they know there's a way to do it, they might not know how to do it, or it might feel like a hassle, so they just live with the problem. Angie said, notifications are like junk mail. You can take the time to set up filters or just hit delete. I just deal with them. She just deals with it every day. Stella said, if you allow push notifications, I know there's a way to go into settings and adjust it, but I don't know how to do that. So what else did we learn? There were only 2 types of notifications that people needed to know. The first one, above all, notifications from other people are most important. So these include SMS, messaging apps, emails from people, phone calls, etc. Anything that came from a person on the other end. These were most valued. Flora said, notifications from other people are most important. I always respond. Those are the only ones that she pays attention to. And then there are more important people. So notifications from the inner circle matter even more. So these are people like your spouse, significant other, parents, kids, closest friends. They can reach us at any time, and we keep channels open and reserved for them. Andrew said, work emails and text from my wife are the only things that matter. Basically things I need to tend to so I don't get in trouble. So those are the 2 types that he cares about above everything else. The other kind of notification that's important to people are reminders for things that they need to do. So we observed people having things they needed to remember throughout their day, like picking up your dry cleaning, calling a credit card company to follow up with an issue, cleaning a chinchilla cage, if that applies to you, setting up a kid's play date, making new keys for the car, things like that, right? We all have things like this in our lives, and people need to remember these things. David said, sometimes I get a notification for something that I actually want to do, but just not at that moment. And then I forget about it later because I don't see it again. And Shelley says, I know I have to pick up my dry cleaning, but telling me right now is not going to help me. It's like nagging. Tell me when I'm near the dry cleaner. So when a notification isn't addressed right away, it's very easy to forget it. Out of sight, out of mind. We realize that we need to make it easier for people to remember these tasks. So while this research, as I mentioned, was conducted only in New York and New Jersey, we've observed similar patterns in many other studies across many locations since then. Whatever topic we're studying, from productivity to wearables to driving, we keep hearing over and over again from people about the stress and the burden of all the notifications they're being bombarded with. So here are some other locations that we've done where we've heard similar patterns across the US and many cities and internationally. So based on this research, our team felt it's important for us to respect our users' attention and to allow them to have more control. So this inspired some major changes in O this year. Now here's Rachel to give you more details about the features.
Hi, I'm Rachel Garb, and I'm an interaction designer and manager for the Android UX team. The first new feature I want to talk about is channels. Show of hands from smartphone users in the room. Who here has ever wished that they could get some of the notifications from an app, but not all of them? That's almost all of you. Yep. So knowing that, we definitely wanted to add support in the Android system so that users could have more granular control over an app's notifications. In O, we're introducing channels, and here's how it works. You define a channel for each notification type that you want to send, and then your users are able to make decisions about notifications at the channel level. Let's look at an example. Suppose that we are all the designers of an app for Crane Air, a fuss-free corporate airline that caters to the frequent flyer, and here's all our existing notifications. We've got a pretty sweet program for our frequent flyers, or as we like to call them, executives. We have a set of notifications for our customers about the points they've earned and their status in the program. Now, all of these notifications you see here have to do with the executive program. So let's make a channel and call it Executive Program. Now, we occasionally also offer discounts and deals to incentivize our customers to book more flights. So let's group these notifications together in a channel and call it Discounts and Deals. Now, when we categorize notifications into channels, we want to look for similar subject matter and similar importance to users. Here, we have a number of notifications that could be sent in the hours and minutes leading up to the flight, so they're pretty important. Let's create a channel for them called Flight Updates. And now, with this example in mind, let's shift over to how users experience channels. The UI design for channels is optimized for the #1 most important use case, which is, I don't want this type of notification from this app. Now, without channels, any support for this use case has to come from within the app with settings to block notifications by type. Now, how does a user find out if an app provides this? They have to open the app and look at the settings. And it's not like all apps are going to do it the same way. But a lot of the time, there won't be any way to block notifications by type. And at that point, the user has to decide what they're going to do. They can ban the app from sending any notifications at all. They could uninstall the app or just live with it. And none of these are ideal. But with channels, it's a different story, one that's straightforward and consistent. Let's check out the UI. Now, we at Crane Air know that a segment of our users love to celebrate when they earn points or reach a new status. So whenever they land, we notify them about how many points they earned on the flight and how close they are to the next status level. But maybe not all users want to be notified like this. Some might not want any notifications except the ones that are essential to functioning in their daily lives. And they know that they can get this information in their monthly statement. They're fine waiting for it. So to stop this type of notification, all a user has to do is touch and hold it, which lets them see the channel, and then they turn off this switch and tap Done. No more executive program notifications from Crane Air, but they'll still keep getting the others, like those handy flight updates. Now, our aim with channels is to make it possible for users to get most, if not all, of their notification control needs met in line or one step away in settings. Now, in settings, users can decide to block all notifications from an app. And new for O, an app can show a dot on its icon when it has notifications waiting for a user. But if the user doesn't ever want to see a dot for that app, they can prevent the app from showing it. Users can see all of the channels at a glance and decide which ones they want. They can view and edit settings for a given channel. More on that to come. And if the app wants to provide other settings beyond what's here, the app can have a link for the users back to a screen in the app. This approach, bringing more notification controls into the system, makes the user experience more convenient and consistent. So that is an overview of channels. And next, I'd like to talk about the new behavior model for notifications in O. And I'll start with the research that informed it. Some people are putting up with unwanted notification behavior because they're reluctant to use settings. You heard about this from Julie. So the opportunity here was to make it easier for users to understand and control notification behavior. Now, let's compare the current behavior model with the new one for O. In the current model, the app developer uses a field called priority and sets a priority level for each notification. That level maps to a set of behaviors, and some of them are customizable by the app. For example, if you choose priority level high as the app developer, you can have your notification make sound or not. You can have it vibrate or not. You can have it peak or not. It's a lot for a user to follow. In the new model, priority is deprecated. And instead, the app developer sets an importance level for each of their channels rather than for individual notifications. And there's fewer customizations that the app can make on that behavior. Here, you see the inner workings of priority levels. I won't read this out to you, but let's compare it with importance levels. As you can see, we've gone down from 5 to 4 levels and reduced what can be customized. We are intentionally trading flexibility for simplicity so that users have a better shot at understanding what the heck is going on. We're letting go of allowing each notification to behave differently so that we can guarantee users that all notifications from the same channel behave the same way. In the current model, a user can control an app's behavior but has no insight whatsoever into the app's intentions as they're making decisions. But in the new model, the user gets a clear picture of app behavior as they make decisions. So it's the difference between I can make sure that this app won't be able to do X versus I can see this channel does X, but I'm going to have it do Y instead. I'm going to show you what I mean by comparing the UI. In the current UI, if show silently here is turned on, then it's predictable. But otherwise, the user has no clue how notifications from the app will behave. In the new UI, the user just needs to look at the importance setting to see how the channel will behave. And if they don't like it, they can choose a different setting. In this new model, Android creates a settings screen for every channel from every app. This is the place where users go to see and control its behavior. The main settings are to block the channel and change importance. If the importance level is high enough, the user has sound and vibration options too, and there's more advanced options. Now, you can also optionally provide a brief description of what the channel does, if it's not obvious, so that users can make more informed decisions. If your app already offers channel-like behavior, please leverage Android solution so that users don't run into the situation where there's discrepancy between an app and system settings. You can link to the system settings screen either at the channel or the app level. And if you want to offer channel controls beyond what the system offers, for example, letting users specify notification and email preferences in the same place in your app, you can have a link back to your app settings. And that's an overview of the new importance model. Next, I'll turn it over to Justin to talk about other new things for O.
Thanks, Rachel. I'm Justin Barber, and I'm a visual designer on Android. And I have to start with an apology, because many of you probably showed up for this session hoping for a Justin Bieber concert, and it's not happening, but I still have some pretty interesting stuff to talk about. So visual hierarchy is the focus of O. And if you remember, last year in N, we completely redesigned notification templates to become more flexible, modern, much cleaner. And the new features in O that I'll be covering were really built on the foundation that we set in N. And also on Julie's amazing research. So that's where I'll start with the with the research insights that really led to what our approach in O. So the first insight was that people are overloaded with notifications, and it's hard to find the important ones. I'm pretty sure we've all been here before. And in Julie's research, we uncovered that users were building associations to determine what was important for them. So if the phone made a certain vibration tone, or they saw a certain color of light blinking, or they'd see a color in their notification, they were making associations to determine whether or not this was important enough for them to spend time on. But that can be frustrating, misleading, and above all, time-consuming. So our goal for O is to present notifications in a way that helps users sift through the noise, not just to build more associations, but to build a consistency and a trust. You should know where the important stuff's going to be before you have to go looking for it. The second most important insight that led to our approach was that people are the VIP notifications. In absolutely all scenarios, who is more important than what or when. So the opportunity here is pretty simple. Make people notifications VIPs of the drawer. People matter the most, and notifications is really a communications hub, so we really want to emphasize that in this space. So as I mentioned before, N focused on individual notification templates. And in O, we've zoomed out to kind of see the bigger picture and how they all fit together in one experience. Specifically, by improving the hierarchy of notifications that appear in the drawer. We did this by designating 4 different types of notifications and 4 different buckets for them, represented by these yellow blocks. Before I get into the detail of each different bucket, I'll give you the high-level overview. So the first bucket is for major ongoing. This is things like a phone call. The next is people-to-people, like a message from a friend. The third is general notifications, the best of which are timely reminders. And the fourth are by the way, or BTW. And these are the 4 buckets of notification types and how they're organized within the drawer. And the purpose of this is to ensure that notifications most critical to read first are shown first. It also creates consistency. When you pull down the drawer to find that specific notification you're looking for, you'll already know which area to be looking at because you'll become familiar with these sections. So we're enabling users to build associations through this ordering. And lastly, we're going to be ranking notifications within each section. This means if you have 2 message notifications, they're not going to be separated by something else in the middle. They'll always appear together. So it'll be a lot easier to scan the notification drawer. So now you have a big picture. Let's drill down into the details of each bucket, starting with the first one. Major ongoing notifications are really for time-sensitive content users should actively be aware of. This is like phone call, driving directions, timer, music. And as a developer, to send this type of notification, you need to be running a foreground service with importance higher than min, or using a media style with media session for music notification. And this type of content is for content that's using device resources that directly impacts real-life context. And the things that match that is a really, really short list. The type of notification will rarely be appearing in the user's drawer because the context that requires it is a very rare situation. So in N, this is kind of what these types of notification looks like, right? They're not very visually distinguished. They don't necessarily always appear at the top of the drawer. They can be lost amidst the other notifications. And if you wanted the proper prominence to really gain that association for the user, you had to go with customization, which led to inconsistency with the rest of the notifications. So in O, what we're doing is we're pulling that color from the app and filling the background with it and guaranteeing a top spot in the notification drawer. So these will always appear at the very top. But again, because they're so prominent, misusing this type of notification for something it's not meant for will be very obvious to users. And with the channels that Rachel just described, it'll be really easy for them to block this type of notification if it doesn't align with what it's really meant to be. Falling into this category is also music. So in N, you can see that the templates are, the music template, the media template's the most different template that we have compared to all the others, but it still feels really generic, and it doesn't really look different from other notifications. So in O, we've integrated the album artwork into the notification and drawn out the most prominent colors for the background and as an accent. The result is a beautiful, lively notification that really celebrates the artwork and the artists behind the music that we really love. And I found myself pulling down the notification drawer as I listen to music just to see what kind of colors that song generates. Now for the next section, people to people. This is really for content from a person, like a message or a missed call. And as Julie mentioned, people are the VIP notifications. So we're going to put them right at the top of the drawer in the #1 position, since major ongoing is going to be pretty rare. To get this type of notification, you should be using messaging style with direct reply or attaching a contact to it. So as it stands today, a message notification is really not that valuable until you interact with it. There's like one line of the message, so you don't know if it's worth actually expanding and reading. And then you still have to make the decision if you should reply to it, and you may not be able to reply to it directly within the drawer. You have to jump out of the drawer. So it's really just not that valuable. So in O, we've made one really subtle change that has actually made a really big impact on the messaging experience. And that is that we're exposing more lines of content in the collapsed state of the notification. So now you can read up to 3 lines of the message without having to spend the time expanding the notification and deciding what you want to do with it. And we're continuing to invest heavily in this area of focus, and we're looking forward to making even more improvements, especially around direct reply, coming soon. This next bucket is for general notifications, and the best of which, as we documented in material guidelines and Julia's research backs up, is really meant for well-timed and informative task reminders. And in O, there's no behavior or visual change in the representation of these notifications. But it does play into the next bucket, a BTW. And today, there are a lot of notifications being sent in this general bucket that really should be sent in O as a BTW. BTWs, by the way, notifications, are meant for contextual or informative but non-urgent content. We heard a lot of stories from Julie's research about how people felt so overwhelmed. If content in the drawer isn't urgent, it should be sent as a BTW. Things like weather updates or traffic, or suggestions and promotions. So earlier in this presentation, Rachel used Crane Air as an example of how to organize your app's notifications into channels. If you remember, there are 3 different channels: executive program, flight updates, and discounts and deals. And that last category of discounts and deals is an excellent example of what should be sent as a BTW notification. And it's pretty simple to send one. You just need to set the importance of the notification to min. So in N, the visual representation of these notifications is pretty equal with all the other notifications. The only difference was a slightly different colored background. It's a pretty heavyweight presentation for content that's actually very lightweight. It's bothersome to users. It takes up a lot of space. So what we've done in O is we've taken the app name and the first line of the notification and simplified that down into a single line. So the new presentation is really meant to feel lightweight so that users don't feel bothered by them. They don't need to manage them because they're out of the way, and it's OK if they can glance at it and don't want to take action on it right now. You can also set your notification to automatically expire so that users also don't have that burden of having to manage them as well. The advantage of this is that instead of risking annoying your users by sending a notification in that general bucket, you can send it as a BTW instead. This way, you don't have to hurt users' trust by risking something. You can just put it in the BTW section. Also, the full functionality still remains. So if the user taps on this BTW, it expands the full notification. You get all the color. And if the notification has actions with it, those will appear as well. So when you put it all together, it comes together really nicely. You can actually tell a very intentional order within the drawer. And when we compare that with N, that's when you can really start the difference. You can really see the differences come out. If you squint your eyes and look at N, which is on the left in the black phone frame, you can't really tell which notification is which at a glance. But if you look at O, it's really clear. You can see the major ongoing at the top. You can see the BTWs at the bottom. You can even kind of tell that it's a people-to-people, a message notification because it's taller than the rest. Now you can also see in N how when there's an overflow of notifications, those notifications got stacked behind the ones that were visible. This doesn't match up super well with the spatial model of the full-width notifications. So in O, we've improved that spatial model and made it feel much more unified. We have a really beautiful animation, and the point of this is to correlate the notifications of icons of how they appear in the status bar with the notifications that they are in the drawer. And again, yeah, you can pretty cool, right? This is something we're really, really proud of. And again, it wouldn't have been possible without those template changes that we made in N, right? So we're taking steps to unify the whole experience. You can also see how instead of stacking at the bottom, overflow notifications fit into a shelf. And we have a really beautiful experience going on. I'll just let it play one more time. Oof. All right, so this is the last feature I'll be covering pretty briefly, and that's snoozing. And this feature came directly out of user research. So the insight was that people need to remember the things they need to do. And today, you only have 2 options if you can't deal with the notification right now. You can either dismiss the notification and count on your memory, which if you're me, never works. Ask my wife. Or you can leave the notification in the shade, but it can get lost amidst a ton of other notifications, right? It's either or. So our opportunity was to give users more ways to do this in the drawer. So let's say you're in a meeting and you get a text from a friend asking you about dinner. Now you're in the meeting, so you can't reply right away, but you know as soon as you leave the meeting, your mind's already going to be on to the next task, and you're not going to remember to reply. So instead of letting the notification linger in the shade, or linger in the drawer, or dismissing it altogether, you can snooze it, and this is how. You can do a partial swipe, which reveals two different icons. You'll notice it's an additional icon to the gear that we introduced in N. And this is the button for snooze. So if you tap this icon, the notification will automatically be snooze. And you'll get a confirmation of this snooze with an option to undo it if you need to. So snoozing the notification will set it to come back at that set duration with the exact same interrupted qualities that it was sent with as before. So if it made a vibration tone when it came in the first time and you snooze it, it'll vibrate again the second time when it comes back. So if you want a different time than 1 hour, you can just tap that arrow, and you'll get a few different options to change that duration. And the option that you select then will then be set as the default duration the next time you snooze a notification. Pretty simple. That's what we have to show you for the new notifications in O. And if you're interested in finding out even more, especially from a more detailed engineering perspective, there's an earlier talk, What's New in Notifications, Launcher Icons, and Shortcuts, that we'd encourage you to check out. We're really excited about these improvements and believe that these features are not only beneficial to users, but will also increase the quality of engagement with their apps. Thanks so much. And we have a few minutes left for questions if you need.
How do you expect inheritance for existing
Hello, I'm Timothy Jordan, and this is your update about the coolest developer news from Google in the last week. The Advanced Android App Development online course has been updated, improved, and extended. With it, you can build a portfolio of apps as you improve your Android dev skills. The course is linked from the post in the description below. We recently launched AIY Projects, do-it-yourself artificial intelligence for makers. With it, makers can use artificial intelligence to make human-to-machine interaction more like human-to-human interactions. We'll be releasing a series of reference kits, starting with voice recognition. More details and links are on the post. Chrome 59 Beta is now available with headless Chromium, native notifications on macOS, service worker navigation preload, and more. All the details are on the post. Google Cloud Launcher has more Google-maintained containers, including Cassandra, Elasticsearch, Jenkins, MySQL, and more. Google Container Solutions are managed by Google engineers, and since we're maintaining the images, the containers available on Google Cloud Launcher will be current with the latest application and security updates. There are 2 announcements from Google Cloud Next London that I wanted to tell you about. First, Google Cloud Natural Language API is adding support for new languages and entity sentiment analysis. And second, Cloud Spanner is now generally available. Check out the details of both announcements on the post. Google I/O is just around the corner, and if you're like me, you like to go in prepared, which is why we have an Android, iOS, and web app to help you customize your I/O schedule and get around the Developer Festival. Check out the screenshots and find the download links on the post in the description below. Please subscribe and share. I'm Timothy Jordan, and I'll see you next week.
As a lot of developers know, there's more to having an app succeed than just building a great app. You want your app to be dynamic and responsive by delivering fresh content to users and quickly reacting to their changing needs. You want to test out major decisions to make sure you're doing the right thing before you push them to your entire audience. And ideally, you want to provide a tailored experience for each user, so your VIPs feel like, well, VIPs. But let's be honest, that can be a lot of work. And if you're a developer without a ton of resources, that's time you'd rather spend on other things, like building your app. That's where Firebase Remote Config comes in. Firebase Remote Config is a simple key value store that lives in the cloud. But don't let that simplicity fool you. Because it lives in the cloud, it means you're able to deploy changes that your app can read within a matter of minutes. For instance, say you've just pushed your app out to the world and you suddenly discover that your Swedish text contains some offensive language. How are you supposed to know? You don't speak Swedish. I don't blame you. But fixing that text the old-fashioned way would mean creating a new build and going through the entire publishing process again. That's something that could take days, which is an awfully long time to have 9.2 million people cursing your name. But if your app uses Firebase Remote Config, you could change that text in the cloud through the Firebase console. Kind of like this. The next time your users fire up their app, Remote Config will grab the latest values, update your app's text, and just like that, you've averted a major international crisis. Or, let's say you've got a puzzle game and you're hearing complaints from your players that level 5 is too hard. If you've configured your app using Remote Config, you could tweak those settings to give your players a few more turns and push out that change to the world. But hang on, are you sure that's the right thing to do? What if the silent majority of your users actually enjoy the challenge of a more difficult level? And by making it easier, you're going to turn away your most hardcore and potentially highest paying customers. How could you test whether or not this change is a good one? Sounds like you need an A/B test. That's where Remote Config's audience segmentation feature comes in. This allows you to deliver different configurations to different groups of users simultaneously. So you can try out your new level settings with half your users while keeping the old settings with the other half. But audience segmentation isn't just great for A/B testing. Maybe you've got a feature change that could have a major impact on your in-app economy. Or maybe you just want to double check that some new networking code isn't going to set your servers on fire. You can use Firebase Remote Config to gradually roll out these changes, trying them first with a small percentage of your users before pushing them out to your entire audience. Remote Config can also deliver different configuration sets to your users based on all sorts of different factors, from device type or locale to any audience segment you've defined in Firebase Analytics. So you can send out one welcome message to your New Zealand customers and another to your Australian ones. or only show your Review This App button to people who use your app every day, or you can change your home screen experience for your customers who have spent large amounts of money on in-app purchases, so they feel special. Remote Config is backed by a client library on iOS and Android that handles important tasks like caching, dealing with flaky connections, and keeping network requests lightweight, which is always a good thing. To give Remote Config a try, check out our documentation here. We can't wait to see what you build.
Yeah, with NPR One, we are reimagining what a listening experience could be outside of the radio.
It's the radio, but better. It has all of the great stuff that we've spent 40 years perfecting.
With NPR One, we see the opportunity of reaching a more diverse audience that have a device in their pocket at all times.
My name is Mike Saiflahi. I'm the lead mobile developer for NPR Digital Media.
My name is Nick Dupre, and I'm the innovation accountant at NPR.
My name is Tejas Mistry, and I'm the senior product manager of NPR One.
So some of the biggest challenges in any mobile app are that first impression. When the user first installs the app, you've got a very limited amount of time to convince them to keep the app and to get engaged in the experience. Trying to figure out how we can get users into the content as quickly as possible was the real focus of integrating Firebase and dynamic links. Using dynamic links, we were able to shorten the number of interactions it takes for a user installing the app to get from the promoted content to the content from 20 to 3. So that user is able to get right into the content.
We're driving more and more listening per user every week. It's really astounding. Creating playlists of content that are configured by the podcaster or by a member station or by us internally. And with Firebase, we have that at our hands.
Having the analytics product interact with things like dynamic links, remote configuration, cloud messaging, it adds a real multiplier effect.
And the integration with the broader Firebase suite, I don't have to go outside the platform to figure out what's working. So it's not just about shipping the product faster, it's about analyzing the results faster. And with the integration with all the other Firebase products, we're really excited about all the things we can learn from it.
We all know from experience that people love to share things about themselves, such as photos, videos, and GIFs that express their feelings. So what do you do to let them store and share these files through your app? That's where Firebase Storage can help. Our storage API lets you upload your users' files to our cloud so they can be shared with anyone else. And if you have specific rules for sharing files with certain users, you can protect this content for users logged in with Firebase authentication. Security, of course, is our first concern. All transfers are performed over a secure connection. Also, all transfers with our API are robust and will automatically resume in case the connection is broken. This is essential for transferring large files over slow or unreliable mobile connections. And finally, our storage, backed by Google Cloud Storage, scales to petabytes. That's billions of photos to meet your app's needs, so you will never be out of space when you need it. So give your users space to share their lives with Firebase Storage, available right now for iOS, Android, and web applications. And to learn more about Firebase Storage, check out the documentation available right here.
Right, let's have a little chat about a brand new API that's just coming out on the platform called the Media Session API. I heard about it when I started doing this app. It was mentioned to me by a couple of the Chrome engineers. But Francois, who's on my team, there's a brilliant Google Web Developers update where he explains in complete detail about how to set up the Media Sessions API. So check the notes below. We're going to pop in a link for that. But I will just show you briefly what it actually looks like in the context of the app on my phone here. In fact, because you probably can't see it, let's switch across to the direct screen cam. There you go. And that's what it looks like on the phone. So as I start playing a video like this, you see that if I swipe down from the top, we actually get a notification which has an icon here, and it has play and rewind and fast forward buttons, and you get to configure those yourself. In fact, let me go into another one of these videos where I think I've actually set up to load some custom album art as well. So there's me and Jake. And you can see here now we've got custom album art, which is the picture of Jake, and the previous and next, the fast forward and rewind buttons are actually set to be skip forward 30 and go back 30. So I should be able to tap that and go forward 30, which you can see there. Oh, it's just skipped it right to the end. Whoops-a-daisy. But I can replay the video. Don't worry. The other thing that it actually does, which I really like, is if I turn off the screen and then on again, you can actually see that the picture, the album art, is actually the picture for my phone in the background. That is very exciting, isn't it? So let me show you a little bit as well, since we're here. Let me show you a little bit of the code. It's very straightforward. We have a quick check whether we support the Media Session API, which is basically looking for, let me show you actually. It is just simply looking for Media Session in Navigator. And if we have Media Session in Navigator, then we consider ourselves having the Media Session API. And what we do is we say navigator.mediasession.metadata, and then we create one of these new media metadata thingamajigs. Very exciting. ESLint doesn't like it. It doesn't think it's a real thing. It is a real thing. You can totally use it. And you give it things like the title, the album, the artwork. I've only set the 512 and the 256, but very much like your manifest files for progressive web apps, you can set as many of these as you need, and the user agent will choose whichever one it thinks it makes the most sense for the device that it's on, and it will upscale and downscale as necessary. But I currently am just setting a couple of them. I may need more as time goes by. And then afterwards, after we've set up the metadata, we set some action handlers for things like the play, the pause, the seat backwards, and the seat forwards. The thing to bear in mind here is that any that you set will have the buttons appear in the notification. If you don't set one, because there are other ones that you can set as well, and I forget which ones they are, but check out Francois' post. He explains the whole kit caboodle. Any that you don't set won't appear. Any that you do set will appear in the notification, and then somebody can control your stuff from the lock screen or by just dragging down from the top. All very good, isn't it, that? And very straightforward code to be writing. So a brilliant little progressive enhancement thing that you can chuck on, and that I have chucked on my media app. Cool. Toodaloo.
Hey gang, want to see something neat? Check out this awesome hidden feature I found in Firebase Analytics. So I'm over here looking at all my reports in the Firebase Analytics dashboard. Here, for instance, I've got my active users for the last 30 days, and while these graphs sure are pretty, I'm thinking it'd be kind of nice if I could get these numbers into like Google Sheets or maybe Excel so I could analyze them a little better, right? Well, watch this. I'm going to select my graph here in the Firebase console. It's kind of hard to tell, but you can see by like the highlighted text here that my graph has been selected. And then I'll hit Command-C to copy it. And then I'm going to switch to a blank Google spreadsheet and hit Command-V to paste. And look at that. All my values are right there in the spreadsheet for me to analyze. So you can see here on the leftmost column, I've got the date, and then all the actual numbers are in the columns next to it. Now you might notice that I seem to have two columns of what looks like the same data, right? I've got monthly active users here, and then right next to it I've got this monthly users column. And then the same goes for my weekly actives and same for my daily actives. And so basically that first column is for the value that corresponds to the date here on the left. The second column is basically for that corresponding day in the previous 30-day time period. Basically, it's the values that belong to this dotted line here in the graph that I copied. Make sense? Okay. And then I can do the same thing for a bunch of these other graphs. Here I can copy and paste my daily engagement numbers. Let's get these into a new sheet here. And again, you can see I've got my engagement numbers from this time frame in this first column, and then those same numbers for the previous 30 days in this second column. And better yet, I can jump over to an individual event like this completed 5 levels event and copy all these graphs here at the top. And you can see I'll get event counts, user counts, event per user counts, and values for every one of my events that I am recording in Firebase Analytics. And this lets me do some pretty nice calculations right here in Google Sheets. For example, let's say our game designer is curious how often people are failing a level in our game. Well, for starters, I've got my level start graph here to show when people are starting a level in my game. So first, I'm going to copy and into a sheet. Let's put them in. Okay, great. And then I'm going to do the same thing for my level fail graph, and that will show when people have failed a level. So we'll copy from here, and we'll paste them right in next to my other numbers. And once I've copied and pasted these values into Google Sheets, I can then calculate my average failure rate per game stat by dividing this number here by this other one. I'm going to copy this formula down for all of my dates. Let's give it a percentage format so it looks nice. Maybe we'll add an average at the bottom here. Let's do average for all these numbers. And there we look at an average failure rate somewhere in the low 30s, which sounds like it's just challenging enough for our players. So our game designer is happy. Now, a couple of disclaimers here. First, this doesn't work on all the graphs I've tried. Some of them just don't seem to copy and paste as well as others, but it does work on a surprising number of them. You'll just kind of have to try them out and see if they work. And second, this will never be a replacement for some of the awesome and sophisticated data analysis capabilities you get by exporting your raw data to BigQuery, and you should totally go watch this video if you want to find out more. But if all you want to do is maybe compare two graphs to each other or calculate some standard deviations or averages on a particular event, this trick can work surprisingly well. So give it a try yourself, have fun with it, and we will see you soon on another episode of Firecasts.
It's been just over a year since we open-sourced TensorFlow, and we've been thrilled to see the adoption by the community and the pace of development both here and all around the world.
TensorFlow is really the primary tool that we're using for a lot of our machine learning work in all of our products. Towards the end of last year, we actually rolled out a completely new translation system that was based on deep neural nets. In Gmail, we were actually able to roll out a TensorFlow model that, by understanding the context of the message you just received, we can predict likely replies. And this is a feature we call Smart Reply.
Diabetic retinopathy is the fastest growing cause of blindness. It's a complication of diabetes. We gathered a very large data set and had doctors grade the images. And then we, using TensorFlow, trained a neural net that does a pretty good job of predicting whether or not there is diabetic retinopathy in the image.
Can we use something like TensorFlow to make music, to make art, and to allow us to communicate better with each other? With TensorFlow, we're able to think abstractly, almost at a level of like improvisation with machine learning. We're able to try new things, to chunk models together in ways that were impossible before we had that kind of expressivity.
Dugongs are classed as vulnerable to extinction globally, so we do a lot of aerial surveys using drones. Then once you've done a survey of a really large area, you end up with tens, if not hundreds of thousands of photos. The goal was to find a way to automate that whole process, and that's where we've been using TensorFlow.
One of the things that we've been focusing on this year with TensorFlow is performance. We've been especially excited to release support for distributed training.
We want to make it easier for people to use so they don't have to necessarily know all of the underlying internals in order to get the distributed performance the best it can be. XLA is something that can compile down TensorFlow. Maybe you want to compile your graph ahead of time and get it down to something much more compact in terms of memory size, so that way you can easily load it and execute it on something that might not have as much storage space, like a mobile phone or some other portable, smaller device.
When we introduced the Hexagon Vector extensions, what we had in mind was enhancing user experiences with imaging features.
So the TensorFlow team said that you only needed low precision multiplies to be able to execute these neural networks efficiently. So we did some tests, and on the same graph, Inception v3, we were 8 times faster and 4 times lower power than running on the CPUs.
TensorFlow is great to work with, easy to work with, lots of capability. And so our engineering teams and their engineering teams working together, we were able to do something very exciting. This is just the beginning of what will end up being a long evolution of some great things we can do with machine learning in image processing.
In addition to sharing TensorFlow, Google has also shared an ecosystem of tools, which contains everything you need to go all the way from research to production. One such tool is TensorFlow Serving, and this is an open source, high performance serving solution. Another great tool, which is actually quite beautiful, is the embedding visualizer. And you can use the embedding visualizer to interactively explore high dimensional data sets. On the education side, General Assembly has done great work teaching TensorFlow.
For my final project, I was really interested in doing lyrics generation, and TensorFlow was a really great match for that because it allowed me to build out and utilize the models that I needed to be successful.
The TensorFlow community is thriving around the world, and we're excited about as many people as possible being part of it. TensorFlow is an open source project for everyone. We're looking forward to building this into something even better and more useful and more powerful in collaboration with the whole worldwide community.
And here we are in the Code Labs area. This is a special part of Google I/O where if you've always wanted to learn a new API or tool or service, you get to come here and work on the Code Lab. And if you have any issues or you want to get in more depth, you can ask a Googler for their help. Any question you happen to have. I'd like to learn a little bit more about what it feels like to do Code Lab here at I/O. And to do that, Claire, how you doing?
I'm great. It's been a long couple of days, but a fun couple of days.
I hope that means a lot of people learning a lot of things.
Oh, most definitely. We've had lines waiting pretty much the entire day.
That's very cool. So what's the setup like here?
The setup here is a bunch of computers that are all pre-configured with the steps to do and learn pretty much whatever you want. You can tell what's going on by the status of these lights up here. If they're green, it means the computer's ready to go, ready for you to come up and learn. If they're blue, it means Code Lab's in progress. And when they turn red, it means that someone needs a little bit of help or has got a question, and one of our staff will zip over right away and help them out with that.
That's totally cool. Now this is a special Code Lab station that actually has a whole bunch of devices. What's going on there?
Yep. That's right. So right now we're in our special IoT Code Lab section. We've got a couple different devices over here that people can run a bunch of various of our Code Labs on, and they'll actually get to interact and play with them. This one's got some buttons and lights and numbers. It's got a button that's very fun to play with. It's a good time.
All right. Is there anything else you want to say about the day? How's it been going?
Really good. We've had a lot of people with very insightful questions, a lot of people showing a lot of enthusiasm for the subjects, which is always my favorite thing to see.
Awesome. Thank you so much.
Thanks, Timothy.
And that's the Code Labs area. Thanks so much for joining me. Remember, I'm Timothy Jordan, and if you'd like to catch some more of these videos after I/O, head on over to g.co/io/guide.
Hi, everyone. Good afternoon. My name is Garen, and I'm a product designer that works on emerging markets projects here at Google.
And I'm Tracy, a researcher that works on emerging markets at YouTube.
And we're super excited that you're joining us this afternoon to talk and learn about design for new internet users. Most recently, Tracy and I spent the last few years working on YouTube Go, which is a new version of YouTube, a new app that's been designed and built from the ground up for new internet users in countries like India. And you may have heard about this in the keynote back on Wednesday that was announced as part of the Android Go operating system. So if you're interested in designing apps that work great on Android Go or just work great for new internet users in general, then we're glad you're here. This talk is for you. This is important because the majority of new the majority of people coming online, and actually the majority of people online right now, are in emerging market countries like India, Indonesia, Brazil, Nigeria. So if you're interested in going global, if you're interested in scaling any projects or products that you work on, it's important to consider their experiences and their contexts. So you might be thinking, well, Android is doing really well. There's this announcement that Android has over 2 billion users. Why do we have to do anything differently? We know from a host of qualitative and quantitative data that these internet users have very different experiences from those of us in this room. If you think about your first computer experience, it was probably a couple decades ago. You probably started using a desktop. You probably started connecting to the internet on that desktop. Your internet connection was probably fast, reliable, and not too expensive. Right now, you probably have a cell phone that's pretty good, has a good screen. It's pretty fast. You're on Wi-Fi now, or you're on Wi-Fi at home, at work, or events like this. And when you're not on Wi-Fi, you've got pretty good access to mobile data to be online all the time. Compare this to the typical persona, or a typical persona of a new internet user. These folks are coming online with their first computer, their first internet experience being a smartphone. And it's oftentimes not this kind of fancy smartphone that we carry around. It's a lower-end smartphone, sub-$100, sub-$50 smartphone. These phones don't have great screens, don't have great contrast. They've got different kind of touch feedback. They've got low storage, low RAM. Oftentimes, they're running older versions of the operating system. They're not updating their apps frequently. They're using the internet on slow, expensive, flaky connections, and rarely, if ever, are folks using Wi-Fi. So, will we still believe that universally we are all human, regardless of whether somebody is in India, Indonesia, Nigeria, United States, or London? We're all human. We do think it's really important that we consider the context, the different cultures, the different constraints, and different mental models that people bring to their internet experience. So over the past few years, we've invested a lot in thinking and figuring out what to do within Google, and we're excited to share a framework that we use within the company for building for new internet users. So in the course of this talk, we're going to talk about what it means to make your product usable, useful, and engaging for these types of users. We're going to give you very quick, very focused tips for each one of these components. So it's not going to be really nebulous, very designy. It's going to be very applied. And Tracy, do you want to kick us off?
Sure. So our first bucket is usable, which focuses on the question, which is simple but challenging: can your product be used? And this bucket contains 3 components: cost, connectedness, and compatibility. So the first will be cost. We can start with a comparison. To afford 1 gigabyte of data in the United States, you would need to work a little bit over 20 minutes on average. But to afford the same exact thing in Indonesia, 1 gigabyte of data, you would have to work 316 minutes, so nearly 5.5 hours. So in markets like these, like Indonesia, data is much harder to come by, and for that reason, people savor every MB that much more. Also in these markets, most of the data is prepaid. Specifically in India, 95% of it is prepaid. And prepaid is where people buy fixed amounts of data up front. It's not an ongoing commitment, which we might be familiar with. So imagine going into a store and you buy a small paper card with a scratch code on the back that maybe you buy for 40 or 50 rupees, and you get 100 megabytes of data. That might last 1 day, 5 days, or even up to 28 days. So the behavior we're seeing is that people are buying denominations based on what they can afford, what they foresee as actually needing, and then they budget out their data use over that time period as necessary. So overall, data just feels like money in these markets. And compare this to what happens in the US. We usually buy a pretty high data cap plan by month, or we pay on every month, but we pretty much commit for a long time. And we're often connected to Wi-Fi, so we don't really worry about running out of data, maybe only at the end of the month. So what is Wi-Fi really like in these markets? Wi-Fi is actually rarely connected to because it's not that accessible. Globally, there's 1 Wi-Fi hotspot for every 150 people, and in India, it's a lot higher. There's about 31,500 hotspots overall in the country. So that means 1 hotspot for every 3,900 people. So if India wanted to meet the global average, they would have to install 8 million more hotspots. And the point here is that public Wi-Fi access is rare, making data, again, that much more precious and expensive. So now you might be thinking, Wi-Fi at home. Home is where we have the comfort of Wi-Fi. We're wrapped in the comfort of our own connection, our nice security blanket. We're not spending any of that mobile data. But this is not necessarily true in these types of markets. Currently, less than 2% of the entire population in India subscribe to a fixed-line broadband internet connection in their home. And if they are accessing internet at home, it's mostly through their mobile data on their mobile device. So in sum, Wi-Fi access is still very rare. And we can't be assuming that Wi-Fi is going to come along at certain cadences for these users to fix whatever blockages or barriers they may hit in other connectivity states. So our tip here for the first component of cost, for data-heavy tasks, provide transparency and control over data consumption. The example on the right is actually from YouTube Go. After selecting a video, users are given the control to select their quality before watching. So they know upfront how much data they'll spend before committing to an action to either play or save the video. And we specifically say for data-heavy tasks because this type of transparency might be less important for smaller amounts that could be considered negligible, like 10 KB.
So the next component of the usable bucket is connectivity. We know that the internet is much slower in different parts of the world. The statistic is that in India, on average, the internet is 3 times slower than it is here in the United States. And most of the folks that are coming online for the very first time are coming online on the slowest connections, on cheap 2G, 3G connections, or overloaded free public Wi-Fi networks. But on top of it being slow, it's also important to consider the flakiness and the intermittency of the connections. So 65 to 80% of the time, 3G connection will, a round trip will actually work. There'll be uptime only for this amount of time. So you can imagine for seconds, for minutes, for hours at a time, even though you might have data, you might not be on airplane mode, the internet still might not be working for you. So it's crucial for those of us that are creating software to acknowledge and actually embrace these states of intermittency. As designers, we usually approach designing for these types of connections by looking at states. So typically, these are the states that we're often used to designing in Silicon Valley or in well-connected tech company environments. There's online state, which is considered the ideal state. Sometimes we think about partial loading states, and oftentimes we'll design error states as well. So a typical mock might look like this for us, or a typical flow of mocks or designs might look like this for us. You might move from one online mock to another online mock to another online mock, and that might be how we design how an app experience actually is. Maybe you design an error case as well. But this isn't really comprehensive. This doesn't actually meet the needs or doesn't portray the experience of a new internet user. So we've actually added a few other states to make this more comprehensive. In addition to considering the online state as ideal, we also think about the offline state as ideal, both because connections are flaky and because connections are expensive, so people turn off their mobile data frequently. In addition to loading being in progress, partially loading, we also have loading started, just to let folks know that something is actually happening. In addition to having an error content, we also have a state that portrays when you're offline and there just is no content. It's not a problem if you don't have connectivity, and it's not a problem if nothing is cached on your device. So if you use this kind of framework and you're walking through the design of a product, you end up with a life cycle that looks kind of like this. You're offline, you don't have any content, you switch it on, the loading starts, there's partial loading that's happening, then you're in a full online state, and then maybe you switch off your connection because it's flaky, or you switch off your connection, it's flaky, and then you go into an offline state. And we consider all of these states first-class citizens. So our tip for connectivity is to expect latency by designing offline loading, retry, and success experiences. Make great connectivity an edge case. So oftentimes we're used to designing edge cases as when there's no network. Have no and slow networks be your primary use cases, and have great connectivity be the edge case. The example that we have here is Chrome's offline page, which has recently added a download page later button. So not only does Chrome work offline and give you helps to figure out what's going on, but there's also an action that you can take on this page, on this piece of content. Another example for this tip is Google Search. Google Search has launched a new feature where when you're offline or when you're on a flaky connection and the connection to Google doesn't work, you can search for something, and then Google Search will give you a notification of the content when it's ready. So you can turn to Google Search in great connectivity, in flaky connectivity, or no connectivity, and still count on getting an answer back. The final component of the usable bucket is compatibility. And oftentimes when we talk about compatibility for emerging markets or for new internet users, we talk about operating systems, hardware, software, and all of those are very important for all the developers in the audience. These are important things to focus on. But I want to talk about something that's actually design related, which is that half the phones in India are sold. Half the phones in India right now are being sold they're less than $100. And actually many of them are $30, $40, $50 phones as well. And as you can imagine, a $50 phone doesn't really have the same type of screen, doesn't have the same touch feedback, doesn't have the same contrast, doesn't have the same resolution as an expensive premium device screen does as well. It's also got lower processing. On top of that, because phones are expensive, people keep using broken phones. Just because a phone breaks doesn't mean they go out and buy a new phone. Oftentimes broken phones are used, and when a new phone comes, the broken phone will still be used by another family member or by somebody in a more remote or more rural location. So it's important that we understand that low cost and broken phones are actually part of the ecosystem in which people are using our products. Material design provides a variety of affordance options, and it's always being revised, and there's more affordances that are being added. And so we encourage you to choose the types of affordances that make most sense for these types of phones. The tip here is to design clearer, larger, farther apart affordances to prevent mistaken taps caused by bad and broken screens and high contrast environments. You'll see the example here is from YouTube Go. There's a modal, there's 2 buttons. The buttons are not just text buttons. We didn't choose to use that affordance option. We chose to use big buttons with contrast, high contrast, big background, and big backgrounds. And this ends up being easier to see when you're in the sunlight or when you're using a screen that isn't as great.
Yeah, and to add something too, what we've learned really strongly in our user research is that pairing together icon and text can really help people understand and remember what an affordance does. You can consider each item, the icon and the text, as compensating for each other for any little bit of each that might get inevitably lost in translation. So now we move on to the second bucket of useful. This contains also the second set of components: culture, content, and commerce, evaluating, is your product valuable? Not just if it can be used, but is it also providing good use to the users? So the first is culture, and culture manifests in numerous ways, but we're just going to explore one branch of it for time purposes. So before search engines existed, there were sites like this, like DMOZ, which was like a portal to the internet, a directory of the internet's top-level content. And whether you knew what you wanted to search for or didn't, you'd start with a related category and go from there. But now we've evolved more into this very familiar format of searching to all of us, which is arguably a little less guided. But this works for us because we had portals like DMOZ help us build a really strong mental model for what lived on the internet and how to find it with the high-level categories and then the subcategories. And studies have actually shown that your mental models and your visual preferences are heavily shaped and affected by the physical landscapes you grow up in and the environments you grow up in. So why can't this be applied to digital environments too? We can't assume that everyone coming online who hasn't had this DMOZ type background has the same mental model of searching. It can be really hard to know what you want to search for and also to formulate a query. Imagine how intimidating it could be to form a query in your second, third, or fourth language and then hope to find some semblance of a relevant result come up afterwards. So our tip for this bit of culture is to show the breadth of what's possible in your product. Don't assume an existing mental model. The example we have here is actually Google Search itself on this mobile device. So there are options to discover not just particular categories, but you can also dive directly into news content. You can find out the current weather before even worrying about typing. And typing can still be very hard on mobile devices. Another example are categories within the Google Play Store. Again, this screen guides users to show what the Play Store contains, and it clearly shows the various categories with matching icons on the side. The next component is content, and one way, just one way that content manifests is with language. Statistics on English speaking ability can be pretty unreliable, but it's generally accepted that about 30% of the population in India can speak English, and a third of that have some semblance of reading and writing aptitude, so 10% overall. And this is a really interesting statistic to consider alongside the fact that a lot of users in these markets and globally use their Android OS in English, despite it not being their first language and despite not fully understanding written English. So another thing we can't assume is that users in these markets will use interfaces in their native language, if that's even offered as an option. And we also can't assume that they want to type in their native script. So we need to work on improving our English UIs. Our tip here is to simplify language. Short, simple, direct for maximum clarity. And with this, to avoid very culturally specific phrases like shucks. Most of the examples we've been showing so far are examples of what to do. And we want to show a quick example here of a screen that may not work so great in other markets. This is a past YouTube onboarding flow that said, "New awesomeness awaits." And the word awesomeness doesn't really mean awesome or really anything in other vernaculars.
Finally, the last component of the useful bucket is commerce. And oftentimes when we talk about commerce and new internet users, we talk about forms of payment because so many economies run on cash. That's important for your product to consider from your business standpoint as well. But we want to talk about a UI-specific design example as well. And that's around sachet economics, sachet marketing. So sachets are small little packets of consumer goods like shampoo or detergent. And what they are is they're really cheap, so people can go and buy them. And this allows folks to get a sense of what the product is and try it out at a very low cost. They can try the experience a little bit before they commit to buying something even more. So instead of buying a big bottle of shampoo, they'll buy a single one-time use sachet of shampoo. And we can actually bring this learning back into how we design digital experiences as well. And our tip here is to allow people to try before they buy, providing tastes of experiences before you want them to commit to them. The example here that we're showing is a website of Flipkart. Flipkart is a big e-commerce company in India. And what we're not showing here, actually, is the Flipkart Android app. Good Android app, great Android app, but Flipkart has heavily invested in a web presence as well. So for folks that don't really know what Flipkart is, that don't want to invest in the data and the storage and the battery to download an app, they can go poke around the website to get a sense of what the app is before they commit to downloading the app. Another example of this is within YouTube Go, where when you tap on a video, before you choose to play or download the video, we show you a little preview of what's inside. We're not going to give away the entire video, but we show you a sense of what you'll be getting if you choose to spend the MBs to download it. Keep in mind, like Tracy said, data feels like money for a lot of folks. So it's not just spending money that feels like money. It's also spending data. It's spending limited storage that folks have on their devices, spending limited battery.
So the final bucket of this framework is engaging. Does your product delight by being social, sensorial, and surprising? In this context, social touches on the fact that the cultures in these types of emerging markets is collectivistic. It's not individualistic. They rely on human networks to fetch information, to learn new things, to discover. Friends are their search engine. For us, Google is our search engine. And there's nothing wrong with that, but considering how we fetch information with search engines, while we are leveraging the other people's knowledge on the internet, it's still very often an individual experience. Additionally, content like a funny video is very valuable social currency in these types of environments where new online content is a lot harder to search for and therefore a lot harder to access. Our tip here is to encourage the sharing of experiences. Don't just design for the individual, but for the community as well. If you allow people to show off to their friends and family, it really bumps up the social currency of your entire app. In this example, YouTube provides a pretty clear shared afforance centered underneath the video and the title, so it makes the action really easy to discover and act upon at that moment that you realize you want to share this content. This is just one way, though, that a product has encouraged sharing. Our second example is the peer-to-peer sharing feature within YouTube Go, which allows people to transfer videos or social currency to any friend nearby with very, very minimal use of data. The second component is sensorial. So not all cultures embrace what we deem this minimalistic aesthetic that seems to be quite coveted in Western cultures. And why it's not always coveted in other cultures could be due to a lot of reasons, be it traditions, resources, beliefs, or what have you. But in these markets and cultures, you'll see a lot of different uses of color, patterns, and designs that can connote a feeling of vibrancy or energy to our Western eyes. So for instance, here we see a comparison of clothing and textiles across 3 different countries that differ vastly from each other and also from Western markets too, be it the context in which they're wearing the clothes, how they're crafted, the colors, the meanings behind the patterns, etc., many more things. Another really interesting example is information density with respect to high context and low context environments. The center image is from a really interesting study that showed that users in Indonesia preferred icons that depicted more of the surrounding context of the object and more detail in the icon depictions, whereas users in the United States preferred the more abstract, simple icons or more low context designs. The images on the sides are common scenes that you'll see walking the streets in India, very dense signage or stores that are organized maybe how you would consider your storage room is organized. And the main point is that what's considered clutter to us or not clean and simple design could be the preference for others. A lot of these differences can also be really overwhelming, but ultimately we say they should be embraced. So our tip really is don't westernize everything. That's not really what people want. Nod to local aesthetics by drawing inspiration from regionally popular products or hiring local designers. This will make your product feel more relatable, that you care and pay attention to the cultural aesthetics. A really great example here is Google Allo stickers. That team hired local designers in India to create these downloadable sticker packs. And not only can you see the pretty clear inspiration of local aesthetics, but also the addition of common transliterated phrases.
And our last component for the engaging bucket is surprising. This is the one that's the most nebulous. What we strongly recommend is to surprise and delight by doing one thing or just a focused set of things very, very well. It's really easy to think of emerging markets, to think of new internet users as having a lower tolerance or being less savvy, and that's absolutely wrong. Just because they're new to the internet does not mean they're new to life, does not mean they're willing to settle for less. They've got different mental models, different desires, but they also they want great experiences. And because many of them are coming online for the first time, they're trying to evaluate how they use their technology. They'll try something out, and if it doesn't make sense, they'll move on to the next thing. So at an umbrella level, it's absolutely critical that you keep your product focused, not have too many gimmicks, and just focus on doing this one thing, delivering the value very clearly. People are critical. They're looking for great experiences that resonate with them, and we think that this is the way to do it. This is the way that a lot of product development happens at Google as well, where we focus on figuring out what this value makes sense and just being very focused on delivering that. So thank you for following along as we've discussed these different components of these different buckets and making your product usable, useful, and engaging. In India alone, over the next couple years, 100 million people are going to be coming online every single year. So let's not forget that while we're all human, while we all care about our families, we have similar aspirations for our families, our lives, there are many different cultures, different context constraints, and mental models that we can accommodate for as well. We think that they deserve great internet experiences, and we're excited that you're here, that you're thinking about this. And if there's one piece of advice that we can give you other than following this framework, it's to listen to your users. And whether that means going to a place where your product is popular or you want it to be popular to conduct some user research, or to building feedback mechanisms into your product, even just looking at the Google Play reviews and looking at where the feedback is coming from, which geographies they're coming from. We think that focusing on the user is the way to help understand how to deliver that focused value. Thank you very much. And this framework is published online in the ACM Interactions magazine. So you can go ahead and check that out at this short link. We also have a website, developers.google.com/billions. And we'll leave you with this framework and these tips all on one slide. And we invite any Q&A as well. So please come up to the microphones in the aisles. Thank you.
Thank you. Hi there.
Hi there. Any plans of introducing DCB in India?
Could you repeat the question?
Direct carrier billing in India.
Introducing which in India?
A direct carrier billing.
Oh, a carrier?
Direct carrier billing.
Yes.
There are some teams within Google that are experiencing it or that are experimenting with it in different parts of the world. And so it's all kind of business discussions that we're not necessarily privy to. But I think this is on the mind.
Yeah, because that is one of the main issues over there. People don't hold credit cards. So it's online payments are big issues over there to sell your app.
OK, yeah. Thank you for that feedback. We'll pass that along. We'll let you know that you asked we'll let them know that you asked the question.
Thank you.
Thank you.
Hey guys.
Hey.
A question regarding the density point that you mentioned. How much of it do you think is a preference, or is it just environmental, where they have a lot of shops around and they just feel the need to have like all the options available and just becomes dense as a result of it?
Oh, that's an interesting question. I'm not sure that we're sure yet of the ratio of how much each plays into it. I think more of the point was that we see that products can force a more simplified
As a lot of developers know, there's more to having an app succeed than just building a great app. You want your app to be dynamic and responsive by delivering fresh content to users and quickly reacting to their changing needs. You want to test out major decisions to make sure you're doing the right thing before you push them to your entire audience. And ideally, you want to provide a tailored experience for each user, so your VIPs feel like, well, VIPs. But let's be honest, that can be a lot of work. And if you're a developer without a ton of resources, that's time you'd rather spend on other things, like building your app. That's where Firebase Remote Config comes in. Firebase Remote Config is a simple key value store that lives in the cloud. But don't let that simplicity fool you. Because it lives in the cloud, it means you're able to deploy changes that your app can read within a matter of minutes. For instance, say you've just pushed your app out to the world and you suddenly discover that your Swedish text contains some offensive language. How are you supposed to know? You don't speak Swedish. I don't blame you. But fixing that text the old-fashioned way would mean creating a new build and going through the entire publishing process again. That's something that could take days, which is an awfully long time to have 9.2 million people cursing your name. But if your app uses Firebase Remote Config, you could change that text in the cloud through the Firebase console. Kind of like this. The next time your users fire up their app, Remote Config will grab the latest values, update your app's text, and just like that, you've averted a major international crisis. Or, let's say you've got a puzzle game and you're hearing complaints from your players that level 5 is too hard. If you've configured your app using Remote Config, you could tweak those settings to give your players a few more turns and push out that change to the world. But hang on, are you sure that's the right thing to do? What if the silent majority of your users actually enjoy the challenge of a more difficult level? And by making it easier, you're going to turn away your most hardcore and potentially highest paying customers. How could you test whether or not this change is a good one? Sounds like you need an A/B test. That's where Remote Config's audience segmentation feature comes in. This allows you to deliver different configurations to different groups of users simultaneously. So you can try out your new level settings with half your users while keeping the old settings with the other half. But audience segmentation isn't just great for A/B testing. Maybe you've got a feature change that could have a major impact on your in-app economy. Or maybe you just want to double check that some new networking code isn't going to set your servers on fire. You can use Firebase Remote Config to gradually roll out these changes, trying them first with a small percentage of your users before pushing them out to your entire audience. Remote Config can also deliver different configuration sets to your users based on all sorts of different factors, from device type or locale to any audience segment you've defined in Firebase Analytics. So you can send out one welcome message to your New Zealand customers and another to your Australian ones, or only show your Review This App button to people who use your app every day, or you can change your home screen experience for your customers who have spent large amounts of money on in-app purchases, so they feel special. Remote Config is backed by a client library on iOS and Android that handles important tasks like caching, dealing with flaky connections, and keeping network requests lightweight, which is always a good thing. To give Remote Config a try, check out our documentation here. We can't wait to see what you build. So you've built an amazing mobile app that your users are going to love, but you want to get it into people's hands and let them see just how awesome it is. Well, AdWords helps you do this, putting ads for your app in front of billions of people that use Search, YouTube, Google Play, and more. You can quickly set up an ad campaign to reach the type of users that might be interested in your app. You only pay if the user clicks on that ad, and you can set the budget and acquisition costs that you're comfortable with. But how do you know you're reaching the right users? Maybe some will install your app and forget about it, while others will make it part of their daily lives. Firebase Analytics helps you do this. You can define events that happen in your app that you consider to be important, such as reaching the first level of your game, purchasing a fancy new pair of sunglasses, or returning every morning to check out new products. You can tell AdWords which of these events are most important to you. Then, AdWords will display ads to people who are more likely to complete these important actions in the future. You can also build audiences, which are specific segments of users, and have AdWords display your app to them. For example, imagine that you have a group of users who are very active, have added a product to their cart, but haven't purchased yet. Well, you can use Firebase to create an audience of just these people, and then use AdWords to give them specific ads and encourage them to come back to your app and take action. Understanding your users and engaging with them at just the right time and in the right way will help you build loyal users for your app. Firebase and AdWords, working together to help you grow your user base. Get started today. Your new users are waiting.
Every time your mobile app crashes, it's an invitation to your users to rate it poorly and uninstall it. This can spell disaster for the new app that you just launched. If you're an app developer, you need to know exactly where your app is having problems. And you need this information quickly so you can correct the issue before it affects too many of your users. This is where Firebase Crash Reporting can help. Our crash reporting tool collects information about crashes that your users are experiencing and sends that data as quickly as possible to be tracked in your dashboard. With the dashboard, you can monitor the overall health of your app. Here, you can see the top crashes and track the recent history of crashes in your app. Crashes are grouped by similarity and ordered by the severity of impact on your users, so you always know which issues to address first in order to best increase the quality of your app. Each instance of a crash comes with detailed information surrounding its circumstances, including the stack trace, device type, and other important details about the device at the moment of the crash. To further enhance these details, you can log additional information as the app is running. All recent log messages are captured for every crash to help your diagnosis. In the event that you're able to handle and recover from an error in your code, but want to report that event for analysis as well, there's an API to send these non-fatal errors for display in the dashboard. It's easy to get started with Firebase Crash Reporting. On Android, the SDK is enabled simply by integrating the Firebase Gradle plugin into your build with no additional lines of code required. And on iOS, there's a CocoaPod which requires a few lines of code for initialization when the app launches. To learn more and get started with Firebase crash reporting today, be sure to start with the documentation available right here. We can't help you write perfect code, but we can help you fight fires with Firebase.
We are in the era of progressive web apps. Browsers are more performant and capable than ever, and front-end JavaScript frameworks like Angular and Polymer have simplified development of rich app-like websites. You can now build an entire application purely with static files like HTML, CSS, and JavaScript. Firebase hosting is tailored for front-end web applications. Firebase Hosting is a developer-focused static web hosting provider that is fast, secure, and reliable. No matter where a user is, the content is delivered fast. Files deployed to Firebase Hosting are cached on SSDs at CDN Edge servers around the world. From San Francisco to Stockholm to Seoul, your users get a reliable, low-latency experience. And every site is served over a secure connection. Firebase Hosting automatically provisions and configures an SSL certificate for each site deployed, so you can get that green lock of confidence. Deploying your app from a local directory to the web only takes one command. So whether you're building a single-page web app, a mobile app landing page, or a progressive web app, Firebase Hosting has you covered. To get started with Firebase Hosting, check out our Quick Start to get you up and running in minutes. Happy deploying!
Analytics. We all know they're important to building a successful app, which is why there are many different kinds of analytics tools for app developers to use. There are in-app behavioral analytics, which measure who your users are, what they're doing, and so on. And then you've got attribution analytics, which you can use to measure the effectiveness of your advertising and other growth campaigns. Not to mention push notification analytics and crash reporting. But quite often, this work is being done by completely different analytics libraries, which means you've got reports living in various tools across the web, and trying to understand trends across these different reports, much less get them to talk to each other, isn't always easy. That's why we've created Firebase Analytics. Firebase Analytics is built from the ground up to provide all the data that mobile app developers need in one easy place. And it starts by giving you free and unlimited logging and reporting. That's right, no quotas, no sampling, and no paid tier to worry about. Simply by installing the Firebase SDK, Analytics automatically starts providing insight into your app. You receive demographic information on who your users are, how regularly they visit your app, how much time they've spent using it, and how much money they've spent in your app. But not all apps are alike, and you can get detailed information about what your users are up to by logging events specific to your app. These can include common events that Firebase Analytics has already defined, like when your users add an item to their cart. And there's also support for custom events you create yourself, like when a user completes a workout in your fitness app, or when they take a selfie in your photo app. Geez. But it's not just about seeing what your users are doing. It's also about discovering who your users are. So in addition to demographic information, you can also discover how your different groups of users behave by setting custom user properties. Have a music app and want to find out whether your classical music fans are browsing more albums than your jazz fusion fans? That's the kind of data you can easily break out thanks to custom user properties. And Firebase Analytics doesn't just measure what's happening inside your app, it lets you combine your behavioral reporting, what your users are doing, with attribution reporting, or what growth campaigns are bringing people to your app in the first place. So if you want to know which ad campaigns are bringing you the users who spend the most money, or are sharing the app with their friends, or have unlocked the last level in your game and are ready for the sequel, you can do all of that in Firebase Analytics. But don't stop there. Once you have all this information, you can take action on it using Firebase Analytics Audiences. Firebase Analytics gives you the power to build up groups of users, or audiences, out of just about anything you can measure in your app. Want to target users in Brazil who have visited the sports section of your in-app store? It's as easy as a few clicks in the Firebase console. Once your app has built up this audience, you can send them notifications using Firebase Notifications, or you can modify their in-app experience using Firebase Remote Config, or you can target them through AdWords, Google's ad platform. And then, because that impact can be measured using Firebase Analytics, you can confirm you're getting the outcomes you expect. Firebase Analytics already comes with a dashboard that lets you view answers for common questions, But if you need more specialized analysis, you can export all of your data into BigQuery, Google's data warehouse in the cloud, where you can run super fast SQL queries to slice and dice this data however you'd like. You can even combine it with other analytics data that you might be capturing. And this is just the tip of the iceberg of what Firebase Analytics can do for you. To find out more, check out our documentation here and give Firebase Analytics a try.
Launching a great app requires dedication and vision, but growing one takes revenue. How about a monetization solution tailored specifically to your app? One that has rich and engaging ads, one that works with Firebase to give you the insights you need to grow, and one that uses mediation to connect you with networks all over the world. Well, that solution is AdMob. Trusted by more than 1 million apps, AdMob offers developers everything they need to implement first-class monetization strategies. And when paired with Firebase, it's even better. AdMob is included with the Firebase SDK, and its APIs are built to make adding banners, interstitials, and video ads to your app simple. Plus, AdMob automatically selects the ads that pay you the most, so you can sit back and watch your revenue grow. And as your business grows, you can benefit from AdMob's advanced features. Say version 2 of your app has a slick new design, and now you need an ad format that fits naturally with your content. With AdMob's native ads, you can create CSS templates designed specifically for your user experience. We'll style the ads to match and display the result in a native ad view that fits your app like they were made for each other. And it doesn't stop there. AdMob helps you earn in-app purchase revenue too. AdMob can determine which of your users is most likely to make a purchase and target those people. They'll see an ad you design, and they can make purchases right there. Now, with your app's slick design and in-app products, it's become a worldwide sensation. But how can you make sure you're maximizing the revenue generated by each user? With AdMob, you can connect to ad networks around the world, bringing even more advertisers who'll compete for your impressions. And because you're using Firebase, you get access to free and unlimited analytics. Imagine a big-time blogger in Tokyo posts about your app, and overnight, your Japanese audience quadruples. With Firebase Analytics, you can easily spot the trend and then switch to your AdMob settings to tweak mediation configurations or start a campaign targeting your new fans. That's AdMob with Firebase. It's as easy as you want and as powerful as you need.
The Firebase Notifications console lets you re-engage your users quickly and easily. With it, you can manage and send notifications to your users easily with no additional coding required. Messages can be addressed to single devices, Firebase Cloud Messaging topics, or devices that you select using powerful analytics tools. So, for example, you could send a message to all of your users who have made an in-app purchase, giving them a special offer, allowing you to re-engage with them. The Firebase Notifications console integrates with analytics so you can measure the effectiveness of your messages and explore insights based on your users' activities, so you can grow your application by easily engaging your users through the Firebase Notifications console.
We all know from experience that people love to share things about themselves, such as photos, videos, and GIFs that express their feelings. So what do you do to let them store and share these files through your app? That's where Firebase Storage can help. Our storage API lets you upload your users' files to our cloud so they can be shared with anyone else. And if you have specific rules for sharing files with certain users, you can protect this content for users logged in with Firebase authentication. Security, of course, is our first concern. All transfers are performed over a secure connection. Also, all transfers with our API are robust and will automatically resume in case the connection is broken. This is essential for transferring large files over slow or unreliable mobile connections. And finally, our storage, backed by Google Cloud Storage, scales to petabytes, That's billions of photos to meet your app's needs, so you will never be out of space when you need it. So give your users space to share their lives with Firebase Storage, available right now for iOS, Android, and web applications. And to learn more about Firebase Storage, check out the documentation available right here.
Hello, everyone, and welcome to the 2017 TensorFlow Developer Summit. And I'm delighted to see all of you here today.
Today, we are excited to announce TensorFlow 1.0. TensorFlow's philosophy has always been to give you the power to do whatever you want, but also make it easy, and this makes it even easier.
We really were hoping to build a machine learning platform for everyone in the world that was fast, flexible, and production ready.
The point of TensorFlow is to figure out how can we give this back to the community and be able to use TensorFlow to further whether it's the research or the production needs.
It's how we express our ideas, and it's the piece of software our engineers and scientists spend most of their time interacting with.
So TensorBoard is a really exciting tool. It's something that will let you take the confusing world of TensorFlow and start to dive into it.
It's just a really amazing time to be an AI researcher.
One of the projects that we've been working on is using deep learning for retinal imaging.
Can we use deep learning and reinforcement learning to generate compelling media?
But this is just the beginning. The TensorFlow community is truly global.
We want to see all the amazing things that you guys can do with TensorFlow. Thank you very much.
Good morning, Berlin.
It is an absolute pleasure to be here with you. Here we go. We're live. We have a lot of experience building some of the world's most popular applications, and we've learned a thing or two about what it takes to build an app. And we found that it's a pretty difficult process.
A lot of your time goes into running infrastructure instead of building the features that make your app your app. There has to be a better way. That better way is using Firebase.
We're now up to over 750,000 developers using the product.
If you use Firebase, your app's code talks directly to our powerful managed backend services. We take care of security and of scalability so that you can focus on building the features that your users love.
Today we're launching Firebase UI 1.0. It's an open source library. It has customized theming and it works for web and Android and iOS. So you can go ahead and drop that in and you'll have all of the UIs that you'll need.
Is my app set up correctly? Which events are being captured by the SDK? Are you receiving my events and parameters? We've built something, the ideal tool to answer all of these questions and these pain points.
App quality leads to better user retention. Better your app is, and the more stable it is, the more likely for users to come back and for your business to be successful and sustainable. And that's where we come in.
So we're really looking forward to get the feedback from the community, as always, to help us continue to refine our product and to work together to help you build a better app.
And we want you to be able to spend all of your energy on bringing innovation and creativity, something new to the world. That's really what we're trying to achieve here, is making all the infrastructure pieces simple for you. And I'm really excited for you to engage with Firebase and see how it can make you more successful.
All right, let's get back to the code.
We're now in the experiments tent, and there are so many cool things to play with. Before we get to that, which is going to be in just a moment, I just want to ask Amit what experiments are all about.
Thanks. So experiments are platforms that we bring out, websites. Each one is a kind of a playground that invites everybody to come in and send in interesting, playful things that they're doing with our technologies. We have Chrome experiments, Android experiments, web VR experiments, and AI experiments. They're all there, and new platforms will come out. And we're very excited about the things that people are doing with them.
And a lot of them are open source, right?
Yes, a lot of them are open source, which is amazing because I mean, experimentation is a wonderful way for people to play and discover new things for themselves. But when they share with the community, then everybody gets to see what's possible with AI, what's possible with web VR, and it's really amazing. And it's also amazing for us at Google to see the surprising things that sometimes happen when people just have fun and play with these technologies.
And a lot of them are built by people who aren't Googlers.
Oh yeah, absolutely. I mean, there's a submit button on there, and you can just go and send us the stuff that you're doing in the garage, the kind of passion project that you have, and you'll be surprised how helpful some of these projects could be for everybody else, especially we can get inspired and imagine new things with these technologies.
All right, let's check some of them out. First off is Quick Draw, and I'm actually going to play. Do you want to like narrate for everybody at home what we're doing?
Yeah, absolutely. So Quick Draw. Oh, thanks. So you might have actually played this game at home, but this is the multiplayer version of the game. What's happening here? It's a machine learning game. So you're going to draw something, and you're going to draw something, and the machine is going to try to guess what it is that you're drawing. And if the machine can guess right, you get a point. All right, so here we go. We got Timothy, Adam, and Nick. 3, 2, 1, go. So the machine is going to tell them something to draw. In this case, for example, Timothy is asked to draw water. And you can see over there that he's trying to draw water. And if the machine can guess, if the computer vision algorithm can guess that it's actually the handwriting API. If it can guess that he got water right, then he gets a point. So I think Nick is killing it over there. He's drawing a train, yeah. Well, Adam seems to be in first place with 14. After we got Nick Jonas with 12, and Tim up. There we go. We're done. Time's up. All right. Third place, Timothy, but it's okay. All right.
That was the water that got me. How do you draw water? I just drew the surface.
That's the funny thing. Some things are perceived differently, right? Like people think water drops versus river water shapes, and it's different every time. Yeah.
Awesome. Thanks, guys. All right, let's go check out something else. There's something that makes music over there, right?
Yes. Okay, so this is a really exciting one. The artist Giorgio Moroder, who used to be he is the king of Europop, created this amazing soundtrack. And what we've done is we're using the computer vision API to go and have the phone identify different items, and then the phone is actually narrating itself as a soundtrack to the music, telling us about what it's seeing, what it thinks it's seeing, and how it's identifying these objects. And that actually becomes part of the song. So it's kind of...
That's really cool.
I think it's better to just listen to it, right?
All right,
yeah.
Let's go check it out. You guys ready?
Perfect.
All right, which one should we do first?
We should do the guitar.
Recognition with me. Take a picture and it'll tell you what I see. Here we go. I'm on it. All right. Is that guitar or not? No. Got musical instrument in this spot. Okay, what else? Yeah, I'm on it. Looks like automotive exterior to me. I'm seeing vehicle.
This is really great. Okay.
Turn it on. All right. I'm on it. I think ceiling is what we've got.
It's a banana, silly.
Maybe not.
All right, I'll leave this with you guys. Thank you. That was really cool. All right, let's try a couple more things. That was super fun. So this is satellite imagery.
Yes, this is satellite imagery. It was created by an artist, Zach Lieberman, and the DAT team. So the idea here was really simple. What if you could search the world using a simple gesture? Right, and notice here how it takes you to different places all over the world every time you draw a gesture. So let's just give it a shot. Let's see where we go. Spain. Yeah. So it's an experiment. It's an experiment. It's just a really wonderful experience, right? It's not like you'll be able to find your way to a specific place by drawing a gesture. That's not the point. The point is really this is optimized for a really joyful and fun experience. you want to try the other mode as well? Yeah. So what it's going to do here is build this like imaginary city built around these tiles. As you start dragging in a certain direction, it'll start building a road by combining all these tiles. There's about 50,000 of them that the team has processed using various algorithms to go and create this experience. And this is a Chrome experiment. You can check it out at chromeexperiment.withgoogle.com. Oh, no, sorry, chromeexperiments.com.
That's really cool. It's really joyful and rather pleasant.
It is, yeah, it's very meditative. I mean, we've been standing here and seeing people play with it, and we find ourselves just like starting to yeah, it's mesmerizing.
Kind of zone out on the satellite image.
Oh, absolutely.
I mean, the world's a big place.
It's a big place. It gets a little smaller when you get to travel it this way. Yeah.
All right, I think we have time for one more thing. What should we check out?
Yeah, let's go check out actually a submission by a student, former student. He's graduated now from Denmark, and he's created a wonderful piece using machine learning. Very unexpected, interesting piece.
So this is Objectifier with spatial programming, and it's a really cool machine learning device that takes visual input, processes it through TensorFlow, and ultimately triggers if this then that statements. So you could imagine putting your favorite reading glasses on would trigger a reading lamp, pulling the sheets up at night, getting into bed will turn all your lights off. It can happen on device. It was built by a developer, Bjorn, out of Denmark, and if we had the proper European adapter, we could do it all right within this physical hardware. There's a Raspberry Pi Zero in there, and then it can ultimately connect to anything you can plug in for the trigger. There you are.
All right, well, I was playing with this earlier. It was very cool. I was able to hit the button and do a gesture, and then using that gesture, we could turn it off or on. That was awesome. So you wanted to say one last thing about QuickDraw.
One last thing, we're very, very excited today to announce that we're releasing, open sourcing 50 million images. These are vector drawings where the actual ordered strokes of images that people have drawn in QuickDraw. It's available now for developers to go and train their own models on, which is very exciting. Researchers can go and look at it and find some interesting patterns, and artists can go and do interesting and weird things and submit them back to us as experiments. So we're very, very happy to share all of this data with the world. Yeah.
That's awesome. Thank you so much. And thank you for showing us around the Experiments tent.
Oh, absolutely. Thank you, Timothy.
All right, Amit. So that was Experiments. Now, if you want to see this video again, or you want to see any of the other videos or recording at the sandbox areas here at Google I/O 2017, head on over to g.co/io/guide. I'm Timothy Jordan, and I'll see you at the next one.
Good afternoon. Thank you for coming. I'm Justin Oasad. I'm a software engineer on the Chrome team. And this afternoon, I'll be talking to you about ways of cranking the performance in your graphics-intensive web apps and games. For those of you who haven't read the abstract, just to make sure we're clear, this talk is going to be mostly about Canvas and a few other things. Here's what we're going to be covering today. We're going to look at ways to get smoother image loading. This is because image loading is often a source of jank in web apps. And also, we'll look at the problems that we face when we're aiming for 60 frames per second and how to solve these. And also, we'll look at moving web apps closer to the performance that we get with native apps. And we'll also be looking at ways for memory-efficient and CPU-efficient background rendering. And finally, we'll look into streamlining some important use cases with WebGL, in particular, multi-view rendering and WebVR. The first topic, synchronous image decodes. So the current practice when we load an image asset into an app is to start using it as soon as we get the signal that the image resources is loaded. So this is what we do with the onload handler, right? So onload guarantees that trying to use the image is going to work if we use it immediately, but it does not guarantee that it's going to be fast. So the first time that we use an image resource, usually there's a delay due to the decode overhead, and that can cause apps to be janky, especially if we start loading images in the middle of an animation. And examples of use cases are the first draw of an image to a 2D canvas using the draw image method, and also a texture upload to a WebGL context using the TextImage2D call. So the solution to this is to decode the images in the background. So image decode is not something that web developers are used to controlling because we kind of just leave that up to the browser and it just happens. But you can take control of this using a new API that's called image bitmap. So this was released earlier this year. It's available in Chrome already, and it's also available in Firefox. Here's how the spec defines what an image bitmap is. There's a few words in there that are a little interesting towards the end of that sentence. Undue latency. What exactly does that mean? It's kind of subject to interpretation. But what is clear is that this is a performance primitive. And what we do know is that image decode is a source of latency that we want to get rid of. So in Chrome, we interpret this as we want to get rid of decode latency. So here's how it works. The use case we're looking at here is we have a web app that runs an animation, and while we're in the middle of the animation, we have a new image that we want to load from the network and start using it. So we can do that fetch asynchronously using the fetch API or using XML HTTP request. And while that fetch is pending, the animation loop can keep running. And then once we get a blob back, we can call createImageBitmap, this new API. And that will initiate the image decode. And the decode is going to happen on a separate thread inside the browser, so your animation loop can keep running while that's happening. And finally, when we get the image back, you can use it in your WebGL context or in your 2D context. And when you're done using an image bitmap, like once you've uploaded it to a WebGL texture, it's a good idea to call close. This is not mandatory, but if you close the object, it's going to free the resources that are behind it immediately instead of waiting for garbage collection. So this can help keep down the memory footprint of your app. It can also help reduce the frequency of garbage collection. Because if you have all these dangling large objects, they're going to have to be collected more frequently. But once you clean up an image bitmap object, it has a tiny footprint, and you can collect these over many frames. So here's the old way of doing things. This should look pretty familiar, just using the image interface and loading it, and once it's loaded, we use it. The new way is not a lot more complicated. It's just maybe an additional line of code. In this example, we're using the fetch API, but you could also use XHR. And there's nothing new about how we fetch the blob here. Just once we have it, we call createImageBitmap, and that function returns a promise. And the promise resolves once the image is completely decoded. So here's some videos that, I'll just let you watch them to kind of speak for themselves. So the left one, there's a bit of a pause when the image changes. And that's the decode that's causing that jank. And the right one is smoother. These were captured on a Nexus 5X device. So this is a phone from last year. And we were using 1 megapixel images. They're not that large, just 1K by 1K. Now let's look at the DevTools timeline and see what was going on. So in the first case, where we're using an image element, there's this long image decode. And on the top row of this graph, we see frame times. What's interesting is there's one frame that took 233 milliseconds to render. That's terrible. That's definitely noticeable by the user. So what's causing this is the synchronous decode inside the call to text image 2D. So that's what this flame chart is showing. The image decode is nested inside. And this is what happens the first time you use the image resource. If we were using a 2D context with a draw image call, the chart would look essentially the same. It would just be draw image instead of text image 2D, and we have the same problem. But the second time we use the same image resource, then the texture upload would be a lot faster. But in WebGL, you don't really acquire an image and then upload it multiple times. You really just need to do this once. So we're not really taking advantage of the decode cache. And also, images are not decoded in advance for a really good reason. Because people often ask this, like, how come when I load an image, clearly I'm expressing intent that I want to use this image. So why doesn't the browser just go ahead and decode it right away so that's ready for when I need to use it? But if the browser were always doing this with all images, it would run out of memory, because a lot of web pages have tons of image resources, and we can only really afford to decode them as they're used. So that's why we're stuck with this problem. Now, this is what happens when we use the createImageBitmap API. On the top row of the main thread, you see there's a bunch of small little blue lines. That's the overhead for fetching the blob from the blob store. And the big green rectangle at the bottom, that's the image decode. And the image decode is happening on another thread that's called worker pool. And what's the important part here is that while this decode is happening, the main thread continues. We can see all those little animation frame ticks. So it keeps doing its work while this long task is happening on the worker pool. And now this little blue arrow you see right there, that's pointing at the text image 2D call. So this thing that was the big source of jank before is now reduced to about 3 milliseconds. So it's no longer a big issue. Now, another use case where we experience jank from image decodes is image injection, when you have a page that's just adding images to its existing content by injecting them. Well, it's not really a good idea to start using image bitmap for that. And examples of kinds of pages where this would be an issue are really long scrolling web pages with lots of images, like a news website or a social media feed. If we started using image bitmap for all the image resources, we could run out of RAM, because there's just, there could be too much content in there, especially if we're decoding them on a mobile device. So there's another solution for that use case. This is currently under development, so it's not yet in the browser, but it's going to expect to see it soon as an experimental feature in Chrome. So this is a new function on the HTML image element interface. We're adding a decode function. When you call this, what happens is it triggers a decode that can also happen on a separate thread. And when it's done, there's a promise that gets resolved. And that tells you now's a good time to use the image to, for example, append it to the document. And that won't cause jank. So the reason we want to use this instead of image bitmap is that this API does not pin the image resource in RAM. The image, the decoded version of the image is evictable. So it's a lot friendlier for situations we're under memory pressure. So expect to see that soon behind a flag in Chrome. So next topic, animation smoothness. So UI performance is always a concern in all types of applications. For graphics-intensive apps and for games, it's a constant battle. We add features, we make things prettier, and our rendering time increases, the app gets slower, we lose our beautiful 60 frames per second, so we have to reel it back in. On mobile, it's even harder. We're dealing with slower CPUs and GPUs, less RAM, and also the touch interfaces. They make lag more perceptible to the user. So this is what it looks like when we're trying to drive animation using the DOM. So we have our 16.7 millisecond budget. This is if you're targeting 60 frames per second. And there's the blue rectangle there, the JavaScript slice. That's the time your app has to do its work, whatever it needs to do at each animation frame. And we also have to keep a big chunk of time at the end where we're not planning to do anything. This is just idle padding. And we need this because there's a lot of stuff that your app cannot plan for that the browser just does. For example, a garbage collection could just happen at any time. Or there could be thread scheduling issues if you're on a CPU that doesn't have a lot of cores and there's a lot of work to do. The main thread could get descheduled, and all of a sudden you have one frame where everything takes a bit longer to execute. And also, you could have event handlers, event listeners, I mean, and you can have a burst of events that happens all of a sudden, and you have to deal with it. And this is tricky, so you need to have some padding if you really want to be able to keep that 60 frames per second rate. Then there's the browser overhead. There's style and layout. This is just the cost you have to pay whenever you're touching the DOM directly in JavaScript. And then there's the painting and compositing overhead. This is the cost of just re-rendering the content of the web page. And there's no way around this. On mobile, the fixed costs that are imposed by the browser, they get stretched, right? Because you're on a slower device. So that squeezes even more your JavaScript time slot, and that makes your frame deadline even harder to respect. Now, when we're animating with Canvas, that orange rectangle that we had for style and layout, that one just goes away because we're not touching the DOM. So things get a little bit better. This timeline, it's also valid for use cases where we're using CSS animations, well, certain types of CSS animations, like if you're animating opacity or simple 2D transforms, the style and layout calculations don't need to be recomputed at each frame. Then there's the painting and compositing step. It's usually a little bit later when we're using a canvas because the browser has less work to do. So in general, when we're doing sprite-based animations, we don't really need all that extra support that the DOM and CSS give us, and you can get a significant performance boost by using Canvas. And this is what a lot of 2D game developers have been doing recently, since HTML5 Canvas appeared several years ago. Now, this is what your timeline looks like when you're making a native app. First of all, you have more predictability, therefore there's much little idle time is required because you won't get any surprise garbage collections. The threads are under the control of the developers, so you have control over how many threads you have and what's the workload that they have, so you don't have to worry so much about scheduling if you're doing things right. And also, your events, like your input events, they can be coalesced, so the time that they consume is more predictable. So that's nice. Now, how do we get the mobile app experience closer to what we have on native? Well, the first thing we want to do is get rid of some of that overhead. Now, the painting and compositing overhead is necessary with Canvas animations because we have to go through the same presentation process as the DOM does because we're keeping all of our content synchronized. But many apps that use Canvas, they're not touching the DOM. So what if we just broke that synchronization constraint in order to get rid of that step? Well, there's a new API for that, and it's called Off-Screen Canvas. So Off-Screen Canvas is kind of like a Canvas element, except that it's not a DOM element. It's just a native interface. Now, it has no style, no layout. It's not directly paintable. It's not composable. So this means it can't be a part of a document. By now, you're probably wondering, so if it's not paintable, how do I do anything useful with it? The whole point is I'm animating something that I want to show on screen. So how do we display it? Well, we use a placeholder. A placeholder is a regular Canvas element that lives inside the web page, and the off-screen canvas is connected to it. So we can inject the content that we rendered in the off-screen canvas into this placeholder location on screen that's reserved by the canvas element. And the process of the commit process is very lightweight. It bypasses the DOM update mechanisms. And the presentation actually, in Chrome's implementation, the presentation all happens in the browser process. So it doesn't consume any time on the main thread, which is where we're trying to save time for your application. This is what it would look like to use off-screen canvas in JavaScript. So the first thing, we're not constructing the off-screen canvas directly. We're calling transfer control to off-screen canvas. This is a method on Canvas elements that creates that placeholder connection. You get a new off-screen canvas that's connected to the placeholder canvas. Then we create a rendering context the same way you would on an HTML canvas. And then the animation loop, well, things look a little bit different there. There's this commit method that we call, and this is what pushes the content update to the placeholder. And you'll notice that there's no request animation frame. That's because request animation frame is tied to the DOM graphics update mechanism, and we're trying to bypass that. So we're using something else. Commit returns a promise, and the promise will resolve when it's time to render the next frame. So that's how this works. So this is commit, and it also plays the role of request animation frame at the same time. So let's see how using this impacts our CPU usage on the main thread. This graph shows two devices, a powerful workstation and a typical phone. So the orange bars, they represent the time it takes to present a 300 by 300 pixel canvas to the screen. And what we see here is that in both cases, the time it takes when we're using an off-screen canvas is faster by about an order of magnitude, regardless of the device we're using. So on mobile, we were taking 2.7 milliseconds out of our 16 millisecond budget just for pushing pixels to the screen. And that overhead is not necessary in most cases. So this kind of seems like, OK, this is obvious. We should just always use off-screen canvas. But it's not that simple. This is not a free win because we lose synchronization with the DOM. And some apps really need that. But if you're doing a game that runs in a full-screen canvas, for example, you most likely don't care about that. So you can just go use this and get a perf win for free. Now, what happens if your main thread is busy? For example, there's a lot of event traffic happening on the main thread. And certain events have to happen on the main thread because that's where the interfaces are. Well, off-screen canvas can be used in a worker. This way, we give the animation loop its own CPU core, and it can just run without being disturbed. And this way, we're reducing the idle time that we need. So that's another step we can take that brings us closer to native performance. So we're just giving the canvas, well, our rendering loop, actually, we're giving it an isolated execution environment. We get more predictable run times for each animation iteration, therefore less idle padding. Here's how it works. The first part of creating the off-screen canvas, that's the same as before. We just call transfer control off-screen. And at the bottom of this page, the animation loop, that's also the same as before, except that it's running in a worker. The difference is what happens in between. After we create the off-screen canvas, we need to send it over to a worker. So we use post message for that. And you'll notice the way post message is called here, we're using the second argument. That's the transferable list. And that's really important because the off-screen canvas object is not clonable, but it is transferable. And when you transfer it, it preserves that connection with the placeholder. So even though we've moved the object into a new realm, if we commit from the worker, the content still ends up in the placeholder canvas. Now, here's a simple example that, oh, there's something wrong with the video. Let's retry that slide. OK. What we're supposed to see here is, I'm going to picture it. So everyone close your eyes. Try to imagine this. On the left, there's a canvas with an animation that runs really poorly, and it's happening on the main thread. And on the right, there's another animation. Oh, here we go. Thanks. All right. So the animation on the right is going nice and smooth, and the one on the left is janky. So the one on the left is being rendered on the main thread, and the reason it's so choppy is because we deliberately inserted long tasks on the main thread, and those long tasks are preventing request animation frame from reaching its target frame rate. So the point that this makes is, even though request animation frame isn't running at full speed on the main thread, the worker can still pump out frames at 60 frames per second with no issue. And that's the whole point of isolating it. So that's what that showed. Can we switch back to the slides now? Thank you. All right. So by now, you're probably thinking, oh, this seems nice, but there's one little problem here. I'm already using a framework, and it just uses canvas. It doesn't use off-screen canvas. Well, maybe, but is that really a problem? There's something really interesting is that the web platform is highly hackable, right? People do polyfills. Well, with off-screen canvas, often we can just drop it into frameworks that usually use an HTML canvas element and hope for the best. And maybe things just work, or maybe you have to do a little bit of bootstrapping to get things working. Kind of like a reverse polyfill mechanism, if that makes sense. So I'm going to walk you through an example of this using the 3JS library. So 3JS is just, for those of you who don't know it, it's just a really popular framework for doing 3D rendering on the web. And 3JS is meant to work with canvas elements. What we're going to see is not only can it easily be set up to work with an off-screen canvas, but we can also use it in a worker without too much work. And quick little disclaimer, the steps I'm going to show in the following slides, they're not a complete, full-featured solution. They're just some ideas to get the ball rolling if any of you would like to try this. So first step, getting it to work with an off-screen canvas. Usually, 3JS renderers, the way most people use them is that we let the renderer create its own canvas. Well, we can override that behavior because the renderer constructor can take a creation parameter called canvas. And we use that creation parameter to specify our own canvas. Just say, OK, no, don't create your own. I have one. Go and use this. But this parameter expects to receive an HTML canvas element. But if we send it an off-screen canvas instead, will it just work? Well, it almost just works. There's one little thing we need to do. Off-screen canvas doesn't have style, right? Because it's not a DOM element. Why would it have style? And sometimes there's a bit of code in 3JS that tries to write the width and height styles. So here, I just created stubs. But you could do something a little more clever. You could create a getter and a setter that forward the style to the placeholder canvas. That might be what that might make sense for your application. Maybe, maybe not. But anyways, the stub is enough to just get started and show stuff on the screen. The other problem is how do we get 3JS to work in a worker? 3JS has dependencies on some DOM interfaces. The most important one is HTML image element. But we can work around that. And we're going to work around it by using the same texture loading mechanism that we saw in the first part of the talk, where we use create image bitmap. So that's what this diagram at the bottom of the slide shows, using XHR or fetch to get a blob. And then the blob, use create image bitmap, get an image bitmap, then upload that to a texture. Here's one way of doing it. This is a really simple, quick and dirty way of doing it. Of course, we could just tweak the 3JS library to make it do things the way we want. But here, I'm not touching the 3JS distro. And there's a good reason for doing it this way. If you don't hack it, then you can keep getting 3JS from your favorite CDN. So here, what we're doing is we're hacking the prototype by redefining what image loader load does. And it turns out that 3JS already provides a file loader interface. And file loader can be used in workers because it uses XML HTTP request under the hood. So we can just wrap that. But that's not enough. We also need to produce an image. So here we use create image bitmap. And once we get our image bitmap object back, we send that to the onload handler. And the onload expects to receive an HTML image element, but we're tricking it. We're giving it an image bitmap instead. And of course, this happens to just work because if we're using the image for a texture upload, well, the OpenGL text image 2D call doesn't care if what you're giving it is an HTML image element or an image bitmap. So it can just make this substitution, and it works. Now, if you're making a game engine, you're probably thinking, well, to get everything working in a worker, I also need input events. And there are no input events in workers. So how do I get those mouse clicks and keyboard actions going? Well, the solution is to forward events. But this is not a great solution. It has a serious downside because if you just have your event listeners on the main thread, when they receive input events, they post message them to the worker where they can be used. Well, if your main thread is busy, you'll be introducing input latency. So this is still not ideal. It's an unsolved problem, but we're determined to make this better in the future. This is like a future next step for this, this class of solution. Now, let's look into some other uses of off-screen canvas. Background rendering. This is an interesting one. People are already doing background rendering today. This is, for example, situations where you have a game where it needs to do some asset preparation on the client side. For example, maybe you're rendering text labels that you're going to be using as textures. If you're doing a lot of this work, you're probably doing it with today's technology using an HTML canvas element that is not attached to the DOM. That way, it's all hidden. It doesn't appear on screen. You're just doing your stuff. But we can do a little bit better. We could move that work over to a worker. That way, you can batch all of your background rendering. You don't need to worry about dividing it into small chunks so that your UI can remain interactive or anything like that. And this is how you do it. So in your worker, you create an off-screen canvas, but this time we're creating it directly using the constructor without a placeholder. And when we're done doing our background rendering, we want to capture the results to send them back to the main thread. So that capture can be done using this method called transfer to image bitmap. This, as the name implies, this is a transfer. That means we're not making a copy. We're just tearing off the pixel buffer that the canvas rendered to. And because we're just tearing it off, this is basically just copying a pointer. Well, what this means is it's going to be faster because there's no copy. And it's going to be leaner in memory because we don't have duplicate copies of the same image in RAM. And that's really going to help with memory bloat. And for sending the rendered results back to the main thread, or maybe we're sending it back to another worker if that's where your rendering loop is, well, we're using transfer semantics there too. And this is important. It's important to note that image bitmap is transferable, but it's also clonable. So if you don't specify that that second argument there to post message, it's still going to work, but it's going to be slower. So remember to do this if you don't mind what the transfer implies, that you can no longer use that image object in the current context. And you'll get some good performance gains. So just so you all know, we've been getting feedback from app developers telling us that it's really hard to write applications that do image manipulation and that work on mobile. The second you try to use a high-resolution image, like, for example, a picture from a DSLR camera, it's really easy to start running out of memory. And this is due to all the multiple copies of the same image data that we end up with in memory just because of how the current APIs are designed. So we're really trying to move towards zero-copy interfaces. And that's what these transfer semantics are about. This should really help with imaging apps. And going forward, we're going to continue to provide new zero-copy APIs. Another use case for off-screen canvas, multi-view rendering with WebGL. So imagine a CAD software or a 3D modeling software or animation or something like that, where you have multiple views of the object, like what we see here on screen. Well, when we're rendering multiple WebGL views that use the same resources, so the same vertex buffers, the same textures, the same shaders, it's useful to share resources between these views. Now, WebGL does not allow resource sharing between different canvases. It's just designed that way. So the solution that most people are using is to have a single canvas that's in the background that we're going to use for rendering all the views. And when a view is ready, we just copy it to the presentation canvas. So this can already be done today using an HTML canvas element that's in the background, that's not attached to the DOM. But we can make it a lot more efficient by using transfer semantics. This is how it works. So the background canvas, we can use transfer to image bitmap. So That's a zero-copy operation. And to present it, we can use this new type of rendering context that's called bitmap renderer. The bitmap renderer context is a very simple canvas rendering context that has only one method in its API, and it's transfer from image bitmap. So that, again, is a zero-copy method. Because the alternative would be to just use a draw image to a 2D canvas, and then you're paying the cost of compositing, and you have an extra buffer in memory. And this is yet another use for off-screen canvas is WebVR. This is still a work in progress. We're not sure exactly what this API is going to look like in the end. But it's being discussed right now, and what we do know is we do want to get WebVR to run in a worker because we're looking for that advantage of having the, an execution context that's isolated from the rest of the browser, so we can hit that 90 frames per second or 75 frames per second on desktop, and also just in general. We want to be able to squeeze more content to get those rich user experiences, and the worker can help with that. So finally, if you want to try off-screen canvas, well, we recommend trying it in Chrome 60. It is there in earlier versions of Chrome, but it's not quite ready for consumption. In Chrome 60, it's starting to look pretty good. So you can get it for Android on the Play Store. Just search for Chrome Canary. You can also find it on the web to download it onto your favorite desktop platform. And you can install this alongside an existing Chrome installation. So it's perfect if you just want to test it in a sandbox. And once you have Chrome 60, well, you have to turn on the experiment. So you navigate to Chrome flags. And then you find this item called Experimental Canvas Feature. Click Enable, and restart the browser, and you're good to go. Now, if you're interested in following the developments with off-screen canvas, here's a link to the bug. Just follow that link, and there's a little star in the corner. You click that star, and you'll get email updates, so you'll know, what's going on, if it's ready to ship. What are the outstanding bugs, that sort of thing. And if you do try it out, please provide feedback. If you find issues with it, submit bugs on crbug.com. You go there. And not just about off-screen canvas, by the way. Please, web developers, help us help you. Go submit bugs. Help make Chrome better. And this is the last slide. Let's just summarize what we've learned today. So please, I see a few people with their cameras there. This is the one slide you want to take home with you. We learned that you can get smooth asynchronous decodes with image bitmap, reduce your rendering overhead using off-screen canvas, isolate your rendering in a worker to improve your smoothness, improve your throughput, and reduce your memory bloat by using transfer semantics. And we saw examples of use cases where transfer semantics come in handy, like background rendering and multi-view WebGL. So that's it. Thank you for listening, and I'm looking forward to seeing what you're all going to make with these APIs.
The only thing that evolves faster than technology is our expectations. We want everything. Better, easier, now. Suddenly, downloading an app feels like it takes forever. And in many parts of the world, data is still at a premium, with 1 megabyte costing up to 5% of a monthly wage. Let's face it though, until now, the alternative to native apps hasn't been great. But that was then. Progressive web apps can now deliver mobile web experiences with a native look and feel, offering features like real-time push notifications, adding a site to your home screen so you can easily jump back to it with a single tap, even when you're offline. Plus the ability to make quick payments on the go. And all from your browser. This is the next generation of the mobile web. So what are we waiting for? Let's go and build something great.
Android Wear 2.0 is the most significant update to Android Wear since its launch in 2014. I'm Hoi Lam, and I'm here to take you through 3 highlights of Android Wear 2.0. First, material design has arrived on Android Wear. The new Android Wear interface uses a darker color palette, which makes the watch blend in more in social environments. It also helps save battery by OLED displays. We also suggest that developer adopts vertical layouts and reserve horizontal swipe for activity dismissal. In our research, this makes user interface easier to understand. To help developer implement these new design patterns, we have introduced new user interface components such as the wearable drawer layout and wearable recycler view. Check out the material design for Android Wear site for more details. The second highlight for Android Wear 2.0 is watch face complications. Before Android Wear 2.0, if a watch face wanted to display data from another app, they need a one-to-one agreement in both business and technical terms. To alleviate this complexity, with Android Wear 2.0, we have introduced the Complications API. Complications are a traditional watchmaking term for areas of the watch face that displays information other than the time, such as the date or phases of the moon. We have extended this concept to smartwatches, so any app can publish data for watch faces to consume. And watch faces can display these data in a style that fits into their unique designs. For app developers, this helps increase user engagement and mindshare. For watch face makers, this adds utility to the watch face. Users can now choose whichever watch face they want, as well as getting the data that they need. Check out the watch face and complications sections of the developer documentation for more details. Last but not least, standalone functionality. Previously, Android Wear 1.0 apps require a phone app to communicate with the cloud. With Android Wear 2.0, Wear apps can access the internet directly without the need for a corresponding Android phone app installed. This means the Android Wear app can access the internet even if the user has an iPhone. To help with app distribution, we have also put the Google Play Store on the watch. Users can now download apps directly on their wrist. Apart from these 3 areas of improvement, material design, complications, and standalone apps, there are numerous other enhancements with Android Wear 2.0. Check out the Android Wear developer site for more details. I'm Hoi Lam. Happy coding!
Hi everyone, and welcome back to Ask Firebase. I'm James Tamplin, a co-founder and product manager on Firebase. A fun fact about me is I first started programming at the age of 12 using a TI-83 basic in math class. Needless to say, my math teacher wasn't pleased.
Nice.
Our first question comes from Mr. Pan4. How did you meet Firebase co-founder Andrew Lee? So Andrew and I actually went to high school together. We've known each other now for about 17 years. After we both finished university, Andrew gave me a ring and we had dinner at a small Midwestern diner. And 9 years later, we're still working on making lives easier for developers with Firebase. This next question comes from Harold Weisinger. And Harold asks, is there a way to run my cloud functions once every hour? Great question, Harold. Unfortunately, currently there isn't. However, it's our #1 most requested feature for cloud functions, which we launched last month. Stay tuned for more news on our Twitter, Facebook, and YouTube channels. Thanks for the question, Harold. Next question. TJ asks, can you check the progress on a database request to know when it's finished? Well, TJ, we have a couple of ways you can kind of get at this. First of all, when you write into the Firebase real-time database, you can attach an onComplete callback with your set request. This will let you know when the write is completed to disk. Alternatively, you can check out our Firebase real-time database profiler that we released just a couple of weeks ago. This will give you granularity at a path level into both the latency and the bandwidth usage. This way you can get a little bit more insight into what's going on with the Firebase real-time database. Thanks for the question, TJ, and check the links in the description for more information. Next question.
Lighter.
Our next question comes from Se-Chun Kim. What's the limit of Firebase projects that can be created? Well, Se-Chun, it depends. We don't actually publish or document the limit of projects that can be created, since that number actually depends on inputs from our spam and abuse teams. However, a couple of things to note. First, billing accounts or paid accounts don't count towards this limit. So if you're having trouble, you can upgrade to either our Flame, which is our $25 a month plan, or our Blaze pay-as-you-go plan. Also, if you're still running into trouble, please reach out to our support team and they can help you raise that limit. Check out that link in the description below. Next question. Charles asks, where do you see Firebase in 5 years? Well, Charles, in 5 years' time, we're still going to be creating great tools that make developers' lives easier. Software is playing a bigger and bigger role in society at large, and we want to help the people creating that software. We'll do this by allowing them to focus on solving their customers' problems, by letting them not focus on low-level infrastructure, by not making them stitch together a myriad of growth tools. While I can't comment on specifics, I can give you a few general areas of where we'll be focusing. The first of which is more deeply integrating with Google Cloud Platform. This lets developers start with Firebase and then move seamlessly into Google's public cloud offering. Second of all is a focus on machine learning and integrations there. It's no secret that this is a big focus for Google. With integrations, we can intelligently provide recommendations to developers about next steps they can take to grow their app, or how they can better improve their app quality. It's going to be a great next 5 years for Firebase, and we're excited to serve you, our developers, as best we can. Thanks for the question, Charles. Our last question comes from Gabe, who asks, how has the culture of the Firebase team changed since joining Google? Well, Gabe, we were 23 people when we joined Google, and now we're more than 10 times the size. So things have certainly changed a little bit. However, I would like to think that we've changed Google more than we've changed ourselves. Specifically, we've changed Google's processes towards building developer products, trying to bring a focus on developers around the globe rather than just Google engineers. We've done this through things like one-on-one developer feedback sessions, through a lot of meetups, and through introspecting and dogfooding. By preserving this culture, we'll try and make developer offerings across Google better for you, our developers. So thanks for the question. That's all we have time for today, but thanks for all of your questions. Do keep them coming on Twitter, YouTube, Stack Overflow, and more with the hashtag AskFirebase. I'm James Tamplin, and we'll see you next time.
Hi everyone, Timothy Jordan here for one last interview, this one with Francoise, principal scientist here at Google.
Hi Timothy.
How are you?
Very good, and you?
I'm doing so good. The festival has been amazing, and we've had the opportunity to talk to a lot of people about what they do, and that's why I'm excited for this moment here, because you do some really cool stuff.
All right, yeah, it is cool, I agree.
So why don't we give everybody just an introduction to the work that you do around machine learning and input?
Yeah, so I work on speech recognition and I work on keyboard input. So speech recognition, you all know what it's about. Sundar has been talking about our progress in voice and how we've lowered our word error rate quite a bit, Google Home and all that. I've been working on speech for the last 12 years at Google, and then more recently, maybe last 2-3 years, I've been working on keyboard input. And you know, when people think of their keyboard, they think it's something very simple where they just take the mobile keyboard on their phone and they just tap, you know, the letters of what they want to spell. But in reality, if you want a good keyboard that really understands you and corrects your mistakes and predict the next word that you're going to type, it's pretty complicated. And there's a lot of machine learning that goes into keyboard as well.
Yeah, that's one of the things when you and I were talking about this earlier, is that that's a common misconception that like machine learning wouldn't apply to the keyboard because you're just hitting buttons, but that's actually not true at all.
No, it's not true at all. You know, keyboard is very interesting because it's such a complex product in itself because you can do a lot of things with a keyboard. You can tap on the keys, you can swipe what you want to write, and then you can even click on the microphone and then you can speak to your keyboard too, right? So the two modalities come together there. But doing a good job at correcting your typos, yet letting you type new words that the keyboard maybe doesn't know about, and then learn those words and those phrases for you, and then being able to predict the next word or the next phrases that you're going to type so that you don't have to type them. You can just say, oh yeah, that's what I meant, click. That takes a lot of machine learning. Yeah.
Awesome. You know, one of the other aspects of your work that I find really interesting is I end up talking to a lot of machine learning researchers that are just blazing new ground. It's really interesting, but it's like very theory and theoretical. But what you do is you have problems and you've just found that machine learning is a good way to solve them.
Right. So the way that I like to think about these problems is I have a technology to build, right? And it has many facets and there are many things that we need to optimize. It can be the machine learning, it could be the UI, it could be the infrastructure that's behind it that nobody sees. And so what we're really trying to do is to understand the pain points for the user. Where are the places where our users are wasting time, are getting frustrated? What are the places that they enjoy instead? And then trying to understand those problems, then we look at what are the right solutions for those problems. And sometimes the solution is just, you know, sweeping a parameter. And sometimes it takes like a really complex piece of machine learning. So we're just picking the technology that matches the problem that we have to solve, and we improve the technology one step at a time.
It's really interesting to kind of have that perspective of it's very pragmatic about machine learning.
Right, exactly, exactly. And I think it's a good approach because once you know exactly what, the hardest part is really figuring out what is the problem that you're trying to solve. And I think a lot of developers are struggling exactly with that same problem. It's what is it that I'm trying to solve, how am I formalizing that, and then what is the best tool to solve that problem.
Awesome. Yeah. So there's another aspect of your work I want to bring up. This is the last one, I promise, which I find really interesting, and you call it deep internationalization. Can you tell me what that is?
Yes. So, you know, as you may guess, I'm not a native US American speaker. I grew up in Belgium. Belgium is a country with French and German and Flemish. I learned Italian when I came here to the United States, so I care deeply about languages. And we have found, developing those keyboards, that a lot of countries in the world and a lot of languages are not well represented in mobile keyboards. What I mean by that is that there are a lot of people in the world, sometimes tens of millions of people, who speak a language and would like to write to their friends in that language, but that language is not supported on a keyboard. So what do? Either they go back to another language, so maybe I cannot type in French, I would go back to English because it's okay, my friends understand English too. But that's not what I want to do. I want to speak French with my family. And if we happen to speak a much, you know, more distant language that is not well represented, we wouldn't have the luxury of being able to talk to each other in our own language. So that brings us into this space where we think it's not just about bringing a few tens of languages into our keyboards and into Google technology in general. It's about hundreds of languages. It's about going beyond 1,000 languages. There are in the world 1,342 languages, according to linguists, that have more than 100,000 speakers. So you imagine, and if you go into even the deeper end, it would be in the 6,000, 7,000 languages. And so I really have a passion for bringing as many of those languages online as possible and progressively enabling technologies like speech recognition, keyboard input to more and more languages.
And the way you design an app is just a little bit different if you're trying to design for all of them, right?
Yeah, so the app itself, we try to keep things as general as possible because there's no way you can scale to hundreds of languages if your infrastructure is not general and your modeling methodologies are not as general and scalable as possible. And that's where machine learning actually is very helpful to us, because before we had machine learning to solve our problems, we would really hard code things, and you would see pieces of C++ code that would say, if language equal German, do this, right? And that's not what you want. There's no way to scale that. With machine learning, you essentially have the algorithms that are data independent and language independent, and then the data is the piece that contains the knowledge about the language. So now there's this nice interface between algorithmic work and data work. And so once you have the right algorithms, it's just a question of pumping data from different languages into them to create a new capability in those languages, and if you improve your algorithms, all the languages improve at the same time. So it's a really nice synergy as long as you can establish that boundary, and with machine learning, that's very easy to do.
Yeah, and it sounds very sort of, once you get the right perspective, things start to fall into place.
Exactly, you really want to build from scratch with this thinking of how am I going to internationalize my product, my technology, but not just to 5 languages, just to hundreds of languages.
Okay.
Yeah.
So I think that's about all the time that we have, but thank you
right.
so much for joining with me and talking about all this.
Yeah.
Is there anything else, like, say, if you could see some developers on the other end of this camera that would love to be doing the kind of work that you're doing now, what's some of the stuff that you'd tell them to get started on?
I think the best work that you do is really when you're passionate about the thing that you're doing. So I would think for each developer, if they are, and I assume they are, passionate about what it is that they're trying to develop, dig deep into it. Just don't be satisfied with something that's average quality. Keep digging and digging to try to understand your product the best you can and what your users want the best you can, and then keep developing from there, and everything will go well.
Awesome. Françoise, thank you so much.
You're welcome. Thank you.
All right. Hi all. My name is Chiara, and I am a developer advocate at Google. I have been working on the AMP project for the last year and a half. And today, I would like to show you how it's possible to build beautiful and interactive pages in AMP for e-commerce website and even beyond. And today, I'm going to share this presentation with other 2 speakers. Please meet Ambarish and William. Thanks, guys. And by the end of this talk, you will get a clear idea of what is available for you in order to build beautiful pages in AMP. So first of all, AMP stands for Accelerated Mobile Pages. It's an open source project who aims to deliver fast content on the web. AMP is built on 3 core components, and only the combination of these 3 will give you the super fast experience. First of all, AMP is a set of HTML tags that you have to use in your page. It comes from some limitations, like the amount of CSS is restricted. And third-party JavaScript is only allowed in iframes. Then there's the AMP JavaScript library, which implements all the best performance practices and manages resource loading on the page. And lastly, there's the AMP cache, which caches AMP pages, making them faster, and also validates pages. So then you always get valid AMP pages. So when AMP was started, it was limited in what it could support. In fact, it was supporting primarily blogs and news publishers. But during the last year, AMP has introduced new components that make now easy to adapt e-commerce website. And we already have some samples, like 1-800-flowers.com, Zalando, and AliExpress. And actually, we've seen a lot of adoption of AMP from retailers as the AMP format matures. So today I'm going to show to you which are the AMP components available in order to build those kind of pages. And I'm going to use 2 samples from the AMP by example website. So if you've never seen this website, it contains the most exhaustive set of AMP samples. So all the code that I'm going to present today can be found on this website. So let's jump to those samples that I've been promising you. Just one note that while I'm going to go through those samples, I'm just going to be focusing on components that are relevant for the e-commerce world. Let's start with a product browse page. You may be more familiar with the term product category page, but it's basically a page in which a user can land when searching something on the internet, like fruit. So as you can see from the GIF, we have some promotions on top, a list of items, and some recommendations. And the user can swipe throughout them. Let's start with the promotions. So as you can see, the images are playing by themselves. And we implemented this by using the AMP carousel component. So let's look at the code. So we have the AMP carousel component. We are using type slides, which means you're only going to see one image at a time. And we are using the autoplay parameter, which means that it's gonna, the images are going to play by themselves. And then what about searching? As I've never seen an e-commerce website without a proper search. So we managed to implement a search in the product browse page by using the AMP form extension. So if you look at the GIF, the user can type Apple, click search, and then a new page with the results appear. So the AMP form extension allows you to use the form and input tags. So then you can build such a search form. The second sample I want to show you is the product page. So as you can see from the GIF, we have some images on top, we have selections like color, quantity, size, and some more information at the bottom. Let's start with the image gallery. So again, here we used an AMP carousel. And this time we wanted the user to be able to swipe from left to right or right to left. So this is the code, very similar to the one that we just seen, this time without the autoplay parameter, and again using the type slides. Just below the image, we added a refinement section in which the user can select the color, the quantity, and the size. You can implement a selector in AMP by using the AMP selector component, which allows the user to choose from a list of options. And these options are not only limited to text, they can also be images. And what it happens is basically once a user chooses on an option, the selected attribute is going to be added. And actually, with the AMP selector component, you can even realize a tabbed panel. As you can see from the GIF, we realized a tab panel in which the user can click on About, Specs, and Size, and the content changes. So we implemented this by using AMP selector together with a CSS trick. So when I say trick, I mean that we have the AMP selector, we have 3 groups of divs. Each group contains 2 divs, one for the button and one for the content. We hide all the content at default. And when the user clicks on a button, the content which is immediately below the button is going to be shown. And you can also implement a shopping cart in AMP. And note that this wasn't really possible when AMP was launched. So let's look what we achieved in this sample. So the user chooses a color, a quantity, click Add to Cart, and then a new page showing the shopping cart appears. So again, we used the AMP form component in here, and as I said, the AMP form extension allows you to use the form and input tags. But I would like to catch your attention on the client ID variable. So this variable allows to create a unique identifier for the user that then you can use to identify the user when you send the request to the server. As an alternative to a shopping cart, you could, on Chrome, you could also implement a Buy Now button by using the Payment Request API. So you may have heard about Payment Request API from other talks here at I/O. But basically, they allow requesting payments informations directly from the browser. In this case, you need to use an AMP iframe, use the allow payment request attributes, and then all the logic for the payment is going to be inside the iframe. And just at the bottom of the page, you can add some recommendation for the users. And the best way to achieve this is by using the AMP list component. So AMP list fetches results from a course JSON endpoint and then shows them by using a template. So AMP supports a set of templates, and for these samples, we used AMP Mustache. And moreover, I would like to say that the AMP list always allows you to get the latest and the freshest content to your page. So in the samples that I just showed, we also created some advanced interactions. These kind of interactions were not really possible when AMP was launched. So now I would like to show you some of them. And at the end, I'm going to tell you how we implemented those. So on desktop, we added a thumbnail gallery together with the image gallery. So when you click on an image from the thumbnail gallery, the image on the carousel updates. And at the same time, when you click on an image from the carousel, the thumbnail images get focused. And notice that the page is not reloading at all. We've also been able to update dynamically the carousel image by clicking on different colors. At the same time, the price just below the image is changing when clicking on different colors. And if you remember the related product section, we also been able to add a Show More button, which is going to load more items from the server and add them to the page, again, without doing any page reloading. So at this point, you may be wondering how we achieved this kind of interactions. And we used the AMP bind component, which at this point you may have heard from other talks like the AMP keynote. But it's basically a new component available under experiment in the AMP library, which allows you to create interactive pages. And to tell you more about this, I would like to invite William to the stage.
Thanks, Chiara. Hi, everyone. My name is Will. I'm a software engineer at Google. And I'll be going a bit more into detail about this AMP bind thing that we've been working on. So first, let's quickly review the motivation behind the feature. As Chiara mentioned, AMP components, like AMP carousel, can offer rich interactivity within the scope of a single component. But what if you wanted to add custom stateful behaviors or interactivity between AMP components and regular HTML elements? In the non-AMP world, web developers would typically do this with JavaScript. However, part of AMP's consistently fast speed is the restriction on just that. So what are our options? One option is to embed regular web pages containing custom JS into an AMP page via an iframe. But you'd lose the speed and other benefits of AMP when you do this, so that's not ideal. Or you could work with our open source developer community to build a brand new AMP component on GitHub. And for certain use cases, this is actually the right thing to do. For example, building a tweet button for sharing something on Twitter. However, building a brand new AMP component takes a non-trivial amount of work, so it doesn't scale particularly well if you have multiple custom use cases. Or you can use this cool new thing we built specifically for this, called AMP bind. All right, well, what is AMP bind? AMP bind is a new AMP component that supports custom interactivity through data binding and expressions. Don't worry if that sounds complex. It's actually fairly straightforward, and I'll explain exactly what that means. So you can think of AMP bind as being composed of three main parts: JSON state, data binding, and mutation of HTML elements. If you've dabbled in popular web app frameworks like Angular or React, this may feel familiar to you. So the first part is state, which is just JSON data in your document. AMP bind includes a new subcomponent called AMP state, which either wraps local JSON in the DOM or fetches it from a remote endpoint. In this example, we have an AMP state element with the ID foo, wrapping an inline JSON object containing a single key value pair. Now, data in AMP state elements can be referenced by expressions. For example, the expression foo.bar here would evaluate to the string hello. The second part is binding, or data binding. A binding is just a link between an HTML element and an expression, where the expression's result sets the value of a property on that element. In this example, the paragraph element's text content is bound to the expression foo.bar plus baz. This means that whenever the result of foo.bar plus baz changes, the paragraph element's text is set to that result. So again, expressions in AmpBind can refer to the state. And remember that the expression fragment foo.bar evaluates the string hello. Baz here is another variable that we'll define soon. The third and final part is mutation. Here you can see a button with a special on attribute. It's part of the AMP action system, which allows users to add simple event-driven behaviors, such as do something on a button tap. So AmpBind adds a new action called amp.setState, which updates the state with an object literal. Here we're updating the state with the key or variable baz. So put together, here's our hello world example for AmpBind. Quickly starting from the top, we have our state initialized with the amp state component, a paragraph element with a text binding, and when we update the state via amp.setState, the expression's result changes, which mutates the paragraph element's bound text property. The expression is foo.bar, which is hello, concatenated with baz, which is world. So tapping the button makes the paragraph element say hello world. So returning to our Apple example, it uses AmpBind to achieve the page reactivity shown here. Again, each color of apple has a different price and size availability, which is updated on the page upon user selection. So I'll just very quickly go over how this example works in the context of state binding and mutation in AmpBind. And don't worry if you don't catch every piece of code here. It's all available online with documentation at ampbyexample.com. First is state. We initialize the state with data about our apples, including price and size for each color of apple. Next is binding. We bind the text of the price label to an expression that looks up the price of the selected color of apple in our product data. Note the selected color variable in particular. And finally, mutation. We change the selected color variable via amp.setState. Now, the color picker uses the amp selector component we saw Chiara demo earlier, where each selectable element has an option attribute. We can reference those option values in the select event of amp selector to set the selected color variable. So the code snippets shown on these slides were simplified a bit to fit. The full code for this example, again, is on ampbyexample.com. There's a short link there for this specific example. AmpByExample also has many other samples of cool, practical usages of AMP. So one part we haven't talked much about yet are expressions. What are they? How do they work? Well, you can think of it basically as JavaScript syntax with a few caveats to keep things fast and safe. Kind of like how AMP is HTML with some caveats for speed and reliability. In AMP's spirit of ensuring fast performance, we've made sure that using AmpBind on your pages won't cause jank. One way we achieve that is by adding concurrency through web workers. So heavyweight tasks like expression parsing and validation are performed on a dedicated worker. This avoids blocking the main thread, ensuring a smooth user experience on pages that use AmpBind. Another cool thing is that it's Turing complete. So Turing completeness is an academic measurement of expressiveness of a programming language. Here's a Turing machine that counts in binary using AmpBind. The line of gray bubbles is the tape of the Turing machine. The color bubble is the current position of the tape head, and the step button is the crank that runs it. We built this demo in part for fun, and in part as an exercise to see how powerful AmpBind actually is. That being said, I don't recommend actually building Turing machine simulators on your AMP pages. But for interest's sake, it works by encoding the state of a Turing machine in an AMP state element, along with instructions for advancing the tape head and writing to the tape at any given state of the machine. And actually running the machine, again, is done by amp.setState in the step button. So hopefully this shows you that AmpBind is quite robust in practice and theory. So here are some more technical details. I won't run through every single one of these. One important thing to note is that we don't evaluate expressions at page load. In fact, AmpBind only executes in response to direct user action. This makes sure that we won't affect load latency of pages, and it avoids unexpected content jumping. The gist of this slide is to say that we've built AmpBind with the principles of AMP in mind. That is, it should be fast, safe, and easy to use. AmpBind is available today as an AMP experiment and slated to launch soon. We're working on making it more useful and adding more documentation and samples. And it's pretty close to being production ready, but we'd appreciate any feedback you guys might have. Just want to make sure that it fits your use cases, whether or not you find it intuitive. Just really want to ensure that AmpBind is practical and useful for you guys. We've also written a new code lab for I/O called Advanced Interactivity in AMP. It goes over some more of the advanced usage of AmpBind, focusing on the e-commerce use case in particular. Please check it out. Many merchants have already started experimenting with AmpBind in their pages. Here are a couple implementations from AliExpress and Wego. AliExpress in particular uses AmpBind in their product detail page in a similar pattern to the Apple example we saw earlier, with dynamic prices and available quantities depending on the user's selected SKU. Next, we'll hear from AK from Mintra.com on their experience with AMP and AmpBind.
Thanks, Will. I think, first of all, congratulations. I think you guys have survived I/O, or almost, I'd say, survived I/O, if you survive the next 10 minutes of my talk. But I think it'll be well worth it, because I'll talk to you about how we did AmpBind implementation in less than a week. Actually, we did it in 6 days and had the 7th day for rest as well. So let's talk about it. So before I go into it, I do want to sort of talk about the fact, just a little bit about Mintra, so that you know this is actually in production in a really large-scale company in India. So who are we? Mintra is the largest online fashion player in India. It's actually bigger than the largest offline player in India. These numbers actually are slightly old. I'm showing some press-safe numbers here, but we are larger than this at this point. 18 million monthly active users, 50 million page views a day, 5 million sessions a day, more than $1 billion revenue run rate. So this is done for an at-scale company in production, what you're going to see next. So let's talk about our journey through AmpBind. So the real problem that we had, why we sort of went looking for it, was that a lot of traffic for us comes on these list pages. I'm sure you have the same thing where folks click on something, I'm looking for Nike shoes or something else, and I land up on this list page, which has a list of products. Now, these pages were loading for us in 7 seconds, and that just was a long time, and we had a bounce rate of 30%, which, as you can see, is killing a lot of our business. So, and as you know, if you reduce the time, if you reduce page load, our estimate is, and we've looked at some of the studies here, if you reduce the page load by a second, you'll get perhaps 11% more page views on an average. If you say people are happy or unhappy, you'll see 16% better satisfaction, and probably 7 to 8% more, fewer conversion if you have, 1 second of page load delay. And India, as you know, 95% of the internet is mobile. Really, even though we have desktop, 90% of our actually revenues are from mobile. And the data speeds, even though they're increasing very, very fast, a lot of users are still on less than 3G speeds, which means that we have to overcome the bandwidth hurdle also through AmpBind kind of technologies. So let's talk about how we did it. So day 0, this is our product manager, Amit, and the engineer, Vijay. They're just thinking, can AMP be dynamic enough? Because AMP really was, as you guys know, was supposed to be for static pages, for content pages that were loading. And the second question was, the product manager, why he has his hand on the head there is that he's got like 20,000 other priorities, and he's trying to figure out how much time this is going to take. But I think AmpBind came to the rescue. And here's our sort of day-by-day journey on how we did it. And this is actually how it played out. In fact, on day 1, we were talking to Anuvrat and Eric and folks at Google and saying, can we even do it? They said, no, read the documentation. This will be actually in less than a week. So day 1, we read the documentation, built a very simple proof of concept. Actually, everything starts with a hello world kind of thing. So we built a quick proof of concept that worked out. And we said, OK, we can actually do this thing. Day 2, we did AMP list call to load results. But as with any project, we just hit this hurdle that these pages were slow to load because AJAX on the client side was not as quick. So we did server-side rendering. The page was less than 14 kilobytes, and it sort of downloaded pretty fast. So we crossed that hurdle. Day 3, this is where the real sort of interactivity came in, where we had search and sort and some dynamic elements on the page. And we had those working, and we'll show some of that fairly soon. Now, AmpBind at that point, and even it was experimental, but as we tried this out, it actually worked fairly seamlessly for us. So that, again, boosted our confidence. Day 4, now this is where sort of we start polishing it. We've got sort of a good thing running, and we started polishing the UX. And as we'll show sort of in a side-by-side video, you couldn't actually distinguish the AMP version from the non-AMP version once you started looking at it. Day 5, this is unfortunate to the reality. As you guys all know, analytics comes late. We think about it early, but it starts coming late. For us also, that's what happened. We started looking at analytics, added that in. And then the other interesting thing is, I don't know if you've heard of AMP accordions, but we've got this side navigation bar on our MWeb, and we used AMP accordion to create those, and we'll show you a little bit of code on that. And the last thing, we added some transitions for filters, and we're done. And like I said, the 7th day, we had the product manager and the engineer there. So let me show you a quick demo, of, it was tough to set up a demo here, but we shot a video back there a few days back of how AmpBind works with our old. So what you'll see, I think you'll see on your left-hand side, you will see the old page loading. On the right-hand side, you'll see AMP loading. You'll have to pay attention because AMP's just going to load before you blink your eye. Ready? Once the video loads. Okay. So that right side is where we've got AMP results, loading, done. Still waiting for my old stuff to load. And this is optimized, and yet sort of I think it took a long time. It is actually that fast. When we showed people, they were just surprised how quick it was to load. So I'd recommend you guys try it out. It's actually pretty cool. Thank you. Thank you to you guys. So this is I'll go through quickly with the code. I think you guys could sort of go in and look at the code. But I think Will talked about the AMP set state. So this is exactly, Will talked about the POC on the hello world. And now this is how sort of it really worked in the real world, where we set the state for saying, OK, but when somebody hits the search button, you go to the show search div, and it goes there, and we can show the search element there. Similarly, for the sort down there, we hit the sort, and it shows the sort div. And then we have the AMP accordion we talked about. So we have this side navigation bar, which this is part of the code for the AMP accordion. So you could sort of create a side navigation bar in AMP. So that's how you sort of do dynamic pages in AMP. So it's pretty cool that AMP was great because it was sort of loading up static pages very fast, but now you can do dynamic pages in a cool way. So that worked out very well for us. Now, what's next? I think every time you do something, you're looking at what you're going to do next, how you're going to improve. Now, we'll keep pushing the Google folks, and I think they'll keep pushing us, and we'll sort of build more stuff around this. But a few things that we are thinking next is, how do we modify the AMP list so that we can avoid page loads on sort as well as pagination, so that we have the next set of items sitting there, and we can point the AMP list source to those items. AMP service workers, that's interesting, and it starts working like a PWA, where we can launch the next non-AMP page content using AMP service workers. And I think this last point I wanted to expand on a little bit. I think a lot of time we think about whether you want to do PWA or AMP. And when we started off, we thought we were going to do PWA because there was a lot of sort of noise around saying, you should do PWA, everybody should do PWA. And we talked to Anurag, we talked to Eric, a bunch of other folks, and they said, what is your real problem? And our real problem was the list pages weren't loading, and there was a big bounce rate on those. And I remember that call where we were told, hey, you know what, guys, think about it. You want to load this page fast, and AMP works great for that. Once people have loaded that page, now you want to bring in PWA so that you can create an experience that is more app-like, and the next set of pages loads well. So I think it's not AMP or PWA, especially with AMP bind and this becoming dynamic. You could do both AMP and PWA together, and that actually brings in a great set of technologies to build amazing web pages. So that's sort of our story on how we did this. I'd like to invite Will and Kiara back on stage to close this talk. Thank you.
Thanks, AK. So beyond the e-commerce use cases we've highlighted today, what else can you do with AmpBind? Well, abstractly, AmpBind adds a layer of dynamic ability on top of your existing AMP components. And as we've seen, you can use AmpBind to add interactivity to regular HTML elements. So I think the possibilities really are only bound by your imagination. Sorry. But we're excited for all of you to try it out and see what you can come up with.
And really, before you go, we would like to leave you with some useful links about things we talked about today. So there's the ampproject.org, in which you can find all the documentation for AMP. All the samples that we've been using are on ampbyexample.com. And you can also find the documentation for AmpBind. And then, since it's the last talk of the day, I can't really tell you, come and talk with us in the sandbox area. So if you do have any questions, you can use the developer support. And lastly, there are some very awesome AMP videos on the AMP YouTube channels. So thank you very much for your attention.
Thanks, guys.
I was an HR. I was working as a recruiter, and I was completely unaware as to what I'm supposed to do. I used to feel that I just don't want to be a recruiter. I want to be on that other side, talking technology and talking about gadgets and how technology is changing our day-to-day lives. One of our relatives, he challenged me that you are a girl and engineering requires a lot of designs and drawings. I wanted to prove him wrong, and that was the time when I heard about Udacity. I started taking some online courses in Java and Android, very basic things. It is little difficult, but it's just that I don't want to feel that, that sense of regret. I just don't want that. So Udacity has actually been a savior in my life. The quality of the projects is very good. It's like, after completing those, you feel like you have conquered something. Actually, I finished my nano degree yesterday, and so today it's just going to be the celebration.
Did you know that the average user has 36 apps on their device and doesn't use 3/4 of them most of the time? And of those, about 1/3 of them have only ever been used once. Well, what if that's your app? You've done the research, you've written the code, you've performed the testing, you've perfected the design, you've gotten the installs, and then nothing. So, how do you prevent this? App indexing helps you re-engage with your users through tight integration with Google Search. As well as appearing in search results, it surfaces your app through autocomplete and now on tap. All you have to do is get your app in the index. And when users search for the content that's already in your app, they'll be able to see your app directly in the search results and be able to launch it right from there. It's as easy as that. But how does it work? If your app and site have similar content, you associate them with each other. Then, your app can receive incoming links from search. On Android, these are achieved using standard Android app links, and on iOS, using standard iOS universal links. When a user searches for your content, they can then find your app. If you have the app installed, it will allow you to link directly to it. When the app launches, it sees the address of the index content and decides which screen to load to show it. It's really as easy as that. You can also use the App Indexing SDK to submit content to the search engine based on how people use your app content. When people use your app, your search position can be improved. With app indexing, you get into the index, putting your app into Google search, and allowing you to re-engage your users.
This is Ask Firebase, a show where we answer all sorts of Firebase questions on whatever medium you ask questions on. We take those questions, we give you answers. It's a show. Let's get into it. Ask Firebase. Take one, Mark. Hey folks, my name is Abe Haskins. I'm a Firebase engineer here in San Francisco, and I'm here to talk to you about Firebase for Unity. If you haven't already seen it, I did a Getting Started video for Firebase in Unity. It'll be linked below. But in the meantime, I want to talk to you about some of the great questions we've gotten since we released the Firebase SDK into general availability a few weeks ago. Also, unrelated, but if you want to call me Abe, that's great. You want to call me Abe, you want to call me literally anything, I'm okay with it. As long as it starts with an A and has some letters after it, we're all good. Let's dive in. That's not nice. Let's get started with the first question from my laptop battery is dead. All right, first question. On our last YouTube video about Unity, 7Madara1 asked, can I use this to build out WebGL games that I've developed in Unity? And the answer is no, you really can't. Since the Firebase SDK for Unity is built on the Android SDK and the iOS SDK, we don't have the ability to build out for WebGL or PlayStation 3 or some of these other platforms that Unity supports. You'll find that some of the features do work, and even in the editor, they're stubbed out, so you'll be able to use them and test your code and compile it and everything like that. But you won't get the same functionality you would if you built out the game for the device. Thanks for the question. Next question. On the Firebase mailing list, DeepPixel asked, why does my app report libapp.so cannot be found? This is actually a great question, and it's related to another issue we've gotten on GitHub from Sakura777. He said, why is Firebase app not able to be found? These issues are both related to the timing of when Unity imports the dependencies it requires to run the Firebase SDK. In some environments, you're just gonna luck out and you're not gonna have to deal with this, but it just depends on your specific game and your specific operating system. So what you can do is, one, make sure you're on the latest version of the Unity plugin. We've pushed some changes that should help this for a lot of people. And two, you can go into the assets folder and go to Play Service Resolver, Android Resolver, Settings, and there's an Enable Auto Resolution checkbox. This is just going to do some extra things to help you get those dependencies imported and help control that timing so everything's going to work well for you. All right, and if you do that, your issue should be solved. Thanks a ton, Sakura and DeepPixel. Next question. The next question is one we've been getting a ton. A lot of people want to upload different assets for their game into Firebase Cloud Storage. They want to upload images and text, all of these great things, movies, etc., all those things you need for your game. You know the stuff. They want to upload those into cloud storage and then retrieve them in their game and just, use them in the easiest possible way. The Firebase Unity SDK is really good when you're dealing with these storage assets because you have a lot of control. You can download them as streams or you can download them as a byte array. But you don't have to really do all of that if you're not interested in dealing with those more complex flows. The absolute easiest way to get an asset out of cloud storage, rendered or consumed in your game in some way, is to use the W package and the get download URL async method that we offer. With that method, you'll just get a normal URL. It's a public URL that you can consume and pull down just like any other URL. And the W package in Unity makes it really, really simple to take that URL, download it, and turn it into a material, turn it into an audio clip, even a movie. So any of those assets you upload in cloud storage or your users upload, if they're uploading profile icons or anything like that, you just pull them down with W and you'll be good to go. If you want to find out more about the W package or how it works with the get download URL async method, you can check out our documentation or the Unity documentation. Both are great resources for this. Thanks a ton for that question, everyone who asked it. I appreciate it. Next question. You guys have no idea how much I spend on conditioner to get this volume. And the final question, the big one we all want to hear about, Cloud Functions. I'm sure you heard at Google Next we announced this awesome thing, Cloud Functions. How does that work with Unity? What can we do with these two things put together? And the answer is you can do like anything. If you check out the repo we have a function sample repo, and this isn't specific to Unity, it's just our general function sample repo. It has 26 different examples of things that functions can do. And every single one of those you could do with the Firebase SDK in Unity with Cloud Functions. And that's because Cloud Functions ties into your real-time database. It ties into analytics and storage and all these other Firebase services that are supported in Unity, and it lets you execute code and change things way back on our cloud so you don't even have to think about it. So if you want a game that interacts with an external API, or you want a game that has some custom authentication that you've brewed up in your awesome game development shack, you can do this with Cloud Functions and you don't have to worry about scaling or anything like that. So you can absolutely use Cloud Functions with Unity, and it's highly, highly recommended. So go check out that repository. It's got a ton of different samples and every single one will work great with Unity. Thanks for the question. All right, everyone, thanks for watching. That's going to wrap up this Ask Firebase featuring Unity. If you have any more questions, obviously you can leave them in the YouTube comments below, post them on Stack Overflow, tweet them on Twitter with that hashtag Ask Firebase, or literally reach out to us in any way. Tweet at me, tweet at Firebase, shout it at the top of your lungs near a Google office. We will hear it, we will answer your questions. We'll see you next time.
Hi, I'm Timothy Jordan, and I've been your friendly developer advocate here at Shoreline Amphitheater for Google I/O 2017. For the past 3 days, we've been checking out all the really cool in-person experiences that you might have otherwise missed if you were just watching the session videos. I hope you enjoyed them as much as I did. And if you'd like to see anything again, check out g.co/io/guide. And hey, maybe next year you can join us here in person. I'm Timothy Jordan, and I'll see you at Google I/O 2018.